Ladies and gentlemen, the chairman of today's function, our chief guest, our guest of honor, and all the dignitaries have arrived amongst us. Within a short while from now, we are going to have the inaugural ceremony of the International Conference GOLD-CT 2024, Global Opportunities for the Development in the Field of Chemistry and Technology. प्यार की एक हंसी फिजा तो चले, कोई पत्ता हिले, हवा तो चले, आओ बैठो जरा सी बात करें, कौन कैसा है कुछ पता तो चले. A very important announcement before we start the inaugural ceremony. Kindly switch off your mobiles or put it on the silence mode. It should not be on the vibration mode because the sound affects, and that is the reason why either it should be switched off or silenced. Now, we begin with Vidyapeeth Geet of Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. Kindly stand up for the same, sorry.
शिवाचे मंदिर सुंदर विद्यापीठ महान विद्यापीठ महान समता ममता स्वातंत्र्याचे नांदो जगीनाथे आत्मबलाने हो आम्ही आमचे भाग्य विधाते लाभो करुणा आणि पाय सदा मंत्र सोहा एकच हृदय एकच हृदय एकच हृदय एकच हृदय
Friends, for ice breaking, now I request Professor D.H. More, Director, School of Chemical Sciences and Chairman, GOLD-CT 2024.
Good morning. The President of this event, Honorable Professor V.L. Maheshwari Sir, Vice Chancellor Kavitri Bainabai Chaudhary, North Maharashtra University, Guest of Honor of Inaugural Function, Padma Shri Professor G.D. Yadav Sir, ex-Vice Chancellor, ICT Mumbai, Chief Guest of Inaugural Function, Professor Jonal Gada from South Africa, Vice President, Pro Vice Chancellor, Professor S.T. Ingre Sir, then Dean of the Science Faculty and Management and Commerce Faculty, the Registrar, Dr. Vinod Patil, then the convener of this GOLD-CT, Professor D.S. Dalal, coordinator, Professor Mrs. R.S. Bendre, organizing secretary, Dr. V.V. Gite and A.M. Patil, then the member of Management Council, Academic Council, Senate, directors and head, and Professor Mahulikar, ex-Pro Vice Chancellor, Kavitribai, KBC NMU Jalgaon, and all invited speaker delegates. Myself, Professor D.H. More, Chairman of this GOLD-CT 2024 and Director, School of Chemical Sciences. I welcome, on behalf of School of Chemical Sciences and KBC North Maharashtra University, to the beautiful campus of our university. Our university was established in 1990, and the School of Chemical Sciences was started in 1994. Our school is having 6 departments. 4 are applied: Department of Polymer Chemistry, Department of Pesticide and Agrochemical, Department of Industrial Chemistry, Department of Analytical Chemistry, and 2 basic courses, that is Organic Chemistry and Physical Chemistry. Our school has been recognized by DST FIST, UGC SAF. Our alumni who have obtained their PhD degree are working in a prestigious position in esteemed industries like UPL, Reliance, etc. at managerial level or upper level. The School of Chemical Sciences organizes regularly the national and international conferences. We have organized more than 20 conferences in the last 25 years. In 2014, the first international conference, GOLD-CT, was organized, and this is the second international conference of this year. Dear delegates, the conference is a testament to the power of collaboration across the border, discipline, and sectors. It is our hope that dialogue sparked here will lead to enduring the partnership and groundbreaking solution that will shape the future of chemistry. Our deepest gratitude to all participants, sponsors for this conference, all who worked tirelessly to make this event successful. Looking forward to stimulating and productive event that will push the boundaries of what is possible in the world of chemistry. I hope you will enjoy the deliberations and stay in a beautiful campus of our university. Thank you.
Thank you very much, Professor More. आज के रोज एक काम करें, आज के रोज एक काम करें, ये सुबह तजुर्बों के नाम करें. तजुर्बे यानी रिसर्च. आज के रोज एक काम करें, ये सुबह तजुर्बों के नाम करें. मैं चिरागों को फिर जलाता हूं, मैं चिरागों को फिर जलाता हूं, सब हवाओं का इंतजाम करें. Research is a challenge, and I'm very much happy that in the chairmanship of our Honorable Vice Chancellor, in the presence of our Pro-Vice Chancellor, in the presence of our registrar, directors, all the dignitaries, we have assembled over here from different parts of India and even abroad for this conference. Now, I'll request Professor D.S. Dalal, convener of GOLD-CT 2024, for the preface of the conference.
Good morning, all. Our beloved Vice Chancellor, Professor V.L. Maheshwari, sir, Padma Shri, Professor G.D. Yadav, sir, respected dais. It is our great pleasure to welcome all the resource persons, academicians, research scholars, participants from various universities, research institutes, colleges, and industries to the second international conference on global opportunities for latest development in chemistry and technology, organized by School of Chemical Sciences, KBC NMU Jalgaon. The main aim of this conference is to provide comprehensive knowledge in the field of catalysis, organic synthesis, green chemistry, nanomaterials, polymer science and technology, chemical engineering, agrochemicals, pesticide, environmental chemistry, microbiology, medicinal and pharmaceutical chemistry. The conference will offer an attractive platform for the interaction among the eminent professional researchers, scientists from different fields to discuss and share development in these areas. This conference has been organized to celebrate the academic contribution of Professor P.P. Mahulikar sir on his superannuation. We have organized this international conference with limited permanent stop and limited contractual stop within a period of 2.5 months. We receive overwhelming response from the participants with 40 resource persons accepting our invitation on short notice. Our participants and resource persons have become our brand ambassador. It is noteworthy to mention the support and encouragement we received from our beloved Vice Chancellor, Professor V.L. Maheshwari, sir. We also received the support from Dr. Babun Banerjee, Dr. Dinesh Sawant, Professor Bapurao Shingte, sir, Dr. Swapnil Sonole, and Mr. Ajay Khairnar. More than 632 participants till yesterday have registered. Amongst that, academician 194, industrial person 8, research scholar 237, and PG students 189 are attending this offline conference from 10 different states. Among that, 7 resource persons and 1 participant are from abroad. Professor Jonal Gada from South Africa, Dr. Rahul Suryavanshi from USA, Dr. Priyanka Makkar from University of Central Florida, USA, and Mr. Thibet from Yemen are present offline, while Professor Sohan Deval, South Korea, Professor Marticela Martinez, Mexico, and Dr. Satish Nimse from South Korea are attending this conference online. Padma Shri Professor G.D. Yadav sir will deliver a keynote address. Other invited speakers of the conference are highly experienced resource persons from the universities and institutes. The scientific program of this conference consists of 6 plenary lectures, 32 invited lectures, 69 oral presentations, 248 poster presentations. Considering the capacity of Senate Hall, 300, we have arranged 3 parallel sessions at School of Environmental and Earth Sciences, where invited lectures talks will be there. School of Chemical Sciences and Audiovisual Hall, all the oral presentations are in these 2 halls. And all the poster presentations are taking place in the Convocation Hall today itself. A cultural program is organized by our MSc student at the evening in the same hall. all the lectures from the Senate Hall are being broadcast live on our website, NMU website, for the benefit of non-registered students and learners. We hope you will enjoy the stay in KBC NMU hostel, guest house, faculty house, which are located in pollution-free and scenic campus. Some resource persons are accommodated in Jain Valley campus. It is our duty to acknowledge our sponsors, PM Usha, SCRB, CSIR, RSC, AAK, Britannia, Havmore, Jain Irrigation Limited, Krishna Pectins, Ferro Oil Tech, AGM Instrumentation, Omsynth Life Science, Creative System and Services Nagpur, and TCI Chemicals. On behalf of organizing committee of the conference, I express my sincere thanks to all the invited speakers and participants for attending this conference, and to the authorities of KBC NMU, our Honorable Vice Chancellor, Sir, Professor V.L. Maheshwari, Sir, Honorable Pro Vice Chancellor, Professor S.T. Ingre, Sir, and Dr. Vinod Patil, Sir, Registrar of our university, for providing all these facilities which you are observing. One important announcement at the last, that RSC is sponsoring 5 cash prizes for oral presentation and 5 cash prizes for poster presentations. In addition, Honorable Vice Chancellor, Sir, have permitted to sponsor some of the prizes, 3 prizes for oral and 10 prizes for poster presentation from the grants of conference. So prepare well, present well with confidence, and all the best. Thank you once again for your valuable contribution and participation in this conference. Thank you very much.
Thank you very much, Dalal sir. As far as the registration is concerned, the number of delegates is concerned, invited lectures are concerned, the canvas is concerned, this particular conference is ultimate. And I think when he announced about the cash prize, it's rare, please join your hands together for the organizers, for the administration, because it's one of the most important things for inspiring the young talent which is available in our country. Sir, मैं अकेला ही चला था जानिबे मंजिल मगर, मैं अकेला ही चला था जानिबे मंजिल मगर, लोग साथ आते गए और कारवां बनता गया. Now, I will request our dignitaries, our chief guest, to kindly formally inaugurate the conference by lighting the lamp. This will show us the light in the next 2 days, and after that, years after years. Atithi Devo Bhava. As per our tradition and culture, we welcome our guest in the best of the circumstances, best of the positions, and the time has come that we should now welcome our chief guest, our chairman, and other dignitaries present over here. First of all, I'll request Professor D.H. More, Director of the School of Chemical Sciences, to kindly welcome the President of the inaugural function of the conference, Professor V.L. Maheshwari, Honorable Vice Chancellor, KBC NMU Jalgaon. इल्म का ताज तो सर पर जरूर रखा है, इल्म का ताज तो सर पर जरूर रखा है, मगर खुदा ने तकब्बुर से दूर रखा है. Professor V.L. Maheshwari, the chairman of the inaugural ceremony and honorable vice chancellor of Kavitri Mainabai Chaudhary, Uttar Maharashtra Vidyapeeth, Jalgaon. Now I'll request the convener of the conference, Dalal sir, to kindly welcome the Pro-Vice Chancellor of our university and Vice President of the inaugural ceremony, Professor S.T. Ingle. खुदी को कर बुलंद इतना कि हर तकदीर से पहले खुदा बंदे से खुद पूछे, बता तेरी रजा क्या है. Professor S.T. Ingle, our Honorable Pro-Vice Chancellor. Friends, our registrar has taken out his valuable time. Dr. Vinod Patil is present amongst us at this moment. I'll request Gite sir to kindly welcome him on this occasion. Friends, the guest of honor of today's inaugural ceremony is Professor Jonal Gada SB from the University of KwaZulu, Natal, Durban, South Africa. Sir, you have taken out your valuable time, your benign presence over here. I'll request the Honorable Vice Chancellor, sir, to kindly welcome him on behalf of all of us. Thank you, sir. Thanks a lot. Friends, Professor S.S. Rajput, Dean of the Faculty of Science and Technology of our university, is present over here and has taken a lot of labor and effort to make this conference successful and being held. I'll request Bendre ma'am to kindly come and welcome him. Professor R.S. Bendre. Friends, you know, this conference is very much special because Professor P.P. Maholikar is going to retire and we have assembled over here to pay our regards on this occasion. I'll request Maholikar sir only to kindly welcome our registrar, Dr. Vinod Patil. Friends, as all of us know, the chief guest of the inaugural ceremony is Padma Shri Professor G.D. Yadav, ex-Vice Chancellor of ICT Mumbai. He has joined us online, and I'll request him to kindly formally declare the opening of GOLD-CT 2024.
Thank you so much. Are you able to hear me? Hello?
Yes, sir, you are quite audible. Just a second, sir. Just a second. There is a little bit technical glitch, and I'll be informing you within 30-40 seconds. Please, sir. Am I audible to you, sir? Yadav, sir? Am I audible to you?
I did not hear you.
Okay, please, sir. Please. Professor G.D. Yadav, Padma Shri, ex-director of ICT Mumbai, is the chief guest of today's inaugural ceremony, and he is going to declare the conference open online.
Yeah.
Yadav, sir?
Good morning. Yeah, I can hear you, and I hope you are able to hear me.
Yes, sir, you are quite audible. And within 30-40 seconds, I'll be informing you. Sir, your video mode is on? Yadav,
Yeah,
sir?
it is on.
Okay.
Yeah.
Just a second, sir.
Guys, can you see me?
Just a second, sir. Just a second.
It is on.
Yes,
It is
sir.
on.
Okay, maybe some technical problem from our end. We are just going to manage it. Please, sir. Please, sorry for that. Friends, we are going to listen to Padma Shri, Professor G.D. Yadav. Yes, sir, now you are visible.
I can see myself on the screen. Thank you very much.
Thanks.
Distinguished, dais, ladies and gentlemen, their fellow delegates, I'm very happy to declare that this GOLD-CT, very nice acronym you have chosen, 2024, which is organized in honor of Professor Maulikar, open. I'm sorry I could not be present there personally because I've been traveling since 1st of September, and only 2 days I've been in Mumbai. And again, I'm traveling from tomorrow onwards. And although Professor Dalal was insisting that I should be there personally, I could not, so I apologize. At the same time, I have so many restrictions. I have 2 commitments today, and he said that I should give a keynote address. Although I'm fully prepared for that, I have to leave my home at 11 o'clock. So I don't think I can do it today. But if you permit me, I will do it because I think your conference is for some time later. And so let us, please pardon me for not doing it today because I have to go out. There is another conference which I'm supposed to inaugurate, and there is another in the evening. There are 2. So I'm heavily loaded. But I must also tell you, chemistry is life. And so this conference which is organized is a great event, and I've been personally to this university on 3 different occasions. And I appreciate, in fact, I also came for the convocation of the university. So thank you so much for giving me this honor. I appreciate the university management, Professor Maheshwari, and the other dignitaries, and of course, Professor More and Professor Dalal for asking me to be there personally. I apologize once again since this program, and I also know the chief guest, I know him very well, Srikant Jogalanda from South Africa. I'd been to his university also. So I'm very happy that he's there and he's going to, deliver his talk. So ladies and gentlemen, I declare this conference open, GOLD-CT 2024. And please pardon me for not delivering my keynote address, although I'm ready right now. I'm ready with my talk. But I don't think once I start, I will not stop for almost half an hour. So that will jeopardize my next commitment. So please pardon me and ask Dr. Dalal to find a suitable time by which I can give this talk. But it has to be early morning. If it is tomorrow, 9 o'clock, I can jolly well do it because I have to catch a flight at 2:30. So if 9 o'clock tomorrow, I can do it, provided you are ready for this online talk. Thank you so much.
Thank you very much, sir. And definitely, as per the schedule you have suggested, we will be having your talk at that very time. Thank you very much. Thanks a lot once again.
Thank you so much. Thank you so much. I greatly appreciate this. Thank you. And you are a poet now. You are singing all the time this wherever I see you with the Urdu shairi.
Yes, sir. Yes, sir.
Inabai Chaudhary, some Marathi shairi should have been there. Thank you.
Thank you. Thanks a lot, sir. Your suggestion is taken up to the one. Thanks, sir. Thanks.
So allow me to leave the meeting. Thank you. Thank you.
Thank you, sir. Thanks. Thanks for taking out your time. And as per your suggestion, tomorrow between 9 and 9:30, we are going to have the lecture, the keynote address of this conference. Friends, now I must request Professor Jonal Gara SB from the University of KwaZulu-Natal, Durban, South Africa, for his inaugural speech.
Good morning, everybody. Respected Vice Chancellor, sir, all the dignitaries on the dais, and all the degrees of the dais, all protocols followed. It's a pleasure to be here in this conference. I thank Professor Dalal, for the initiative, and first time I'm in Jalgaon. And actually, it's a lovely campus to start with, and first time I'm coming, I felt very impressed with the greenery and the environment. To start with, I love attending conferences, actually, The reason is, it is said, in the old days, when we have no internet and everything, spending one day in the library, will save you 1 week's work, or sometimes 1 month's work. You sweat for a whole month, then you realize, that work is not viable, that you could have learned by spending some time in the 1 day in the library. That is the old time, but now, we have the internet and we look at a lot of information. Coming to the conferences, conferences, it is a must to attend. There are so many benefits out of the conferences, particularly for the younger people. I want to advise, the first thing, opportunity for you to visit a new place. Okay, I will talk about the new place later. When you come to the conference, interact with the people. It's what we call the networking, Networking is, the purpose of the networking is, not just to know and say hello, In the future, in the next 20 years, those people will be your collaborators and you will be working with them. You are taking advantage. That is the, of course, mutual advantage. But at the same time, coming to a conference, it saves you almost like a year's work. I tell you how, Most of the time these days, we have the poster sessions. That is where, young people interact and try to compare with what that fellow is doing, what this fellow is doing. That is one aspect. The main aspect of it is, how you do that and how you got those results. That is the, most of the times, when you look at the published paper, you never see those final details, what is the critical part of it and how you get the job done. That you never see in the paper, only the final results, and they discuss about what it means, But when you come to the conference, that is where you talk to that guy, but I tried that 20 times, why it didn't work, Then that fellow said, why you allow the temperature to go beyond 30 degrees, that will work, That is how it works, and so simple, and you learn. That's why, attending the conferences is very, very important for you to sort out your own problems in your own labs through your peers. That is the second aspect. And then, of course, as I said, networking will be lifelong thing, The last thing is, when you come to a conference, don't go to the conference and just go home. You spend adequate time in that place and see all the places there around and learn about the people, learn about the culture. That is the thing, actually, to be scientists, that is the perk we have to attend a conference, If you are in the industry, you visit the places because of the business thing, But when academics, they won't effort to travel by themselves just on a holiday, But you can go with your families also when you attend a conference, And those are the aspects of the benefits of the thing, but at the same time, this conference, Professor Dalal has put a lot of effort to invite so many good people in the field, and I hope it will be of mutual benefit, and all of us will benefit out of this conference. Thank you very much for giving me this opportunity again.
Thank you very much, sir. Delegates, ladies and gentlemen, as all of you know, the inaugural ceremony is being presided over by Professor V.L. Maheshwari, Honorable Vice Chancellor of KBC NMU Jalgaon. I hereby invite him for the presidential address of this conference. अच्छे बुरे की तुमको खबर दे के जाऊंगा, कुछ सोचने की तुमको नजर दे के जाऊंगा, यारों मैं इस जमाने का तंगे तराश हूं, पत्थर को बोलने का हुनर दे के जाऊंगा.
Good morning. Namaste. The inaugurator of the conference, a very distinguished scientist, Padma Shri Professor G.D. Yadav. Our chief guest from currently residing in South Africa, Professor Srikanta Garu. Am I right, sir? Director, School of Chemical Sciences, Professor More, my colleagues, Pro Vice Chancellor, Professor Ingle, Dr. Patil, Professor Dalal, Professor Mahvlikar, Dean, Faculty of Science, Dr. Rajput, all other my colleagues on the university, all the distinguished resource persons, invitees, delegates, student friends. At the outset, let me extend you all a very warm welcome on this beautiful and serene campus of Kaviyatri Bainabai Chaudhary North Maharashtra University. I'm sure your stay is going to be very comfortable and academically productive as well. School of Chemical Sciences on campus is organizing this conference after a gap of almost 10 years. I remember in 2014 they organized GOLD-CT-1, and in 2024 now they are organizing this GOLD-CT-2. All of you would agree that the conferences, they provide an excellent platform for the peers, for the researchers to exchange their ideas. At the same time, they provide a wonderful opportunity for the young researchers, particularly students, to listen to some very insightful lectures in the current topics in their areas of interest. It also provides an opportunity to showcase whatever research findings you have in the form of posters or in the form of, brief oral presentations. For the sake of simplicity, let me categorize all type of researches into 3 categories. I know that it is an oversimplification of this statement of the issues, But for the sake of simplicity, for the sake of easy understanding, I am doing that. What are those three domains? What are those three categories? First is human food. Second is human health. And the third, which includes everything but these two, and we can put it, human convenience. And in all three categories, in all three domains, humans have made great strides, massive efforts have gone into them, and we have made tremendous progresses. If we analyze them one by one, let's say, start with human food. Of the various domains of agriculture, let's say, we made massive progress in terms of managing pests in our agricultural fields. Going from manual to mechanical to chemical to molecular ways of managing our pests. In case of human health, same thing has happened. We have made tremendous progress. From preventive, that is vaccine, to curative, that is antibiotics, to predictive, that is gene therapy, to regenerative, using stem cell therapies to regenerate some of the cells, some of the tissue types, or even organs in the laboratory. If you talk of human convenience, you can take a number of examples. We moved from incandescent lamp to tube light to compact fluorescent lamp to LED. We moved from, let's say, letter to telegram to phone to wireless smartphone. And there can be a number of these kinds of examples one can give. All three domains are important, all three categories are important, and there is a competition among these three. Each one is important. We have learned in a hard way how a small virus can bring the whole world on its knees. And it keeps reminding us that we need to keep doing research as far as human health is concerned. Our ever-increasing population keep reminding us that we need to remain invested in terms of time, energy, efforts, and research as far as human food is concerned. And now, can you imagine your life without a mobile phone? We are getting used to these kinds of conveniences so much that it sometimes becomes almost impossible to dream of, to live without these kinds of gadgets. So research is important. The bottom line is that research is important. But does it mean that anybody and everybody should do research? Research for the sake of doing research should not be done. And I share some 4 or 5, my ideas as to what should be done in research. As I said, a researcher, because there are so many young friends sitting in front of me, must have 3 P's. He or she has to have passion, patience, and perseverance. Whatever you are doing, whatever your topic may be, you should be passionate about it. Please remember, inherently research is slow moving. That does not certainly exclude the possibilities of breakthroughs and disruptive technologies. Inherently it is slow moving. So one has to have deep passion about the work that you are doing. Second, academic research is good, but along with academic research now, in the present circumstances, if we can incorporate, if you can orient your research, your topic, socially, industrially, commercially, it is going to be better. Third thing, that quality. Now we are talking so much about quality. Quality as defined and accepted internationally. Quality not the one that you are defining. And lightly, if the front row permits, I would like to share this thing. So what is meant by quality? See, a person goes for purchasing a hand fan, haath ka pankha, which many times all of us use when the electricity is not there. And he asked the shopkeeper that he needs the best quality fan. And the best quality fan available in the shop is offered at a very obviously heavy price. He purchases it, and fortunately the very second day it was put to use. Electricity went off, and the person tried to use it, and in the first attempt itself, the fan got dismantled, disfigured. So he was furious because he paid a heavy price for it. So he went back to the shopkeeper, as said that fan that you gave has broken. So it said, no, it should not be the case. It's a very good quality fan. Maybe you have not used it properly. But I used it properly, the way it is being used. How did you use it? He said, like this. This is the mistake that you made. It is not supposed to be used like this. It's a quality fan. You keep it like this and, move your... So, friends, quality not as defined by you, quality as defined and accepted internationally. Let me put it quantitatively. So how many research publications India as a country, as a nation, published during a given period of time, maybe 3 years, maybe 5 years, I'm not sure about that. It's 1.5 million, about 15 lakh. Way behind China and America, still it's a sizable number. We stand at number 5 in terms of sheer number, quantity. But in terms of quality, where do we stand? We stand at 153rd position. 153rd position. So 30% of our research papers have never been cited. So I think we need to take care of this. Fourth thing, now if we can incorporate innovation in our research, it is going to lead to wealth creation. It is going to lead to prosperity. So innovation means what? Something new, product or service, or an improvement in the existing product or service. And who is an innovator? Innovator sees what others see, but he thinks what others do not think. I think that is what makes a person innovator. So I think all my young friends, you have to have strong observation. You need to cultivate strong observation, comprehension, analytical abilities, along with creativity and common sense. And you need to awaken the innovator within you. So innovator will lead us to what earlier they used to say when I was a young researcher, publish or perish. From there to patent and prosper. Finally, in this increasingly regulated world, you need to protect your intellectual property, whatever research findings, whatever new things that you are discovering, by providing them legal protection, either in the form of patent or other aspects of the intellectual property. We are lagging far behind in terms of filing patents. We means India as a country, as a nation. Again, let me put it quantitatively. In 1 year, we filed something like 90,000 patents, 90, as against 4 million filed by China. 4 million means 40 lakh. Huge gap. Of these 90,000 patents that have been filed by India, only 20,000 have come from higher education institutions like this. And of this 20,000, 20% means 4,000 have come from 3 areas: chemical sciences, life sciences, and pharmaceutical sciences. So there is a huge, what you can say, vacuum, void in terms of filing of patents. All useful innovations, meaningful innovations, applied innovations should be protected legally, either by filing patents and things like that. So these are some of the things, in my opinion, every young researcher should keep in mind. So I'm sure this 2 days conference, the invited lectures and other planned activities are going to provide a lot of food for thoughts for these young researchers so that they can plan their future career and path forward in a meaningful way. I must thank the organizers for giving this opportunity to me, and I once again welcome you all. Thank you very much.
Thank you very much, sir, for your presidential address. You covered all the aspects related to research, the quality, innovation, and I'm pretty sure that all the delegates present over here, especially the young and budding researchers, will definitely learn a lot from your address today. Now I request Dr. V.V. Gite, Organizing Secretary of GOLD-CT 2024, to kindly come and propose a vote of thanks.
President of Inaugural Function, Honorable Vice Chancellor of KBC North Maharashtra University, Jalgaon, Professor V.L. Maheshwari sir, Vice President of Inaugural Function, Honorable Pro Vice Chancellor KBC NME Jalgaon, Professor S.T. English sir, our most valued Chief Guest of the function, Padma Shri Professor G.D. Yadav sir, ex-Vice Chancellor ICT Mumbai, our another valued guest of this inaugural function, Professor Zonal Gada, University of KwaZulu, Natal, Durban, South Africa, Professor S.S. Rajput, Dean, Science and Technology Faculty, KBC NME Jalgaon, Dr. Vinod Patil sir, Registrar, KBC NME Jalgaon, all other dignitaries present on the dais, ladies and gentlemen. I, Dr. Vikas Gite, is here to express vote of thanks with respect to the inaugural function of this second international conference, GOLD-CT 2024, on behalf of organizing committee and university as a whole. First, I must express my sincere thanks to our Honorable Vice Chancellor, Professor V.L. Maheshwari sir, for gracing this occasion. His presence, all necessary permissions and support in organizing this conference and giving valuable time for this inaugural function despite his very busy schedule. Further, I express our thanks to Honorable Pro Vice Chancellor Professor S.T. English sir for his presence and support in organizing this GOLD-CT 2024. I sincerely thank our Chief Guest Padma Shri Professor G.D. Yadav for kindly accepting our invitation and gracing the function. Now, I plan on record our thanks to our guest of honor, Professor S.B. Zonal Gada, for accepting our invitation and his presence and encouragement. I am also thankful to Professor S.S. Rajpur for his presence and gracing the occasion. I am also thankful to Registrar of this University, Dr. Vinod Patil sir, for presence and making availability of infrastructure and other administrative support, whatever is required for this conference. I am also thankful to all invited talk members, presenters, and participants of this conference for their presence and participation in this function. Last but not least, I thanks to all those who directly or indirectly taken efforts and made this inaugural function grand success. Thank you.
Thank you very much, sir. Friends, this is the end of the beginning. The inaugural ceremony is going to end now, and immediately we are going to have a plenary lecture by Professor Zonal Gada. Please be here, and we'll be starting it very soon. Professor S.B. Zonal Gada has been a senior professor of chemistry at the University of KwaZulu-Natal, South Africa. And he has been the head of the School of Chemistry. Currently, he is working as Senior Research Associate and Emeritus Professor at UKZN. Previously, he worked as research associate at the University of Bonn, Germany. And he has worked on various faculty positions in different universities of India. With over 14,000 citations and H index of 55, Professor Jonal Gada has published 500 plus research papers, including 30 plus review papers. He is among the top 5 researchers of the University of Caen and was the lead researcher in 2017. He has got the distinction of participating in more than 170 plus research conferences in 48 countries, primarily as plenary and invited lectures. His research interests include green chemistry, heterogeneous catalyst, value-added conversions, and he has got a very good expertise in water chemistry. So I now request Professor Jonal Gada for the
check. Hello.
I hereby request Professor P.P. Vadgaonkar, scientist NCL Pune, to kindly chair this session of this international conference. Thank you very much, sir. Our chairman of this session, and the session is going to start with a short file from now after the permission of the chair.
Good morning, everybody. Can you hear me? Okay. Okay, this morning, it's a pleasure to be here, as I said, and I'm going to talk about green synthesis because the focus of the conference is green synthesis. I'm going to talk about binary oxides and novel nanocomposites as sustainable catalysts. I try to present some of our work, where we did use the catalyst and try to provide good results. And of course, we have been doing work in the other fields, like in the not only catalysis, also the microwave-assisted synthesis or the ultrasound-assisted synthesis, like that, various other things also. Here I'm going to focus on the different catalyst materials what we have used, and Okay. Before I start the chemistry, I want to take you back into the little bit of the history. You see the Africa. Africa is a huge continent, and you can see, it can accommodate almost all the USA, Europe, India, China, Great Britain, everything, It's such a huge continent, almost the rest of the world can be accommodated into that. And not only that, it has a lot of potential also, and it has always been exploited before the colonial people came to India. I want to share with you little bit of the history. You can see the Portugal and Spain on the top of Africa. The Spanish and Portugal people always, they have been quite good at the seafarers, and they have been trying to come to India, and the story of Columbus going to South America, trying to find the new way. But Portuguese people always tried to come to India, and they tried to come along the African coast, and many times they came up to what you call Ivory Coast. Ivory Coast is, now the Ivory Coast is, how it got the Ivory Coast is, the Europeans started to take away ivory from there, and that's how the name came the Ivory Coast. Okay? The next round they tried to come little further down up to Nigeria and Ghana, that is called Gold Coast. The Gold Coast, they found the gold mines in, actually mainly in Ghana, and that's why it's called Gold Coast. Like that, many sailors have come and went back, and Vasco da Gama started his ship with one of the king's best ships. He came to on his journey. He came all the way, came to the bottom of the Africa. That is the point, when he came to the bottom, when he saw now he can go upwards, that point is called the Cape of Good Hope. In our history books, you see, he came by the Cape of Good Hope to India, and he came to Cape of Good Hope and then came across to the other side of the southern part. He came to Durban. Durban port is an actual port. When he came there, and he came on a Christmas day. Christmas in Portuguese is called Natalia. That's how he called, this is Natal. And then he came upwards, he came up to Kenya. There he met the Indian business people coming from Gujarat, already doing their business along the coast, along the Arabian coast and all the way up to Africa. No, I'm not talking about what they were transporting, that is a different issue. He found them and he followed the ships of business people, and in his own writings he said that, their ship was 10 times bigger than his own ship. Compared to Vasco da Gama ship, the ship coming from India was 10 times bigger. That time you can imagine, what sort of prowess the Indian people have. And finally, he followed the ship and he didn't go to Gujarat. He went further down to Kozhikode. Kozhikode is the present Kozhikode. He came on 1498 on May 20th. May 20th he came, and then he went back. After 2 years, he came with 20 ships. He came with 20 ships, and the business started, and the history, all the way the colonialism, and not only India, all the Southeast Asia and everything was colonized by, they shared, all the European countries shared India and the other countries, as their colonies. And now, that is I stopped the history there, now we start for the next one. Okay, now, okay, that's great help, And now, considering, 12 green principles of chemistry, and I need not to go through these 12. You can see that, atom economy and minimizing the hazardous chemicals, safer solvents, and energy efficiency and renewable green stocks. minimizing the derivatization, and all these things, most of these things we can achieve by catalysis. We can achieve all those green principle catalysis. I'll show you some of the examples. And we know the catalysis, it's homogeneous and heterogeneous catalysis, and including the enzyme catalysis, homogeneous catalysis. And heterogeneous catalysis, as we know, the reactants or the catalysts can be of different phase. When we compare the two, homogeneous and heterogeneous catalysis, homogeneous catalysis has been there all the way, and heterogeneous catalysis also has been all the way. Now the thing is, nature, most of the reactions occur through heterogeneous catalysis processes on the surface reactions, Now coming to homogeneous catalysis, normally they are high selectivity, robust to the poisons, mechanisms are better understood, you can do under milder conditions, and all this one, and good reaction rates. And the difficulty is they're expensive, not expensive because they can't be separated, the process becomes expensive, and they have the short service life. You can't reuse them that easily. When it comes to heterogeneous catalysis, the main advantage, easily you can separate the catalyst, and it can be reused and recycled. But the problem with that is, normally lower selectivity that depends on the catalyst, and sensitive to the poison. This is particularly true when you have the high pressure, high temperature reactions. Normally moderate reaction conditions, this may not be an issue. And normally mechanisms are not that well understood, although you can get the job done. Now, if you can improve the process, that means, if you improve the selectivity, and then, we can improve the energy requirement, you can use the heterogeneous catalyst as good as the homogeneous catalyst. Now, when it comes to catalysis, all of us know it accelerates the reaction. What is a good catalyst? The good catalyst is the one which gives only single product, none other than what you want. When you have got many reactions, if every reaction can be catalyzed by the catalyst, it's no good catalyst. It has to do the job only specific so that it can cut down the other reactions and allow the single product. That's why, what is the, selectivity is the most important thing, and then the efficiency of the reaction and able to work under mild or severe conditions, what is its environmental impact, and the scope of recyclability. I'm going to talk about the mixed oxides and the nanocomposites and try to show here, although I show you number of reactions, my focus here is to show you the different catalysts, what we have used, type of the catalyst. Why you use the mixed catalyst? Why can't we use the metal oxides? Metal oxides are very good catalysts, all of us know. Each metal oxide is a good catalyst. Why you use mixed oxides? On that, the simple example is, when you have a multi-step reaction, which has to happen in one pot. That means, not one conversion, many conversions have to happen. The catalysts have to have different efficiencies. And I give simple example, if you have got some work at home to do, you need an electrician and a plumber. You need an electrician and plumber, and if you bring both of them, the job is finished. Instead of that, if you decide to bring 10 electricians, no plumber, or otherwise 10 plumbers, no electrician, job is not the same perfect as it is by bringing the both. Exactly that happens when you use the mixed oxide. Mixed oxides, you have the whole periodic table, you have got the materials, the acidic nature, basic nature, amphoteric nature. The combination of the materials you choose, you can design the properties, otherwise, vary the properties of your catalyst so that you can achieve what you want to do. Now, another advantage of that is, compared to the mixed oxides, compared to the single oxide, mixed oxides, they can last longer and their catalytic efficiency can be retained longer period, And that's why, you can, by optimizing the conditions of preparation of your catalyst, you can achieve better results. And you can apply the catalyst in various conditions. I'll show you. Okay, another thing is, nanomaterials. Nanomaterials is the one, which is very important. And this technology, we know, we can see human hair is, 100 microns. And we can see with the naked eye. And 1 micron, this size, we can't see bacteria, we can't see, all of us, we know we can't see 1 micron. The smallest what we can see is about 30, 40 microns with our naked eye. We can see with our naked eye up to 30, 40 microns, And the simple example is, when you are sitting in a room and see a beam of the light and the particles moving. Those particles moving, that is what we call is the Brownian movement. Brownian movement is possible only when there is no gravity. The gravity, normally, if you have the 50 micron size, the gravity will affect and the molecules won't move with Brownian movement, they settle down. That's why, you can see up to 30, 40 microns with the naked eye, and those particles you can see. And then our purpose here is, normally nanotechnology we use, while it is there everywhere, in our catalysis we use nanomaterials. One of the active material on the surface of the other material. That's what our approach is. And we use the nano material so that it can be efficiently work. While talking, just for precaution, although nano is good, nano also is toxic. We have to be careful how we use the nano and how it will end up, And in our own body parts, there are so many nanoparticles which can harm you. The simple example is, asbestosis, which now the asbestos is banned because of the nanoparticles of asbestos going into our lungs and bringing you the problems. Now, importance of nanocatalysts. Nanocatalysts, as you can see, now we have the catalyst. We talk about the nanocatalyst. Nanocatalyst, catalysts in the nano-sized particles we use. That is, we use the different material of the nano size as the active material. And we can use the different things. Now here in this one, we can see different materials of the pore size, both as the active material and also as the support material. I'll show you some examples. And we have got variety of the materials that can be used both as the active and also support material. And green synthesis, the same principles of green chemistry, we can see high selectivity and available material, and cutting down the number of steps. We talk about the one-step reactions, safety of the reaction conditions, excellent yields, and environmental friendly conditions, no waste, and atom efficiency. These are the things, and I will try to show you the reactions, how we achieve all those things by using our methods. Now, I want to agree with you, one step is not suitable for everything. There are many excellent organic chemists who do the comprehensive total synthesis. I'm not talking about that. I'm talking about one-step reactions where it is possible, where we can achieve the results. Here in this case, we used silver on zirconia. We did a lot of work on zirconia, and zirconia has got large surface area. And now, using silver on zirconia, in this particular case, we did the minopyrimidines. Synthesis of that, it is a 3-component reaction using the catalyst, ethanol as the solvent. Reaction is at room temperature. In 30 minutes, you get the products. In 30 minutes, you get the product, and the yields are, from 90 to 96% yield, and 12 novel compounds have been synthesized. And all these are the new compounds, as I said, and similar reactions have been reported in the literature with sodium hydroxide as catalyst. In 6 to 8 hours, you get 45% yield. Here in this case, you see the reaction in less than 30 minutes with 90 to 96% yield. And in every reaction, as we know, although we put one slide, that indicates, how you choose the conditions and optimize the conditions. In this particular case, we tried to load different loads of silver on zirconia, 1%, 2.5%, 5%. You can see 1% it is finely distributed and 2.5% finely distributed. When you get the 5%, there is agglomeration occurring, although we put more, still the molecules and nanoparticles are agglomerating. That's why we found 2.5% is the effective size, and it gave us the good results. Like that, I'll try to show you many reactions here. Ruthenium on zirconia, and in this case also you can see a 4-component reaction. A 4-component reaction, that the reaction conditions, ethanol at room temperature in less than 20 minutes, you are getting functionalized pyridine derivatives, and although all these have got the bioactivities also, I'm not talking about that, and the particles, fine distribution of that, 90 to 96% yield, and then in less than 20 minutes at room temperature. The similar reaction studied using a homogeneous catalyst triethylamine. As catalyst, it takes 8 hours to give 64% yield. Now here in this case, with our catalyst, we get 90 to 96% yield in less than 20 minutes. Quite efficient reaction. And in this case, here we used the zirconia, functionalized zirconia. It's a diamine functionalized zirconia. It's a 4-component reaction, and similar, we got very efficient yields. But this reaction is the water ethanol system. At 70 degrees, in 3 hours, you get 80 to 90% yield, and this material is recyclable multiple times. Now, here we have got another one. This one is, calcium hydroxyapatite as the material. Calcium hydroxyapatite, by loading the metal ions, it will have the amphoteric nature. And this one is, as you know, calcium hydroxyapatite is the material our bones are made up of, calcium hydroxide. And this material is quite efficient material. You can see 2 series of reactions, and you get 2 series of library of products. And quite efficiently in both the series, you get 88 to 97% yield at room temperature in less than 30 minutes. Now you see this one, the very finely distributed particles there, and these 22 molecules, you get 80 to 97% yield. And now look at it, very similar reaction under reflux conditions with ethanol as solvent and stannous oxide as catalyst. That means, already catalyst is used, but still it took 1 to 2 days to get 80% yield. 2 days of reaction, it is really testing your patience, And now, here in this case, in just, in short minute, less than 30 minutes, you get the reaction finished at room temperature and with excellent yields. This is another with hydroxyapatite. In this particular case, magnesium oxide loaded on that. You got a 3-component reaction and quite good results, 90 to 97% yield in less than 25 minutes, and very well recyclable, and ethanol and room temperature. Quite excellent reaction. And here we have this particular reaction is, nanocellulose on hydroxyapatite. And of course, it's not a multi-component reaction because of the new material we used. This condensation reaction is very good, 90 to 96% yield in less than 15 minutes at room temperature with ethanol as solvent. Quite good reaction, and although this reaction has been studied by many others also, but this one is quite good result compared to any other reported results. Now here we have got another hydroxyapatite with the natural material, and this one is, we used this 3-component reaction to generate the diaminopyran dicarbonitrals, and quite efficient yields, and you can see the very similar result, 80 to 96% in less than 30 minutes, and recyclable up to 6 times without loss of activity, and material is quite good. Now here we used a different support material, fluoroapatite on that bismuth oxide. In this 3-component reaction, giving you the 96% yield, 90 to 96% yield, all the less than 35 minutes at room temperature, and again, ethanol as solvent. And 98% atom economy. Most of the reactions have got 100% carbon capture. There is nothing is leaving, only water is the molecule living in the whole reaction of the three reacting. Now here we have got a different material. We have samarium doped fluoroapatite loaded on carbon nanotubes. And in this particular case, this one we have got results are quite good. In less than 10 minutes, 96% of yield of the triazoles, we get very good results. And at room temperature and ethanol as solvent, and it is recyclable number of times. Now, it's a very similar material. Here in this case, instead of samarium, we use the titania, and fluoroapatite and carbon nanotubes, a three-component reaction giving you 91 to 96% yield, less than 20 minutes. And interestingly, one may ask, why you should do so much of taking titania and fluoroapatite and again loading on carbon nanotubes. For that matter, titania, fluoroapatite, and carbon nanotube, all three are catalysts on their own. They all three can catalyze the reaction, but the product, what you get is about 60% or 65% yield, The combination of that is, allowing you to get 91 to 96% yield and in less time, that is like here in 15 minutes. Those reactions, single material also can catalyze, but efficiency is quite low. Now here, hydrotalcides. Hydrotalcides are another cheap material we use. Hydrotalcide is nothing but our what we call the talcum powder, the face powder. That one loaded with magnesium, vanadium carbonate, and multi-substituted pyridines. Three-component reaction in less than 1 hour. In less than 1 hour, we have got the same reaction. You compare that in 8 hours, 54% yield. The other reactions here, you get 94% yield in less than 1 hour at room temperature with water as solvent. And here, another hydrotalcide reaction. And this case also, you see a 4-component reaction in water at 80 degrees, very good yields of the functionalized benzenes. And you have this one, compared to the similar reactions, which gives in 6 hours 30% yield, you get in 1 hour 98% yield. And this is another pyridine on silver on gold on magnesium oxide, very efficient catalyst, 2 series of reactions giving excellent results. The same reactions reported with 30% yield in 7 hours. Now with this our catalyst you can get in less than 40 minutes. This is organofunctionalized graphene oxide and quite efficient catalyst, a 4-component reaction giving the products 93% yield, but reaction is 2 hours at room temperature and is recyclable up to 3 cycles. And here we have an interesting reaction, this one. Magnesium oxide and the reduced graphene oxide is a very good reaction, directly converting benzene into aniline. Normally, as you know, benzene is, you can't convert benzene into aniline, Normally you take nitrobenzene, and nitrobenzene is converted into aniline, But here you can do very cheap materials. In one step, you can convert into aniline at 70 degrees in 90 minutes. Single product, but the conversion efficiency is 77%, but the selectivity is 100%. And the next one is metal organo frameworks. That's a very promising field. And in this one, you have got multiple applications, and it can be used as in a variety of applications, and because of its properties and the spaces between the molecule, with that, you can see that different methods and different synthesis routes, and you can different structures of MOFs and different applications possible in the gas storage like CO2 or hydrogen storage, and in the optics, and in the drug delivery, and also in the catalysis that can be, they have been used, and in our case we used it as a catalyst Here we see the magnesium-based metal organic framework, the three-component reaction to give the products a 91 to 96% yield, and you have got very good results, 90 to 96% yield in less than 40 minutes at room temperature. And this is another reaction, similar, cadmium-based MOF, and you have the three-component reaction, you're getting less than 25 minutes, and room temperature. And here we have the coordination complexes, not the metal frameworks, but these are the coordination complexes, and we have got very efficient reaction of four-component reaction condensation, giving you the single product with 90 to 98% efficiency in less than 20 minutes, and no loss of activity up to 6 cycles. And this is another reaction, four-component reaction, and now I want to, here you can see this is an interesting reaction. You see the material is eggshell powder, normal eggshell powder. You're using the eggshell powder as the catalyst, a four-component reaction giving the products, excellent yields of the phthalate derivatives. This is quite a good material, 98% yield, 100% carbon efficiency, and this reaction, catalyst is so cheap. And next one, this one is with brick powder. With brick powder, you can efficiently do the reaction, and here again, you have a four-component reaction using the normal brick powder, excellent yields, 91 to 96% yield, and in the case of the eggshell and also the brick powder, why they work is, they're nothing but the mixed oxides, like here in case of the brick powder, you see different silica, alumina oxides, and small traces of calcium and magnesium oxide. That makes that catalyst quite efficient, and you get the results. And with all that, I tried to show you the number of reactions where you can get excellent results under very moderate conditions and applying all the green principles. And then finally, I want to thank the conference organizers, especially Professor Dalal for the invitation, and my university, which supports my trip, and all my students. Everywhere I have shown my name as the name, publisher. Nowhere my name appears as the first name. I put it just to indicate that is our work. There's only the indication. Otherwise, who actually did the work will have the first name, and some of our students and postdocs. And then finally, this is a message for all the youngsters. A man can succeed at almost anything for which he has unlimited enthusiasm. That is the most important, the zeal to have that success, and you will achieve that. And this one is coming from Durban, I have to show Gandhi lived in Durban, not in South Africa. He lived for 22 years before he came back to India, and most of the times he lived in Durban. This place is called the Phoenix Settlement, or the Tolstoy farm where he lived, and even now some of his family members live there. This is a museum. This is a museum where he lived, that now they converted that. This is not a replica of the original one. Original was burnt, and now it is a replica of that where he lived. It is, you can see that, and this is Nelson Mandela. And Nelson Mandela, this site is, called the Nelson Mandela capture site. Why it is important, this is where, he was caught and put in jail for next 27 years, before he is released before the independence. 27 years he was in the isolated jail, not in a jail in a place called Robben Island, and you can't escape from there, And then this is the site where they put this one. And of course, Durban beaches are famous, lovely beaches, warm water beaches all the time. Even the winter you can be enjoying, and water is normally safe. It is a blue flag beach by the night. This is the soccer stadium in Durban. And thank you very much for your attention again.
Friends, please join me in showing our appreciation to Professor. You know, what his presentation showed us is that research knows no boundaries. Research knows no boundaries. And he brought to us the cutting edge research which is carried out in South Africa, directed by an Indian to Indian audience. So, you know, very special appreciation to Professor for the excellent work which he presented to us. Thank you very much, sir.
So friends, before I request the chairman, sir, to call for the next lecture, all of you have the details of the conference. Parallel sessions are being held in the School of Environmental Sciences, Audiovisual Hall, and the School of Chemical Sciences. So accordingly, as per your interest, you can visit the places. Sir, please come. A small memento from the organizers of this conference. इसको सर अपने ड्राइंग रूम में बहुत प्रोमिनेंट स्पॉट पे रखिएगा ताकि हम लोग की याद हमेशा आती रहे. और in this particular session, I'll request the chairman, sir, to kindly present the memento and the certificate to Professor Janakal. Thanks, sir. Thanks a lot for your time, for effort. Now I'll request the chairman, sir, to kindly continue with the session.
A very good morning. Is it?
Please.
It's still a morning, so very good morning to each one of you here. Continuing with this session, I would like to invite Professor Babasaheb Sangpal. Of course, I have known him, from his PhD days. He comes from Shivaji University, Kolhapur. He completed his PhD from Shivaji University, and presently he is at VNIT Nagpur. Of course, I have been to his lab just few years back, and I was very impressed with the kind of work which he is carrying out in the cutting edge topics like supercapacitors, batteries, etc. So I would like to request Professor Babasaheb Sangpal to make his presentation. And the time allotted for presentation is 30 minutes, which will be followed by question answers.
Check.
Hello, check.
Hello.
Sir, please. Sangpal, sir, With the permission of the chair, please continue.
Now it is close to 12, so I have to say maybe good morning or good afternoon, right? So I wish to thank the organizer, Professor Dalal sir, for inviting me to give my research areas so that it can be explored well, so that new budding researchers, they can use these themes so that they can work upon device grade applications. So my topic it is there, that is nano-embedded thin films for solid state supercapacitors. So basically, whatever this conference it is there, that is a global opportunity for the latest development in the chemistry. So I belongs to physics, but we are doing some chemistry part. So it is called interdisciplinary research. So we are using some chemistry part to synthesize the material, and we are applying this material for the device grade application like a solar cell, supercapacitor, and the gas sensor. So basically, before going into the detail, I wish to explore my institute, that is VNIT, Vishweshwarya National Institute of Technology, which is a institute of national importance from the central government, and it is autonomous institute, and it is under the Ministry of Education. So basically, our institute is having different branches like engineering, architecture, as well as basic sciences. So after 12th students giving the JEE examination, they are entering inside these institutes for the different branches. Like applied mechanics, architecture, chemical, civil, different branches are there. So we are giving degree for BTech, MTech, as well as PhDs. And from the basic sciences, we have physics, chemistry, as well as the maths. So we are giving the degree MSc as well as the PhD. So those who are qualified the GATE or NET examination, they are getting the fellowship for the PhD. And also we have started now non-GATE admissions. Those are not getting the fellowship. Also we have also part-time PhD program as well. Along with this one, we have humanities, that is the also department, so that communication skill, which is very important, so that they can adopt for the communication skill as well. So whenever we are thinking about the device grade application, because my talk it is there, that is for more general audience, so that you can use this theme, so that you can develop certain things. Miss just Vice Chancellor sir said that not only publication it is important, so that you can think about the quality research, you can think about the device grade application. So afterwards you can think about the startup as well. So basically, whenever we are thinking about any device grade application, we have to keep 3 points in our mind. One is the material, whatever the material it is there, because you can make the lot of materials that can have a different forms. And in the previous talk, we have seen that the nano material it is very important, so that it can have a very broad area of the application whenever it is concerned to the human society. So materials that can be nanoparticle, you can think about nanomaterial in terms of the quantum dots, or maybe core shell type of the morphology, or you can think about the nanowire type of the morphology. But whenever we are thinking about any material, we should think about the synthesis route, how we are developing these materials. That is the most important concern. So whether these methods are low cost, whether it is simple, and whatever raw material it is easily accessible or available or not. For example, if I want to make the silicon type of the solar cell, silicon it is largely available in the sand. We can say silicon dioxide. But making that silicon from the sand, it is very, very difficult, because for making the solar cell, we should have the material which is very pure form. So extracting the silicon from the silicon oxide, it is very, very difficult. So we should think whenever we are making any device grade application, whatever the material it is going to be adopted, that should be with the lower cost. So synthesis method should be at the lower cost, and whatever process that you are adopting, that is scalable to the industry or not. Because finally, whatever device you are making, whether it is applicable for the society. So whenever it is applicable for the society, the device should be scalable. Means what? If you are making one device, it is maybe costly, but if you are making 1 lakh device, it is maybe cheaper. So industrialization or processing cost has to be included, and that processing cost should be very affordable to the common people. That is the most important thing. So whenever you are making the process, that should be scalable or not, and whatever the material it is there, which is at the lower cost or not, that is the most important part. Then also, properties depending upon what type of the application that is concerned. That can be electrical property, mechanical property, or maybe you can think about the structural property, right? That has to be well tuned depending upon the type of the device that you are making. That may be, for example, if you are making the sensor, that can be the optical property. So magnetic property or different properties are there that you have to keep in mind. Then whenever you are making any devices, three processes are going on. One is the synthesis. You have to make the materials, then you have to characterize the material, and then you have to apply the material. So only one subject or field which is not so important, but we have to think about the interdisciplinary research. For example, if you are thinking about the chemistry, as this conference, it is tied up with the chemistry, right? Chemistry, it is there where lot of synthesis of the material it is there. But whenever you are applying something, you should have the physics. But whether both are going in hand, then it is good. But whether it is enough or not, it is not enough, right? Because atwards, we can have the engineering as well as the technology, because whenever you are making something in the laboratory, it should be transformed to the industry so that it can be affordable to the common peoples. So this movie you have seen, 3 Idiots, that is Chase Excellence, Success Will Follow You. So I have made this little bit title different in terms of the nano, because chase quantum, nano will follow you. So try to make the quantum dots so that automatically you can get the nano materials in your hand. So what we have to do, that we have to do this, we have to use the simple things in a simple way, learn more, and it should be useful for the common people. And then you can do much more complicated things in a simple way. So that final thing it should be there, that should be applicable to the society. So our approach that we are adopting as this conference theme, it is there, it is the chemistry background. So if you are making the nanomaterial, we are making the nanomaterial in a thin film form. So size, thickness, we can say it is less than 1 micron, you can say, or maybe less than 2 micron, you can say. But whatever embedded thing it is there, inside this thin film, it is a nano, or it can be quantum dot. So there are 2 approaches are there. One is called as a top-down approach, it is there, and second one, it is called as a bottom-up approach. But whenever we are using top-down approach, size restriction or limitation and reproducibility, it is quite difficult. So what we are doing, we are using simple low-cost chemical method so that you can grow the material from the bottom to top, so that you can tune the morphology through the chemical method, through the different parameters which is assessed through the chemical method, and we are growing in the form of the thin film, that are the nanomaterials. Then these are the nanomaterials which is called as a lab scale nanomaterial for different diverse application we can concern. Then why chemical method? Because chemical methods are applicable for the large area. It can be very simple, it can be cost effective, it can be low temperature process, and you can work with the different type of the morphology that is called as a nanostructure morphology, so that we can play with this very different surface area as well. So these are the important aspects of the chemical method, as this conference theme it is there, which is basically belongs to the chemistry. So our group, it is working on like solar cells, like a dye sensitized solar cell, quantum dot sensitized solar cell, nanowire based solar cells, as well as we are working on the gas sensors, and also like dye sensitized solar cell, we have developed the colorful solar cell. I will show you one video at the end, and here you can see that these are the quantum dots. That is the CDS quantum dots, which is deposited by using simple solution chemistry. Nanowires also, it is deposited by using simple solution chemistry. But whatever part that is we have focused, it is for the device grade application. So basically, my talk it is for the supercapacitor, that is the energy storage devices. That may be a little bit new to the common audience. So supercapacitor means what? It represents the electrochemical energy storage devices, which is having high energy density than the ordinary capacitor, and high power density than the ordinary batteries. So energy means what? It is the capacity to do the work. And power means how fast energy it can be delivered to the application part. So supercapacitor, it bridges the gap between the capacitor and the battery. But present focus it is there, that is to improve the energy density so that it is possible to replace the batteries. So basically you have seen a lot of vehicles are coming as called as e-vehicles are there, right? So there you require the charging time, it is much more. So you have to keep that battery maybe for maybe 2 hours or 3 hours or 4 hours. So if it is possible to charge that one within maybe 5 minutes or maybe within 10 minutes, then it can have an added advantage. So that within the charging port, you can go there, maybe stay maybe 5 minutes, 10 minutes, you can take the tea during that time. If it is possible to charge your device, then it can run for a certain path, we can say. So advantage being for the supercapacitor, it is having high power density, long cycle life, then safe operation compared to the battery, because most of the batteries are there, like a lithium ion or different batteries are there where acids are going to be used. So these are the Ragon plot. First, it is called as a Ragon plot, where we can see that energy, specific power against the energy, so that you can differentiate between the capacitor and the battery through the supercapacitor. So supercapacitor, it lies between this middle part, and here you can see that battery, it is having higher specific energy, and capacitor, it is having higher specific power. In terms of the parameter, you can say charging time for the battery, it requires certain minutes to certain hours. And capacitor can charge very quickly. It can be millisecond to microsecond. But contrary, capacitors can discharge very quickly as well. It can be millisecond to microsecond as well. And battery, it can discharge for a longer time. So that longer duration where application it is concerned, that can be used. Now think about the energy density. Energy density for the battery, it is higher. And supercapacitor, it lies between that of the capacitor and the battery. So if it is possible to tune your supercapacitor or materials so that you can match your energy density as that of the battery, then maybe in the future it is possible to replace these batteries with the type of the supercapacitor in e-vehicle as well. And if you are thinking about the cycle life, because cycle life, we are using the battery, no doubt if you are selling any e-vehicle car or maybe in a household purpose it is there, main cost it is there, it is a battery. Because battery, it can withstand maybe 3 to 4 years only. So you have to replace that battery, either in e-vehicles as well. But in case of supercapacitor, if this cycle life, it is very high. It can be maybe 5,000, 10,000, or maybe 1 lakh as well. So cycle life means what? It can run maybe 6 years, 7 years, or maybe 10 years as well. So if it is possible to have higher energy density with very high cycle life, it is possible that this supercapacitor can work very well with the e-vehicles as well. So our this supercapacitor in Shanghai, you can see this is a case study. They are using this one company from the international company, it is there called Maxwell's, right? They are using this prototype of the supercapacitor in the electric bus. So here, when people are riding inside the bus, this supercapacitor gets charged. Then it can run for a certain kilometer, maybe 5 to 10 kilometer. Again, during that time, it can discharge. Again, in the next hall, it can get charged. So if your energy density it is higher, instead of just running 5 to 10 kilometer, it can run maybe 50 kilometer, it can run maybe 10 kilometer, 100 kilometer as well. So depending upon the energy density. So what type of the supercapacitor here they have used, it is liquid based. So where liquid it is contained. So if it is possible to think that your energy storage devices, which is a liquid free. So we thought to have certain idea to develop the supercapacitor, which is completely solid state, which is a liquid free device. And it is possible that if you are using liquid, and if it is possible to bend your supercapacitor, lot of mechanical or technical problem it is there. So if you are having the device which is completely solid state, it is possible to bend as well. So we thought to work on completely solid state as well as the flexible device so that it is possible to bend your supercapacitor. So these are the new advances it is there. For example, now you can see wristwatch it is there, or different flexible electronics are there, or variable type of the electronic it is there, where you require the flexible device so that it is possible to bend. For example, I am wearing certain cloth. If it is coat with the supercapacitor, it is possible to have flexible as well as the variable electronics type thing it is there. So this can be possible to tune up in the future market as well. And these are the supercapacitor where you can see with a very small size called as a micro supercapacitor. So that, for example, for different application, we can have a very small size of the supercapacitor so that you can use for the different application like medical applications. Then, if you are thinking about the supercapacitor, we have to understand the basic thing, and it is specially I made for the new youngsters so that they can understand this type of the supercapacitor. So supercapacitor, these are the two types. One is called as a EDLC type of the supercapacitor, and second one it is called as a pseudo capacitor. So EDLC means what? Where storage mechanism involves the charge separation at the interface. And mostly carbon-based materials are used for this type of the supercapacitor, like activated carbon, carbon aerogel, or you can say carbon nanotube. You can think about the graphene or graphene oxide it is there. These are used for the EDLC type behavior. And for the pseudo capacitor, where Faradic mechanism it is there, where reduction and oxidation it is there, right? Where metal oxides, polymers, and different type of the metal chalcogenides are there, where it is used for this type of the supercapacitor. But whenever you are thinking about the EDLC, as the surface charge reaction it is there, it is having low resistance. But it is having high stability, but on contrary, it is having certain limitation as it is with a lower capacitance. And whenever you are thinking about the pseudo capacitor, as Faradic reaction it is there, it gives very high capacitance, but it is having low stability. So each is having its own advantage as well as the disadvantage. Now new theme come up which is called as a hybrid capacitor, which can take one material from the EDLC and another material from the pseudo, so that you can make the composite material so that it can have very high stability as well as the high capacitance as well. So different type of the carbon nanotube, it is used like carbon nanotube, graphene, or maybe carbon aerogel, activated carbon. And here from this one, we have used carbon nanotube, which is having one directed conducting path with very high surface area. So whenever we are thinking about the energy density, because for the battery to replace, we should think about the energy density. So energy E equal to 1/2 CV square. C is the capacitance, V is the potential window, or you can say operational potential it is there. So inside this one, whenever we are thinking about energy density to improve, we have to improve the voltage, we have to improve the capacitance. So if we want to improve the voltage, we should think about the specific area, porous size, electrical conductivity, as well as the additional redox capacitance. And if you are thinking about increasing the voltage, sorry, this is for the capacitor, next one is for the voltage, you can use the ionic liquid, organic electrolyte, as well as the asymmetric or symmetric type of the capacitor you can assemble, so that you can increase the potential window. That is the operation potential window, we can say. So advantage of the being the composite, that we are using carbon nanotube with metal oxide or metal chalcogenide or maybe polymer, you can think, so that carbon nanotube, it is having high stability as well as the conductivity. And if you are thinking about polymer or a metal oxide or metal chalcogenide, it is having high capacitance. So if you are making the hybrid, which combines EDLC as well as the pseudo, which can shows the improved electronic conductivity as well as dual charge mechanism. But what are the material requirement for the supercapacitor is that it should have the high conductivity, large surface area, good chemical stability, good reversibility, as well as high valence state. So we thought to use this one in terms of the EDLC called carbon nanotube and coat with the different metal oxides, metal chalcogenides, or maybe polymer. So initially what we have done, we have used simple conducting substrate that is called as stainless steel, which is commercially available in the market. Then we have coated with a different type of the morphology called nanoflex, nanowires, or maybe nanoparticle or core shell type of the morphology. Also we have coated carbon nanotube. So carbon nanotube, it is EDLC, and we thought to coat on the carbon nanotube with the different metal oxides or polymers or metal chalcogenides, we can say, in the different forms, can be nanoflex, nanoparticle, maybe quantum dots it is there, or maybe polymer, so that it can be wrapped, these materials, in the nano form on the carbon nanotube. So as a simple thing that we are not fabricating carbon nanotube, we are using commercially available carbon nanotube, and we are using simple deep and dry coating technique to coat on the conducting substrate. So how we have done, we have made the solution of the carbon nanotube very homogeneous solution, right? Then after dipping, we are drying that one under the IR lamp, and depending upon the number of cycle, the thickness can be optimized, and this is the SEM image of the carbon nanotube which is coated on the stainless steel. On this one, we have tried different materials like metal oxides, metal chalcogenide, polymer as well to coat that one. And as a showcase, I can show you just vanadium oxide as well as vanadium sulfide, which is coated on the carbon nanotube. So here, for the vanadium sulfide, we have used simple chemical method which contains 4 beacons. So where there is a cationic, adsorption, and anionic reaction. So adsorption and reaction process, it is there. So this is very simple process without much sophisticated instrumentation, so that you can start to work with the nano with this type of the method called as a SILAR method, called successive ionic layer adsorption and reaction method. So what we have done, we have taken the carbon nanotube which is coated on the stainless steel, dipped inside the cationic solution, then dipped inside the water, that is ion exchange water, then anionic solution for the reaction. So that, for example, if you want to coat the vanadium sulfide, this carbon nanotube, when you are dipping in the vanadium source solution, vanadium ions gets adsorbed, right? That is cations of the vanadium. Then there is a reaction with the sulfur, so that this sulfur react with the vanadium, so it can get VS2 on the carbon nanotube. And this completes one cycle. Depending upon number of cycle, you can control the size of the particle. And here we have done this characterization like X-ray diffraction, then XPS, just to identify the form material, it is vanadium sulfide, it is there or not. And oxidation state, it is also important. right, +3 or +4 oxidation state it is there. To confirm that one, we have done this XPS analysis. But most important part is the surface morphology, because whatever vanadium sulfide it is there, which has to coat on the outer surface area of the carbon nanotube. And here you can see that the second image, it is vanadium sulfide on the stainless steel. First image, it is just carbon nanotube, and when we are coating the vanadium sulfide on the carbon nanotube, it covers only outer surface area of the carbon nanotube, which is responsible for high redox reaction as well as with very high surface area. But most important thing is that this is SEM image, but we have taken HRTM image where we can see that this vanadium sulfide, which is grown on the carbon nanotube, it shows the hexagonal type of the structure on the carbon nanotube, because we have used the chemical method called as a Cellar method, and vanadium sulfide, it is having two states. One is called as a trigonal state as well as hexagonal crystal structure, we can say, and used Cellar method, it is possible to grow the monolayer, and it favors for the nucleation, where carbon nanotube, it is having hexagonal structure, so it favors the hexagonal structure, and we got hexagons of the vanadium sulfide on the carbon nanotube. So we have used this one for the supercapacitor study. So for the initial testing, we have done this one as a 3 electrode system, where you can use reference electrode, counter electrode, and your active material on the stainless steel as a working electrode. And for the 2 electrode for solid state device, we use 2 electrode system for the device testing. So liquid based configuration for the 3 electrode system, as here you can see that specific current versus potential that can be scanned through by using potentiostat, where area under the curve gives the how much charge it is stored inside this one, called as a specific capacitance. So we have calculated that one. And next one, specific capacitance against the scan rate, it gives the how much capacitance it is there. It can vary with respect to the scan rate. And we have achieved a specific capacitance in 2 molar KCl solution as 830 farad per gram at 2 millivolt per second, and stability it is there. We have run this one for almost 10,000 cycle, because stability it is also equally important, and it is more than 95% stable for this electrode. Then we have done the charge discharge study also, how the charge discharge it is there. It should quickly charge and it should slowly discharge. That is the important idea inside this one. Then, but if you are using the liquid, it is having long-term stability issue, like liquid evaporation, imperfect sealing it is there, and interaction of the liquid with the substrate it is there. So we thought to make complete solid state device by replacing this liquid with a solid gel, which consisted of PVA and LiClO4. PVA, it is a non-conducting matrix, where polyvinyl alcohol, and lithium, it is a conducting. Means lithium ion are embedded in the polymer matrix that we have coated on the one electrode, and then we have sandwiched another electrode called as a symmetric device. If you are using 2 different electrodes called as a asymmetric. But here we made symmetric device for the vanadium sulfide coated on the carbon nanotube, and here you can see that it gives the capacitance about 182 farad per gram at 2 millivolt per second, and stability it is more than 93% for 5,000 cycle. And when you use this one, so you can see that the potential window it is more than 1.5 volt. We have run this VNIT panel by using this form device. And this result, it was published in the Journal of Energy Chemistry for just vanadium sulfide coated on the stainless steel and ACS applied material and interface, when we got this hexagons of the vanadium sulfide on the carbon nanotube. Similarly, we have coated vanadium oxide by using simple chemical method. And here, this is the morphology, which is flex-like morphology for the vanadium oxide. And inside the Cellar method, we have placed cationic precursor, anionic precursor separately. But inside vanadium oxide, we have used chemical bath deposition, where cation and anions are together inside the one bath, and just deposition temperature is just 60 degrees Celsius. Then here you can see that the potential window for the solid state device with the PVA LiClO4, we got 1.8 volt. So 1.5 volt it is there, which is important to run most of the devices it is there, but this shows 1.8 volt. And for the solid state device, we got very high capacitors, about 468 farad per gram with 96% stability it is there for 4,000 cycle. And this is the charge discharge energy density also for this developed device. Here we can say this is bending angle with respect to the specific capacitance. As we said, it is a flexible device. So how much flexibility test that we have to perform is that we have made the bending, mechanical bending, and we have tested that one. And it is 90% stability it is there up to 175 degree mechanical bending. And also we have tested for almost continuous 7 days. This device, it is working very well. And also we have used this small one device to run the VNIT panel. Here I can show as a demo case. this result was published in the Electrochemical Acta as well as this Nature Scientific report. And here you can see that this is a working model of this device. This device, it is 3 by 4 centimeters square. It is completely solid state as well as the flexible. And we have used the battery, which is a 3-volt battery. It is there to charge this device. So this device can charge within 1 minute. And this discharge can be there for 4 to 5 minutes. So here, this is the device charging. So whenever you are thinking about any type of the research, when device development is in the laboratory it is there, it should be applicable to the common people. That is having more importance. As Vice Chancellor sir said that quality and the citation you will get when you are taking something at the device grade application, then automatically you will get the more citation as well. So this is VNIT panel. It can run up to 5 minutes. And this video, it is available in the scientific report website as well. Not only this one, we have run this digital small fan by using this device. And this project, it was from Technology Mission Division from the DST. I was PI, then Dr. Kale from CIMET, he was co-PI, and one industry partner, Dr. Sharma from Spell Technologies. So this is now device charging, and this is device discharging. So this fan can run up to 3 to 4 minutes. So I have given this demo in DST. They called for meeting, and then in this international meeting, it was there. Then this demo, they have given the booth, and we have given the demo for this one as well. This Saraswati member Nitya Ayog, he visited. Ashutosh Sharma, Secretary DST, visited, and Ram Gopal Rao, Director, he visited our booth. Not only this one, just recently we have published one paper in Journal of Colloidal and Interface Science, and here we have developed the marigold type of the tungsten oxide, and at the first time in our laboratory, initially whatever we made, that is called as a pouch type of the cell, but here we have made simple coin cell that is very small size, and we have run this VNIT panel with a very small area. It's completely solid state device by using tungsten oxide. Here you can see that it is charging. This is very small area. Now discharging through the VNIT panel consisting of 21 red LEDs. So along with the publication, you can get the satisfaction as well as your device is working very well. It is working. So we have developed a lot of devices. These are the different parameters like potential window, energy density, power density. Because of the intrinsic property, it shows the different potential window, energy density as well as the power density. Also, we are working on this dye-sensitive solar cell. Actually, this work, it was carried out in this North Maharashtra University. It was between 2007 to 2012 when I joined this one as assistant professor. And we developed colorful solar cell, which is called as a dye-sensitive solar cell. And this is the working model. I wish to thank different projects. Now 3 projects are running. Also, we got DST FIS grant when I was HOD. These are the students. Because of that, whatever the research it is there, they are the bone back for this one. And Prashant Bhaviskar, he was there. He got DAD fellowship when in 2011. All these students, they have visited. Some are there working like one is working this Bidan Pandit. He just got Marie Curie fellowship and in collaboration with MIT USA. One he is in Korea, another one in Japan, another one is Israel. So. One book, it was published from the Springer, Simple Chemical Methods, how it can be applicable for the different application that we have made. Different 12 methods are there like CLR, CBD, spray pyrolysis, electrodeposition, so that this low-cost chemical method can be applied for the device grade development. So I wish to thank VNIT, DST, TMD, SRB grant, Government of India, research collaborator, as well as the research scholars. Thank you very much.
For a couple of questions. Yeah, Swapnil.
No, there is a mass loading effect, it is there. So optimum mass loading should be there because it is specific capacitance is divided by mass loading. So you have to optimize that one depending upon the mass loading. If you are increasing the mass loading, if it is increasing that one, specific capacitance may remain same, may change. So there should be optimum value.
Sir, one question.
Yeah.
As per the capacitor is concerned, the capacitive contribution and diffusive contributions are important.
Yes.
So as per the device fabrication is concerned, which part of the capacitance is more important?
If you are thinking about the stability and capacitance, if it is capacitance, it is there. If you are thinking about the capacitance, then diffusive type, it is more important because intercalation, deintercalation process, it is there. So if you are thinking about this hybrid, which contains ADLC as well as the pseudo, both the mechanism it is there, surface diffusion as well as the capacitive as well as the diffusive. So it can give high stability as well as high capacitance. But you have to optimize that one. That is also equally important. How much pseudo and how much ADLC it is there. Yes. Thank you. Yeah. In supercapacitor, instead of thickness, we can talk about the mass loading. Whatever thickness may be there, because thickness means what? In the thickness, if it is 1 micron, whether it is nano, whether it is nanowire or nanoparticle, nano-embedded, it is there. How much porosity it is there, that matters a lot. But instead of just thickness, we should talk about the mass loading. That is very, very important. Optimum mass loading should be there, whatever the thickness may be there. Because it is divided by not thickness, it is divided by mass loading. Not 2 seconds, it is in a certain second, maybe 30 seconds, 40 seconds. Yes, you can see that one because charging should be there and discharging should be there. Discharging should be very slow. Along with that, discharging voltage drop should not be there because voltage drop is also happening along with that one. Depending upon material, IR drop is also there, whether you are using, suppose LiCl4 and PVA is there. PVA, it is non-conducting. Because of quantity of the PVA, also IR drop can change. Also resistance between the material and the substrate, that also can change. So how the interface it is there, that can be studied by using EIS analysis.
I request chairman of the session, Vadgaonkar sir, to felicitate Dr.
No. Let me make some remarks.
Yes, sir.
In line with what VC sir said, in his inaugural speech, Professor Babasaheb Sangpal demonstrated, how one can carry out a fundamental research of high quality, also coupled with the applications. That's what he demonstrated. Friends, I just would like to mention that, we all live in energy-driven world. And Richard Smalley, Professor Richard Smalley, who is a Nobel laureate, he has identified 10 top challenges the world is going to face. And on top of the agenda is the energy. So anything, related to energy generation, energy storage, those are the pressing needs of the present time. And that's where, Professor Babasaheb Sangpal, working in a VNIT, it's not like a national institute. I mean, it's national institute, but not like a CSR lab or other institute, has demonstrated, ably, how one can carry out high quality research coupled with the application. So let's show our appreciation to Professor Sangpal for the work. And now our next speaker is Friends, our next speaker is none other than Professor Sheshnath Bhosle. Of course, I'm not going to read out the printed version of the introduction, which has been passed on to me. I have known Sheshnath from his early research career. Of course, now he is at the mid-career stage of his research. Of course, he has done his PhD in Germany, has also worked in Switzerland, Austria. He was a faculty, in an university in Austria. Of course, I don't remember the name of the university right now. He is, a sort of a role model for the young researchers who come from rural part of Maharashtra, because I know that he comes from a very humble background, but the position which he has reached today is, commendable and admirable. To his credit, there are more than 3 centuries of publications with H index of more than 45. And I always keep telling, the best of Sheshnath is yet to come. So you can imagine, the kind of contributions which he has made to both fundamental science and applied science. And I think that's what he's going to demonstrate to us. Of course, again, I say that, his research is, of course, influential, meaning, it has made great impacts. And of course, again, in line with the VC sir, what he mentioned, he combines excellence with relevance. I think that's the beauty of research of Dr. Sheshnath Bhosle. So I would like to present to you Professor Sheshnath Bhosle.
Thank you, sir. Thank you, sir, for your nice introduction. I think we have only 30 minutes to cover. I will try my best, but I'm sure Dinesh Sawant sir will give me more time. He will reduce his time. But anyway, we're going to have the lunch after Dinesh Sawant sir. Let him start. Good afternoon, all. Thank you, ma'am, for coming. That's Mrs. Vadgaonkar, ma'am. Thank you, Vadgaonkar, sir. What happened? Can you show slides, please? Okay, all. Thank you, Dalal sir, for inviting me in a great place. This is my second visit. My elder brother used to work in this university, and now I'm here to present some of my work. As sir gave my background, you can see I will be talking about the development of nano and biotechnological tools using a small organic molecule, how we can utilize them for advancement. I hope you will enjoy. If you get bored, please raise your hand. We can stop in between any time. Yeah. I'm working as a UGC professor in Central University, Karnataka. I'm not going in much detail. First of all, I need to thank my students. Because of them, I'm here to able to stand in front of you. My RMIT team, I work in Monash University for 5 years as a faculty. Then RMIT work as a 5 to 6 years. Now, I spent 5 years in Goa University. Currently, I'm working in Central University, Karnataka. I must thank a couple of students from Jalgaon University. He's one of the first student who passed his PhD from Jalgaon University. Another one is Gajanan. His photo is not with me. I also thank them. Most important is collaboration. To become a wider or publish high-level standard, high-level work and high citations, you need a collaboration. We are lacking behind that. That's why our number of patents, number of papers coming down, and quality and quantity also affect that. That's why collaboration is most important. Whenever you work, you must collaborate with other scientists. Funding is important. Without food, we cannot live at home. That's why we need money, we need salary. Such thing we need for the research as well. Without that, we cannot work. I'm going towards the supramolecular chemistry. What is it? It is nothing than the utilizing concept from the nature. What are the concepts in nature? Like photosynthesis, host gas chemistry, ion channel. There are many more concepts used in nature. We know only few of them or understood few of them to go further. You can see the butterfly. We see the color of butterfly every day, but we don't know what is or what element they containing in the butterfly. You can see that they use a donor acceptor system in their body. That's why the visualization of color will take place. मराठीमध्ये सांगायचं झालं तर आपलं रात्री एक सोनकिडा येतो, चमचम करतो. What the happening there? They releases the certain amount of molecules in the environment. That's why they give a lightening of their body. Or couple of people are working towards synthesizing dancing molecule. Yeah, you not only interest come with the making molecule, but can we make a molecule who can dance? Yeah, not only single, but we can have a synthesis molecule like a dancing molecule, like a salsa dance, together dancing. Yeah, it's a party time. We can make a penguin-like structure. We can make a donor acceptor. That's what nature uses. Nature never uses covalent bond. Nature uses covalent bonding. We can make the polymer like what Vadgaonkar sir produces, or other groups also produces, but nature uses the non-covalent bonding. That's called coordination bond. You can take an example of hydrogen bond, or you can take an example of host gas chemistry, hydrophobic, hydrophilic interaction, and so on. And this one of the example, like shaking hand with poor person to rich person. Yeah, it's difficult, but nature uses this hydrogen bond to shake with us. Yeah. With this, earlier 1997 we got Nobel for supramolecular chemistry. Recently in 2016, not recently, days to come, as Vadgaonkar sir said, we should bring Nobel to India as well. That's what we are for. For a young researcher, I welcome them to work hard. Not only quantity, quality, but focus and work hard is the most important. That's where also we are lacking of. In 2016, these three people got, Sir Stoddard, Swedge, and Jen Feringa got Nobel. Bernard Feringa got Nobel because of we use a combiflam tablet to treat immediately. But what is the side effect of those drugs? Because only few % of drug influences in our body to treat that for certain time. But the 97%, like if you take a paracetamol tablet, combiflam tablet, only few % of paracetamol drug is there. Yeah, what is the waste of that? That remains in the body because those are hydrophobic. It won't dissolve in water. And to do that, why not we create such a molecular motors, molecular lifts to target the drug delivery, like a cancer. Like if you cut the amoeba, it can regrow. Same thing with cancer, it is regrowing because we are not targeting the nucleus of that cancer. Same thing for amoeba, if you kill the nucleus, it won't regrow. Similarly, cancer can be treated. That's why these people develop such system to target the drug delivery system. But problem there, they use such a huge, bigger molecular structure which cannot be synthesized in larger scale and so on. That's where we are working towards. There is long, I always use this phrase, there is still a long way to go. Our aim is to learn from nature and use knowledge to explore new frontiers. What are the new frontiers? You can see that receptor ion channel, enzymatic reaction, energy conversion, photosynthesis, drug delivery system, and so on. These are the few. We use natural food, natural everything, but we don't understood yet, and there is a long way to go to learn from nature. That's why young scientists should come up with their ideas and work towards the development of our nation. This is one of the best example of purple bacteria. You can see that molecule arranges such a way in a purple bacteria. There is no covalent bond between molecule. Electron transfer from back to chlorophene to back to peptide to quinone and so on. Before it goes back, the food production takes place in our green plants, and before recombination of charges, then energy harvesting takes place. Same thing with, just now you heard Sankpal sir about the supercapacitor. You need energy storage devices. Nowadays, Modi government put a lot of efforts to make more contribute towards the supercapacitor. Next 20 years, if you work in the supercapacitor area or energy materials, your life will be brilliant, because government putting a lot of efforts. So far, we use material from China, USA, and so on. We want to be independent. That's why, if you come up with the idea, work on this direction, you will be the brilliant scientist in future. To fabricate the device, there are many scientists use nanowells, nanogaps, zeptovels, nanotubes to arrange a molecule similar to the purple bacteria, what you see in bacteriophil, bacteriophaptine, quinoa, and so on. But problem here, they use such a tubes where molecule going on, sitting on top of each other, similar molecule. But nature uses different redox potential. That's why you need such a cavity which can arrange a molecule in such a manner without covalent bond, and in such a manner having the different redox potential. We are came with idea we call Yacto, is the smallest unit so far. It is 10 raised to minus 24 liter volume. I will go through these couple of slides about Yactovels, couple of slides on naphthalene diamides, how we can use in our everyday life, photoluminescent material, porphyrin nanostructure, and so on. Yactovel can be prepared anywhere. What we lacking of? आपण काय म्हणतो, माझ्या लॅबला काही नाही, माझ्या युनिव्हर्सिटीत काही नाही, आमच्याकडे फिल्म कबड नाही, आमच्याकडे हे नाही, कंप्लेनच जास्त झालेत. तर इफ यू व्हॉट एव्हर यू कॉन्ट्रीब्यूट इन दॅट डायरेक्शन, मेक कोलॅबरेशन, मूव ऑन. या माझ्याकडं सेंट्रिफ्यूज नाही, मी काय करू म्हणल्यानंतर मग हाताने फिरवायचं. ओके, मीन्स यू कॅन यूज अ नॉलेज. That's now this Yactovel can be prepared anywhere. You can prepare in our NMU. Yeah. We use iron particle, magnetic nanoparticle. We fabricate with tetraethyl orthosilicate. We got OH functionality on these nanoparticles. We modify them to with APTS, get aminated particles. Simple coupling reaction with acyl chloride with amide, it's amide coupling reaction. Anyway, if you ask 12th standard student, they will know this. Yeah, use simple chemistry to prepare the Yactovels. We prepare our magnetic silica nanoparticles. How we can use them, that I will tell you later. But first, how we can confirm that? The base porphyrin is a fluorescent molecule. When you give the light, it emits the light. You can see the beautiful fluorescence. Now, everywhere, every university has these fluorescence UV machines. Our NMU also have, I know that. Yeah, you can see the fluorescence. When you add the same size of porphyrin, which has the different redox potential, which goes inside the cavity, 2 inches. But bigger size than the wells. Well, माहित झालं का? विहीर. Nano or Yacto is a size. Yeah. जर मोठा दगड जर विहिरीत टाकला तर वरच अडकून बसेल. जर सेम साइज दगड टाकला तर विहिरीत जाईल. म्हणजे एक कन्सेप्ट आहे. Then we use this concept. Bigger size porphyrin does not enter inside the gap, and fluorescence of the base porphyrin remain intact. Then we confirm the prepared gap or 2 nanometer gap, exactly what we added. And then we use a Michael addition reaction. Simple reaction we use this. And our Yactovels, wall of the Yactovel has the double bond. You can see that double bond. We use this Michael addition reaction. We got negative charge porphyrin on the surface of this Yactovels. And that can be varies between the distance can be varies between these molecules depend on the chain length. And these are rigid gaps because there are very strong hydrogen bonding. Yeah, and that's why rigidity comes from the hydrogen bonding. And then we can vary the distance between these molecules. You can see that 0.5, 1 nanometer, we succeeded onto 1.5 nanometer. Then this chemistry, if you don't have fluorescence, don't have UV, don't complain. You can use a cyclic voltammetry. 1.5 lakh, I can pay you from my pocket. Do the same chemistry on the gold plate, gold electrode. Yeah, and you can see that. Cyclic voltammeter of gold plate give the beautiful cyclic voltammogram. Once you occupy this molecule with certain distances, the electron does not transfer from the gold surface to the ferricyanide. And then Whatever gap you prepared, you can monitor with a cyclic voltammetry. Using these gaps, what we did, added same size porphyrin, taking so long time to reach at the base of the reactor wells. You can see that about 10,000 seconds it takes to reach at the bottom. Why? Same दगड आहे विहिरीत गपकीने जाऊन फटकीने पाणी उडवायला पाहिजे नाही. Why? Because the hydrophobic nature of the walls of the reactor well make the water molecule in a trimeric form, dimeric form, like because of the hydrogen bonding, and to squeeze that water out from the reactor well is taking time to reach at the bottom, the added porphyrin. And then taking advantage from that, we were able to, this is the first example, we were able to arrange a molecule with a different redox potential molecule within the gap and quantify with the UV visible absorption spectroscopy as well as the fluorescence spectroscopy. And this is the first example where we were able to use our reactor wells for the arranging a molecule similar to the bacteriophobactin, bacteriocolophin, quinone molecule, what we've seen in the purple bacteria. Then whether we can make hydrophilic gaps. Yes, we were able to compile hydrophobic reactor well. We were able to modify walls with oxygen chains, which is hydrophilic. We were able to do the peptidic reactor wells. Nowadays, antibiotics, taking antibiotic is very difficult, very easy to get in market, but very difficult because once you start getting antibiotics in the body, your body cannot function well after some time when you take only simple combiflam or paracetamol tablet. You need always antibiotic dose. That's why we are able to manipulate or understand what is the role of the antibiotic in a human body and so on using our model system. Doxorubicin in the Barsi area, you might know the Barsi area is one of the biggest cancer institute. We are working with the Tinundaram Institute, but Barsi area they use MTZ and doxorubicin molecule, which I will show you next slide. We are able to capture this molecule within the cavity and releases with the pH dependent. You can see that this is the molecule, only 3% to 5% doxorubicin MTZ has been used when you give the 100% dose. That's why you lose your hairs, you won't taste the foods. That is a big problematic. Nowadays, because of tobacco, because of this gutka, we're getting mouth cancer. Because of the drink, we're getting stomach cancer. Because of not feeding milk to the babies, we're getting breast cancer. To avoid that or to overcome that, can you target the nucleus? I will show you that later on. But these are the drug molecules where successfully modify or capture the drug molecules in our cavity. And you can see that particle remain intact. Because the problem here, if your particle disturb, the size of particle disturb, that can cause the problem to the other organs. Our particle remain intact. We are able to release the drug molecule in the specific areas. And because let's suppose we have cancer on your hand, because you cannot inject directly to the cancer cell. If you inject from anywhere from your leg or body, if you bring the magnet from outside, it will accumulate all the particles that place. And with the pH, in acidic pH, only drug molecule releases. Means there are two benefits. You can accumulate the activates in a specific cancer cell and MTZ molecule coming out in the acidic media. Our cancer cells are acidic cancer cells. 4.9 pH of cells are acidic. Like when we call it, our stomach got too much acidity because of drinking tea and so on. And then over the time, you will get the stomach cancer. You get the lung cancer. You get the mouth cancer because of the acidity of the tobacco, acidity of the your gutka, pan gutka, and so on. That's why you need to have the drug molecule released in a specific cell and targeted in a acidic pH. You can see that particle remain intact. We are able to release the drug molecule in a pH dependent. You can see that depending on the pH, it releases. We are able to successful 48 hours time, 60% cancer can be killed. We sent to the FDA approval from Trivandrum, Sri Chitra Institute of Trivandrum, but they declined from the USA because we need a minimum 83% success rate. If we are able to do that, these are original breast cancer. You can see that red dots are the carcinogenic dots, carcinogenic cells, but over the time, you can see that it's a killing. Yeah, 60% succeeded, and we are working towards modification of these particles with a different tagging and so on. And if we succeed, definitely that is the best part for the women to use for not losing hairs. And within the certain time, our cancer can be cured. But I cannot guarantee how much we will be succeeded. If we succeed above 90%, I promise you, we will have the Nobel in India. Chemistry of core-saturated naphthalene diamides. This is a different topic. I will go through that. Still I have 10 minutes, sir, yeah? Yeah. Naphthalene diamide is simple molecule known from 1897. And they use it as an acceptor molecule for donor acceptor system. But slight modification of this naphthalene diamide with the nucleophilic substitution reaction, you can change the optical properties and fluorescence property. You can see that. When I was doing a PhD in Germany, 2002, and this Urtner, Professor Urtner came with the idea of modification of nucleophilic substitution reaction, we can modify the naphthalene diamide. Using that, we were able to publish one of the best articles in Science Journal. If you go through this Science Journal, it has around 62 pages supporting information. We wanted to publish 3 to 4 papers, but science is science. Yeah, that's why we sell to the science, and River asked us to put all the papers as a supporting information for this paper. Please read this paper. If you are not interested in research also, read this paper. What I recommend you, when you get the high BP, you know BP? माहिती आहे ना BP? सगळ्याला 90% लोकांना 45 झाली की BP चालू होते. का? कारण सोडियम, intake of sodium chloride. What is intake of sodium chloride? It is a different source. मग डॉक्टर काय म्हणतो, मीठ कमी खावा. If you eat every day one banana, I guarantee you, you can avoid the, I'm not Ramdev Baba or someone else, yeah? I can guarantee you, because of the content of the material inside the banana, magnesium, potassium, it can reverse the channels. And we are able to prove with our experiments, and we've seen that magnesium and potassium channel is reversing the sodium. That's what our proof is. And we did it in a lipid bilayer membrane. It's like cell membrane in our body. We did it in a yolk lipid bilayer membrane. We were able to open up channel, close up channel, and so on. There's too much study in behind that. But you can see that using this naphthalene diamide. But can we use this naphthalene for different purposes? Yes, we are able to do that. You can see that science paper that's closing helix and open helix and so on. I don't want to go into too much detail. If you are interested, you can write me an email. We can discuss more about that, because this is a conference. I just want to give you the overview. And interested scientists from front row or back row students, they can come to my lab, work with me. We can produce best science in the world. Can we use this simple molecule for benefit of our society? You can see that naphthalene diamide or TTF type of molecule we can use for everyday life. As fluoride sensor, we can see that Ramdev Baba say, my toothpaste is the best. What is that toothpaste name? That blackish color? हाँ, पतंजलि का वो टूथपेस्ट है. उसमें प्रॉब्लम क्या है त्याच्यामध्ये? The content of fluoride we don't know. Once you print it, you label it everywhere. You know the fluoride, content of fluoride in Colgate. We don't know. Whatever they say, we know. then can we synthesize such a simple molecule for practical application in our home itself or our laboratory itself? Yes, simple molecule can only detect the fluoride, and that can be, we don't need UV, we don't need fluorescence, we don't need any instrument. That can be seen by naked eyes. Yeah? We can use this knowledge of nathilindiamide for calcium. दिवाळी आली, मिल्क आहे, मिल्क प्रॉडक्ट आहेत. रमजान आला, मिल्क प्रॉडक्ट आले मार्केटमध्ये. कुठून मिल्क येतं असं जे ओव्हर इयर नसतं. You know what I mean? Why in Diwali function or Ramzan Eid we get a lot of milk product? Why not every day? Because that might be because of the fake milks in the market. To determine that, we don't want to ask anyone. Bring that milks at home and put this our product. Just need a small drop of that product, and if you see the changes in the color, we say that it has the calcium. If once we know the calcium, it has the calcium, then we can drink that milk. Don't believe on anyone. We are chemists, we are the scientists. We are not doctor because we are thrown up from doctorate and engineering. But we are the scientists who can make the tablets. We can deliver the drug in the human targeted drug delivery. We are the scientists. Yeah? And future scientists, I want you should be working on this field because there are a lot of things should be discovered. Lithium battery. People say lithium battery. What is lithium battery? Can we store the lithium? And can we sense the lithium from any material? Yes, we can sense. Simple molecule can have the different optical properties. You can see that secondary crown ether attached to the this naphthalene. We can see the fluorescence, naked eye detection. It's only detecting the lithium. Litmus paper, everyday laboratory, MSc, BSc practical uses litmus paper. But problem with litmus paper, once we use the acid or base, we cannot reuse it because we have to throw it. Can we synthesize simple molecule? As I was working with the Puyer sir, we recently submitted one more paper on this other type of molecule, DPP molecule. Here, acid-base sensor. What litmus paper works is acid-base. You can see that our molecule can be reused many times as a litmus paper. We can make the beauty of chemistry. It's not only application part, but beauty of chemistry is can we make the structures, different structure. You can see that hydrophobic chains, hydrophilic chains, we don't have to synthesize polymer to make the material. We can make the material from the organic molecules, small organic molecules. That's what I may say, small molecules for the nanotechnology development. You can see that I can make beautiful earthworm-like structure from simple molecule. And this is a real picture from atomic force microscopy. I can make the balushai donut, yeah? I can make the donut-like structure with the aromatic chains. I can make a smaller balushai without aromatic system on the core, yeah? I can make the small particles, small hollow particles on nanoscale level. I can make the nanobelts. I can make a better nanobelts. You can see, we cannot wear it, but that is a nanotechnology development. That is the application for the future to come. This is a SAM images, this is a TM images. You can see that small manipulating structure, small salophilic interactions, we can modify the molecules to work for us what we want to. Yeah? Or we can make the flowers. Yeah? If you want to propose anyone, you can buy the flower, you can propose. But if flower sukli ki bai geli, hasachi goshti vegli, but if you make the flower which can survive forever in the literature, or forever for your wife, or girlfriend, or husband, we can simply interact phosphoric acid with melamine. We can synthesize flower, yeah, And the growth of flower can be monitored with a scanning electron microscopy. You can see that जसं गुलाबाचं फूल किंवा झेंडूचं फूल खुलतं तसं we can monitor with hours time. Within 3 hours time, we can make the flower. To grow the flower, it takes 40 days, 30 days, but for organic chemist, we can make the flower within the time. Time is short. I can make the caterpillar-like structure. You can see that hydrophobic hydrophilic interaction. We know the pesticide. We use the pesticide for farming the field. But the caterpillar always coming, causing problem for the food. What is the problem there? What we found out, because of this hydrophobic nature of this molecule, the caterpillar bend their mouth and then they cannot drink that pesticide. That's why we wanted to study that what is the nature of caterpillar. This is the hydrophobic nature of caterpillar. You can see that if you put the drop of pesticide on the caterpillar, it go out. Yeah, like oil वर पाणी टाकल्यानंतर सरकल्यासारखं. Okay, that's the caterpillar nature, and we can see the growth of the caterpillar using the scanning electron microscope. There are many things to do. We have written the chemical review. We have written chemical society review. Many reviews we have wrote on this topic. If you are interested, you just Google my name, chemical review in 2016 or 2021 chemical society review. They have the highest impact journals. Yeah. We cited around 600 publications on the, in this paper. Short time, we are making small organic molecule which can fluorescence when they aggregate. And what is the use of that? We can sense the cyanide. Yeah, we can sense the cyanide with only addition reaction. It's a no-angel condensation reaction. Or you can add the cyanide to the double bond, and then our wives or our parents, they use the potato which is growing. ते कोंब फुटलेल्या potato मध्ये cyanide generate होतो. We have proven that. You can see that. When we want to buy the sweet potato for fasting, उपवासाला sweet potato खातो. If you see that yellow dot coming on sweet potato, that is generating the cyanide in that sweet potato. We have shown with our molecule. You can see that when you put the molecule, we can see that. Yeah, it's generating the cyanide. Almond, bitter almond also has the problem. How we can know? Don't swing it. You can see that white dot coming on the almond, and that is generating the cyanide inside these almonds. We are also working on the mops to filter the water from the poisonous chemicals. We are working towards the making rings. As boy can propose with the flower, girl can propose with the boy with, or a woman can propose to the husband, making the ring of molecules. You can see that beautiful ring can be created from simple molecule. That is a transmission electron microscopy. Yeah, chemistry is beautiful. You only want to work. We know the cancer. We can treat the cancer, but early detection of cancer is important. You know the Urasing. He has detected cancer in a second stage. That's why he survived. Once you go to the third stage, you will become the chief minister of the Goa. I don't want to say or bad thing, but if you know the early detection is good. We can use our cells. What is a cancer? Acidic cancer cells. If you have the pH meter, pH type of dye, which is non-toxic, which can detect the cancer, you can see that pH 3 only detecting the cancer. We can make DNA separation, DNA fabrication. Again, early detection cancer. PI has been used for many years, which is a toxic itself. But we have shown that our molecule showing the better separation than the PI. We can make the tanis. Tansasarka dista nahi, saadicha tanis. We can make the leaves-like structure, just controlling the molecular morphology with the pH of water, chloroform methanol, chloroform hexane. We can modify or we can see the different nanostructure of from one molecule with the varying the concentration, with varying the hydrophobic interactions. Given the part, bad thing happen in the night time, can we make the flower which can fluorescent? Yes, I have synthesized that molecule which गुलाबासारखं दिसत नाही, झेंडूसारखं दिसतं, बाई काही इम्प्रेस होणार नाही, पण we can make the molecule which can looks like a flower or which can create the nanostructure like a flower which can be fluorescent. Yeah? Because it emits the light once it aggregate. We can make a beautiful chemistry. We have written many reviews. I'm writing one review now on this topic. It will come, they gave me 1 year, it will come soon. But we have a written review on SS applied material interface. If you are interested, you can read that reference. Purple nanostructure, you can make a rangoli काढतात बाया रंगोलीनं. आम्ही molecule rangoli काढतो. These are the X-ray crystallography, crystal structure of the molecule. You can see that it is like a swastik-like structure. I shown that in Germany when I went to there for conference, and that was a bit shaky. Yeah, you might know the history of the Second World War and so on, but we shouldn't show that kind of structure to them. But it is a published. I don't have the problem. Okay, we can make the nanowires. We can make molecular watch. We can control the watch-like structure, how the watch is moving. It moves with the battery, but I can make the molecule on the nano scale to make the molecular timepiece. This is a X-ray crystals of that molecule. Molecular watch is stopped. I will stop soon, don't worry. I can make the nanotubes. Means we can control any structure we want with modifying. It's not like I got it, I publish it. I make the structure based on what I want. And that is a chemistry. That's what you should develop for yourself. It's not like a vice chancellor sir said that. What he said, don't do science because it is a work. Do the science with your passion. I don't sleep if I don't produce something because I love chemistry. That's what everyone should be doing that. If we do that, we will be the best in the world. This is my last slide. You can see that I can make a giraffe patches from the molecule. I can make any structures, what I want. I can make the molecule for the solar cell. These are the cover art. Yeah. Don't eat butter because it is having a lot of fats. Don't reuse oil. Yeah. Our parents, once they make puri, we reuse oil, but cis fatty acids converting trans, that's really bad. We are working towards that again, how we can modify that. Don't eat crunchy omelette, but use half fried omelette is better. Avoid eating sugar, maida, rice, and these all white products because they are causing problem for carcinogenic products and BP, sugar, and so on. This is my last slide, and thank you very much. Thank you, sir. I took a bit 2-3 more minutes from Dinesh.
Thank you, Shashnath. Thank you. And I think we have time for a couple of questions. Yeah, please.
कधी जाणार तू तिथपर्यंत?
Sir, as you unlock the cancer drug, in the well of the molecule, so is that possible to unlock that molecule in the micelle by using different surfactant?
Yeah. We can assemble. Look, that work has been done many years. They use a polymeric dyes to interact with this type of molecule and send it to the body. But our aim was to target the nucleus. Yeah, you can use the micelles, you can fabricate with the polymers, or you can functionalize those polymers with this type of molecules. Everything is possible. But how we can target? Our aim should be something, no? Just for sake of publication, we can do something. Yeah, we can show or we can prove something. But if you want to target, want to do something, then we should have some kind of aim. That's what our aim was. You can use for myself, ma'am.
Sir, as you told, in almond and all potatoes, when they sprouts, at that time he having the yellow spots and cyanide is generated.
Yeah.
As it is a pure sodium cyanide or potassium cyanide or a cyanide functional group organic moiety like that.
That could have been killed us, yeah, already.
No, that is so dangerous.
Potassium. But I think it is kind of a copper, cupric cyanide, copper cyanide.
Okay.
Yeah, it's not that much carcinogenic, but it's generating. But over the time, we don't know what will happen. That's why I try to avoid. That's our suggestion.
Yeah.
That's what we see.
Okay, thanks.
Thank you.
Let me summarize. Of course, Dr. Sheshnath Bhosle gave some practical tips based on his work, but I would like to summarize by, giving some tips to younger students, younger researchers. Because no one is a born researcher, but someone with a commitment and passion can become world-class researchers. I think that's what was on display. Of course, research needs facilities, but more importantly, what research needs is the creative ideas. And again, Sheshnathji demonstrated through his work the brilliant ideas what he has, put to practice. And of course, again, another point to, take home message from his work is not the competition, but the collaboration and cooperations are important. Cooperation is important because he has extensively collaborated not only within the country, but also abroad, So what that again tells us is that research is not the monopoly of the Western world, but sitting in a place like Goa University or Gulbarga University or Central University of Gulbarga, Karnataka, Gulbarga, one can do world-class research. So let's show our appreciation to Professor Sheshnath Bhosle for his outstanding work. So we wish good luck to you, Sheshnathji, for more of publications and also the technologies. Okay, would like to felicitate you. On behalf of the organizers. I think that brings us to the end of this session. We're going to break for lunch. 30 minutes? Somebody's going to make an announcement? Okay. So I would like to thank the organizers for giving me this opportunity to chair the session. It was really a pleasure. Thank you.
We'll have break for half an hour. Please come as early as possible because we want to complete all these sessions as early as possible so that in the evening we have another program. Thank you. we'll start the next session. I request Sheshnath Bhosle sir to chair the session. Please come on the dais. I welcome Bhosle sir by offering a bouquet.
Okay, good afternoon all of you. Hope you had a good lunch. Hopefully backside won't sleep. You can come front, please. Many empty spaces there. Okay, I welcome Dinesh Sawant sir from NCL Pune. Next lecture will be Dinesh Sawant. December 2019, Dinesh Sawant sir joined NCL Pune. Previously, from 2018-2019, he worked as an assistant professor as a DST-inspired faculty in IIT Dhanbad. He has recently been appointed as a DAD Germany Research Ambassador for India honor position from 2018 to 2022. Welcome, Odgaonkar sir. Dr. Dinesh has published so far 25 research articles in international journals, and so far cited, his work has been cited 550 times. I'm not going in too much detail, but he, in year 2011, he was awarded with the Young Scientist Award of Indian Chemical Society at International Conference at Allahabad, India. I welcome Dinesh Sawant sir to give 30 minutes talk, and followed by, depending on the time, we will have some questions, or we can have questions during tea. You will have tea as well. Okay. Thank you, Dinesh. Please.
Thank you, sir. So after a lecture by such a dignitaries, particularly like Sheshnath Bhosle sir's lecture having so many publication up to the science, like माझं lecture will be like Parvata Samor Tekadi Saman. With this, I will briefly start about my lecture. जसं जेडी यादव सरांनी सांगितलं होतं सकाळी की शेरोशायरी झाली पण एक थोडी बहिणाबाईंची पण पंक्ती व्हायला पाहिजे. सो अरे संसार संसार जसा तवा चुल्यावर आधी हाताले चटके तवा मिळते भाकर. सो रिसर्च इज लाईक दॅट ऑल्सो. जेव्हा आपण लॅबमध्ये जातो तर चटके म्हणजे काय की जोपर्यंत फेल्युअर येत नाही तोपर्यंत पब्लिकेशन पेटंट किंवा प्रॉडक्ट रूपी भाकर आपल्याला मिळत नाही. सो म्हणून त्याची सांगड घातणं हे खूप महत्त्वाचं आहे की जोपर्यंत तुम्हाला चटके मिळणार नाही आयुष्यामध्ये तोपर्यंत यश मिळणार नाही. आणि हेच आपण रिसर्चच्या प्रयत्नातून शिकतो. आणि दुसरी गोष्ट महत्त्वाची आहे की सिम्प्लिसिटीपासून कॉम्प्लेक्सिटीकडे. सरांनी जसं सांगितलं की एक स्मॉल मॉलिक्यूलपासून अप टू द सायन्स पब्लिकेशन. सो ती स्मॉल कन्सेप्ट काय आणि ती आपण कुठे करू शकतो. बऱ्याचदा मनामध्ये काय असतं की रिसर्च करायचं म्हटलं तर खूप हायफाय अशा लॅब पाहिजे. आपल्यापैकी किती विद्यार्थी इथलेत जळगाव विद्यापीठ. ओके. ऐराणी समजा सगळ्यासले. ओके चालेल. सगळ्यासले असं वाटतं की आता मी खानदेशतीन येऊ राहिनो म्हणजे मला पहिले इंग्लिश बोलणं म्हणजे लईच असं मोठी गोष्ट असे. पण तसं काही नाही. इंग्लिश येवालेच पाहिजे असं काही नाही. फक्त समजायला पाहिजे. बरोबर. आणि ते वास्तव ना मग धीरे धीरे केमिस्ट्री राहतच आपली येच बरोबर बाकी सगळं. आता पुढलं काही जास्त ऐराणी मग घेत नाही कारण बाकी लोक पण शेतच आपल्या बरोबर. बाकी आपण ऐराणी मधार चर्चा करूत. तर राईट नाऊ आय एम प्रेझेंटिंग वर्क ऑन कॅटलिटिक अमिडेशन रिॲक्शन्स. As sir mentioned, like acid chloride and then making amine, it is your 11th and 12th standard chemistry, right? So how many of you know about carboxylic acids? Most of you know. How many of you know about amines? Have you done binary mixture separation? Can you separate two compounds, acid and amines? To separate acid, what you have to add? Which base? Sodium bicarbonate. And to separate acid, what you add? For amine separation, what you will add? HCl, right? So it's a simple chemistry, but can we generate publication from that? We don't think beyond like a simple thing. We think too many complex things, right? So what we did in our work, we tried to make very simple things. Can we do acid amine and just make an amide by using greener methodology? So I will explain some of the work which we started initially and then what we are doing right now. So before that, I would like to dedicate my today's talk to Professor Maulikar sir. He was one of the pillars when I entered after my postdoc into Indian job searching market. Luckily, I got first opportunity to apply for Ramanujan. He supported my application during that time. In addition, I joined Jalgaon University at a SERB startup grant young associate or young researcher. But due to SERB delayed funding and all, I went back for a postdoc. But during my overall journey, whenever I need a recommendation, whenever I need anything, he was there as a pillar. And recently, sir visited our home at NCL also. Apart from that, it's not necessary that you should be only from like big cities. Sheshnath sir has already proved that. So even myself, I'm from Dhule district, right? So to become a scientist, to do world-class research, to go abroad, generally we think you need too many things. No. What you need, passion, your foundation should be strong, and you should have some big dream. Then only you can achieve it. So that's how, with one lecture from Dr. Arif Sheikh at that Jain College, I started my journey. I was working in a share market, and then that one lecture gave me an information I can do research. So that's how I started chemistry career lecture series. So far I have delivered more than 150 lectures at different colleges. Some of you might have attended those lectures also. And during 2014, I got Best Oral Presentation Award in GOLD-CT. That time I was doing postdoc. And today I'm in front of you as an invited speaker and as a scientist at NCL. So always whenever I'm at NCL, I'm achieving something else. So I don't know what will be the next. So we'll see. So these are few slides about my lectures, which we conducted online and offline. And this is my educational journey, which started from ICT Mumbai. I did PhD with Professor Bhange on catalysis area. Then I moved to asymmetric catalysis using artificial metal enzymes. Then with Professor Raiju Noiri, who got Nobel Prize for asymmetric hydrogenation, I work on making strain-promoted phosphine. And there I introduce about this area, catalytic amidation for peptide synthesis. And after that, I work with Professor Matthias Beller on BSF different projects. So right now, this is my group. In audience, currently Amit is there from Jalgaon University. And he was one of the researchers who started initially this topic in our lab. We started in COVID. Chemicals, everything was delayed due to COVID. And then what to do in the lab. So we started with simple chemistry, acid and amine. So note that, like, you can do research anywhere, even at college level, at your home, anywhere. What you need, chemicals to mix. And what you need to analyze, some kind of sophisticated instrument. So doing chemistry, it's very easy. Just for analysis, you need collaboration or you need some instruments. So we are working right now. I'm having a group of 5 PhD students. Out of that, Nutan, right now, she is doing collaborative PhD work at UW Australia. We are working on different topics, catalysis, amide synthesis, ligand chemistry, and we are combining this area with organic synthesis and process development. That's why our group name is CATOM, Catalysis for Organic Synthesis and Medicinal Chemistry. And today, I'm going to explain about amides. Why amides? Even though this bond is simple, we have studied in BSc, acid, amine, amide. But still today, whatever product you imagine, at least somewhere you will see the amide bond, even nylon. What we use is amide bond. All peptides, amino acids, everything like depend upon this bond. So there are various ways you can make this amide bond by using catalytic condensation, by using oxidative amidation, by using carbonylation, by using carbon monoxide, aryl halide and amine combining. Apart from that, thermal amidation, just by heating it. But this thermal and catalytic has a boundary. There are some substrate which you can heat easily and you can get directly amide without using any catalyst, without using coupling reagents. But at the same time, there are some substrate like aromatic acids, aromatic anilines, they really need some kind of catalyst. So there are many applications, as I said, in polymer, in pharmaceutical, and if your mosquito bites, what we do? We go and we put morphine, good night, so that also contains amide bond, DEET, which is a gold standard for mosquito repellent. So we are also working on that as well. During PhD, we did a lot of work on amidation by using catalyst, particularly metal catalyst, aryl halide with particularly CH activation of this amide bond, giving nitrile and amide as a product. And this was an interesting thing. Instead of amide, we observed nitrile. So just that one observation gave us a paper. And how it happened? So if you add aryl halide, POCl3, And DMF, it's a Wills-Merhack reaction. You should get a formylated product. But in presence of catalyst, what happens? Your Wills-Merhack reagent undergo oxidative addition and you get a amide. And same thing, under dehydrative condition, when you have benzamide, which is primary amide, will undergo hydrolysis, like dehydration, and you will get nitrile as a product. And with this small concept, we published 2 to 3 papers, and then we came to know in literature, till that nobody used carbon monoxide. And then we use even a carbon monoxide, which is a C1 chemistry, and we published this particular paper on making phthalamides. But still, this simplest reaction, acid, amine, giving amide. You cannot replace this simplest reaction with any other reaction. But what happened? Expected is I should mix acid and amine and I should get an amide and water as a byproduct, green chemistry. All principles will be there. But actual fact is we know the acid-base reaction. So as soon as you add amine, it's a base. It will abstract a proton and you will end up with the salt. And literally you can see this salt formation in nonpolar solvents. And then in thermal amidation, to cross this energy barrier, you have to heat. And sometimes that heat requirement might be very high, depending upon what kind of acid, whether it is aromatic, aliphatic, it will depend. And to overcome this hurdle, people have developed very fancy chemistry. They give very, very fancy reagent names. Okay, you imagine this peptide synthesis. You will come across many names. Ultimately, what is the goal of those reagents is to just make a good living group. By using acid chlorides, POCl3, PCl3, then thionyl chloride, you can convert this acid into acid chloride and get then amide at room temperature. And the greener approach, can we do it catalytically without using this stoichiometric reagents? And if you see this carbodamide, triazine, like there are many more fancy reagents are there to make a peptides. So other application of this chemistry is in peptide synthesis. But ultimately this reagents generates stoichiometric amount of waste, though it is having high yield and selectivity. So what we did actually, we did a lot of literature search and we found that people have used boronic acid as a catalyst. Apart from that, there are metals reported, in heterogeneous catalyst, zeolite, alumina, many things are reported. So then we come up with an idea, can we have this phosphazine as a reagent, where Lewis acid and Lewis base, both can combine and that they can give the activity of a catalyst. And this was the proposed mechanism for that thought before we do that experiments. And idea was, can we explore peptide and cyclic peptide synthesis by using the simplest protocol in future? So after designing, I will not go into all the parameters what we set, but we made a library of this particular ligands and particular catalyst. And then we screen it randomly, and then whichever we found best, we made further derotization. It's like a SAR in medicinal chemistry. So the same thing we did for catalyst. And then we come up with this TAP catechol, and we found, after doing a lot of optimization, we can get many aromatic challenging amides, which cannot be done by thermal amidation in a simple way. Thereafter, in literature, we found that people are just exploring phenylboronic acid by substituting one derivative. One derivative is like a one publication. Then while understanding a basic, what we understand, most of them are saying there is a BOB bond formation during mechanism or BB bond formation. Then we thought, why don't we start directly with BB bond? So that's how this was our proposed mechanism for activation, and we started with BB bond. And we got excellent results in this case, like within 7 hours, we got this amide product. And almost we compare our results with reported catalyst as well as without catalyst. And in most of the cases, we reported that even simple BB catalyst at 2 to 5 mol%, you can do the amidation of a challenging substrate. Then right now, we are exploring this chemistry. Amit has worked on it. Recently, we submitted this publication. About to submit, actually. So here, what we observed in the literature, boric acid is reported, aryl boronic acid is reported, aryl borinic acid is reported, but mostly people are concerned about breaking of this BR bond. But at the same time, there are many reports where phosphated Lewis acid base pair, triaryl boron, this kind of catalysts are well known. So we thought, why we can't reproduce or we report this for this particular reaction, because it was not explored. And then we got an interesting results. Because it is in progress, we cannot show all the parameters, but we got good to excellent yield of acid, amine, as well as we explore it for different drug molecule synthesis. And now we are exploring it for peptide synthesis. In addition, while working in this area, we observed, okay, silica is like silane reagents are right now hot area. People are using silane as a reagent, which is traditionally well known for reduction of a amide bond. But now this chemistry is well known for making an amide, and every sealant reagent is a one publication. But not only publication, it generates a new chemistry. Then we were thinking last year after lockdown, can we explore this as a catalyst? What are the parameters required? Based on our expertise, we know orthochelation effect will make it as a catalyst. We know that there are some derivatives which can activate, which can act as a ligand. So those we tried, but during that time, this was our proposal, like this will be the first catalyst. Then suddenly we saw in 2023, while we were working on this project, Professor White and Braddock, they are very famous for this chemistry amidation. They have reported a similar observation what we were planning. So then we lost the opportunity to publish first, but we were happy. Our thoughts were up to that mark. But the good thing is, this was a starting point and it was complementary to our work. Here, with 10 mole % catalyst, you can see that they're getting very low yield of with different catalysts. But at the same time, if you see the aromatic acids, 0, 0, 0, 0. And in our case, right now we got more than 50% yield with the catalyst which we are about to explore now in advanced state. So this was another area. So first we explored phosphorus, then boron chemistry, then diboron chemistry, and now silica chemistry. Simple, acid, amine, amide. And now you can count the publication. So publishing is not a big deal, but how you explore that area and how to flourish for application, that is very important. And this is the current work, what we are doing right now. I cannot disclose the catalyst structure because right now we are working on it, but this was the proposed mechanism it should happen. But at the same time, we know under some condition it dimerizes. So we are trying to develop a condition where dimerization will be stopped, but we will get only active catalyst. And then this cycle will go on and we will be having a real catalytic effect, and this will be the first reaction. Not only we restricted for making a reaction, we thought how we can change whatever right now hurdles we have in experiment. Everybody know Dean-Stark apparatus? You might have seen like Dean-Stark apparatus to remove azeotropes. Toluene and water at same boiling point forms azeotrope, and then when they cool down, they get separated due to polarity. Water will be at bottom, toluene will be at the top. So instead of using that big apparatus which was broke down during experiment, we thought, okay, can we develop an alternative? So with one of the glass vendors, Zenith Glass, we gave them this design, and we designed this apparatus in such a way that this S shape will help to condense vapor to condense and fall on this wall. And then we raise this particular area so that water will remain at bottom and only toluene will go inside. And it worked excellently. And now we don't need Dean-Stark apparatus. So instead of doing 1 or 2 experiments, we can do 4 or 5 experiments at a time in a few modes. So do not restrict yourself just to following the procedure. You can modify the setup as well. And right now, we are exploring that simple chemistry for challenging problem in a pharmaceutical industry. And why it is challenging, you can see even Dr. Reddy's laboratory, they reported in 2007 synthesis of all these drug molecules by using boric acid, phenylboronic acid catalyst at that time. And that time, this was the new area, and after that, there are no reports, apart from people showing few applications in their paper. So now we are screening all the commercial catalysts. Apart from that, we know some of the good catalysts, and we are currently developing this method for actual application, where a single-step drug molecules can be made, multi-step amidation drug molecules can be made. So this will be the futuristic application. In addition, we are also exploring wherever that amide bond involves. So can we do medicinal chemistry? So by retrosynthesis, we'll go up to synthon. We'll start with new synthon. And then using our protocol, so synthon will be new. In addition, our steps will be new. So we can make a new molecule. So apart from that traditional chemistry, we are exploring now carbon dioxide for amidation, little bit ahead of this normal acid and amine chemistry. And here we are incorporating 3 areas, photosynthesis. Like if you do photosynthesis, what happens really with sunlight, you will get glucose. But here, with photosynthesis, carbon dioxide will convert it into CO. And by doing carbonylation reaction, we'll get value-added product, and our focus is amide. So this work we are doing in collaboration. And what is the novelty? This is well-known area, carbonylation and all, or photocatalytic carbonylation is known. But its application for amide synthesis, there are only few reports. So this area we are right now addressing. And this is the current work, what we are exploring in our lab. Application of our previous protocol for peptide synthesis, then new silica-based catalyst. Apart from that, we are also developing some transamidation reaction. And now this is little bit advanced stage of that. Instead of using amine, we are planning to use nitro compound instead of using acid, CO2, and in one pot, we'll get the amide as a product. And how it is possible? This diboron is also reported as a reducing agent. It generates a hydrogen. That was our first observation long time ago. Like when you add a diboron in a water, it generates a H2. After that, there are many reports. Well, people are using this chemistry for reduction. So same approach we will combine together, and this will be the upcoming results from our group. So with this, I will stop because I got an instruction. We have to limit this presentation for a few minutes. So I would like to acknowledge Professor Bhange, as well as my postdoctoral supervisor, Professor Matthias Beller, Professor Nayori, Professor Saito, Professor York Pinger, and also special thanks to Professor G.D. Yadav sir. Not because he was a mentor, but because of him I was able to do PhD. He was a vice chancellor that time, and he gave me UGC SAP fellowship. So I'm the product of UGC SAP. Many departments, they had this facility in Jalgaon University, and this was really good, and you can see product as an NCL scientist. So I got best thesis award during my PhD from UDCT Mumbai. This is my current group who are working, and they are the pillar. They really had a long trouble to establish lab, a lot of strictness from me, because first batch is always a foundation batch, but right now they are having like training up to the world class in the laboratory. And why I say world class? Because I've worked in different groups. With York Pinger, almost from US citizens, Saudi and all. Then with Nayori's laboratory, with Matthias Beller in Germany. I was a DAD research ambassador. And also I got an opportunity in, this slide is particularly for students. Do not just watch us from the backside. You should come and interact during lunch session, during tea. That's how I got my postdoctoral positions. When I interacted with all these scientists during a conference, I met Nigeshi, Suzuki, Trost, and there I got opportunity to work with them as a postdoctoral supervisor. So this all about my journey, along with a simple area can give you a lot of new ideas. Do not restrict your research because you don't have chemicals, you don't have facilities and all. You decide what you have and you can start. So like the same thing Sheshnath sir said. So there are many opportunities ahead. So that's all from my side. Thank you very much. So any question?
Thank you, Dinesh. If you have any questions, please raise your hand.
Irani mother पण चालेल, काही टेन्शन नाही.
One is there.
Yes, sir.
With tri-aryl boron catalysis, so why you not try to synthesize paracetamol by using your method?
Yeah, already we are having our patent scientist from NCL, that's why I cannot disclose many things. Already NCL has handed over one paracetamol technology, Dr. Sanjay Kamble sir's group. So they are already into it. Already there are many patents from NCL in that area. So that's the reason we don't wanted to touch that area. That's why apart from paracetamol, we tried most of the drugs. But yes, of course, it is possible and it is much easy than compared to other. What is our observation? Whenever it is aromatic aniline, aromatic acid, it is difficult. But if its coupling partner is aliphatic, it's easy for a catalytic purpose.
Acylation, chances of O-acylation as well as
yeah, so the question is really good. Question is, when we have this NH2 and OH, both are nucleophilic. So is it selective that only aniline will be acylated or both will be acylated? So what is our observation? Apart from that, second observation was acid and ester. So only acid will be amidated or ester will be amidated. So first what we saw, only acid is amidated in these conditions. And in case of amine and phenol, we saw exactly amines are prone to get acylated compared to OH, phenolic. But if you have strong basic conditions, or might be sodium salt of it, there are good chances. Another observation during this chemistry, when we are using ethyl acetate for workup, Amit was really happy, his NMRs were matching, but then we saw product is completely different because ethyl acetate is a ester, aniline got amidation happened with ethyl acetate and he got acylated due to solvent, not due to his starting acid. So that also we have to be careful, we have to observe what is happening. But yes, we can do both acylation by tuning the reaction conditions. But in our current condition, it is only limited to aniline. Thank you.
Okay, one more question.
Yes.
You have to speak louder, please.
Can you please, on that slide? So his question is to avoid that Dean-Stark apparatus, we designed something. He want to see and ask question on that. Okay, alternative for Dean-Stark. Dean-Stark, why we need? Because we are doing reaction at high temperature. If I want to do same reaction at low temperature, we can use molecular sieves to remove the water. Okay, by the way, these photos are from Amit. I just copy pasted. So all credit goes to my students. Yes. Okay, so what happens here, you will be generating in this flask vapors of toluene and traces of water. We are not having very large amount of water. Whatever water which is coming after that reaction, 1 millimole or 2 millimole, it's not a very big amount. But at the same time, it may be a reverse reaction if we cannot remove the water. So that's why in normal simple reflux, what will happen? Vapors will go up, again will go down. And then again still you have traces of this water inside. To overcome that challenge, we have to use Dean-Stark apparatus where water droplets will go down and only toluene will go in. So we mimic that idea. And now here you can see that S-shaped joint, right? So vapors will go up. Then with this round, you can see on rota also, when they come, and they will not come directly as a drop. They will come here, and that drop will be here on the side wall. Okay? And now, if you know the adapter of rotary evaporator, so that adapter has hollow tube. So we raise that hollow tube little bit here. Instead of here, that hollow tube is up to this height. So now what will happen? These droplets will condense, and then it will saturate that toluene and water. And now due to polarity, toluene is little bit non-polar compared to water. Water will be at bottom. So water will remain at bottom, and only toluene will go in. So that was the idea. And that worked out.
Thank you, Dinesh.
Thank you, sir.
I think we should summarize the lecture. Dinesh joined in NCL. As you've seen his work, his wonderful work he's doing. Hopefully next time he will be asking 5 minutes more, 5 minutes more.
Definitely,
Okay.
sir, we'll try to
summarize Dinesh's work, he has done many things with using a catalytic reaction for amidation, coupling reaction. And also he used carbon dioxide to make a amidation reaction. And further, direct amidation using nitroaromatic is most important because generally we need a aniline. Rather than that, he using a, what was that catalyst?
Diboron.
Diboron in situ reaction, and he can do the amidation reaction. Means sky is the limit, yeah. You can do whatever chemistry you want. You should have the motivation. That's the most important you should take home from Dinesh. He come from the NMU. He is a product of NMU. He travel whole world. We were become a friend through the Facebook. See what I mean. You can use Facebook, WhatsApp to approach for scientifically, not like a जेवली का, गरला गेली का, झोपली का, हे नाही. That's why use the technology for betterment or betterment of India. Nation come first. That's what I believe. Okay. Thank you very much, guys. Please thanks me joining Dinesh. Thank you. Let me congratulate Dinesh. Thank you. Our next speaker, I think we will continue. We have a lot of time for tea. I'm sure we are young people who don't like tea anymore. Next lecture will be one of the best lecture you will enjoy today after my lecture, I think. My guru, my mentor, my support, Dr. Vadgavkar sir. To add for him, the sky is limit is a word what I can say. He win many awards, yeah, prestigious awards. I can name few of them. Jeevan Gaurav Puraskar, yeah, Lifetime Achievement Award from Solapur University. That's what I'm looking forward to work with. On our new research foundation, Scientist of the Year Award 2013-2014. Fellow of Maharashtra Academy of Science 2008. Is not easy to get Fellow of Maharashtra Academy of Science. I can see that I am still member of Maharashtra Academy of Science. Professor M. Sattappa Silver Jubilee Award in Polymer Science, Society of Polymer Science, SPS India, and Professor Sukumar Maiti Polymer Award in 2004. To add in it, he visited many countries, USA, you just name them, USA, Canada, Germany, France, Italy, Belgium, Netherlands, yeah. Now we only dream cricket team come, hockey team come, isn't it? Means he visited many countries. To add in it, his daughter graduated PhD from Germany and now she's in US. That's what I'm looking, not only working, you guys working with me, but you should focus how we can go to the abroad and capture the abroad. Yeah, that's the aim we want. Let's begin sir's lecture. I'm sure you will enjoy this lecture. Thank you, sir.
Thank you, Sheshnath.
There is some technical problems. I think it will be fixed soon. Meantime, sir can give a motivational speech. Sir, you can start. Thank you. This is happen in India, yeah? Don't worry. We'll fix. We are technician. Okay. Now started. Sir, Vadgaonkar sir.
Each one of you, and I would like to thank Professor Sheshnath Bhosle for a very gracious introduction. It's an absolute pleasure and delight for me to be present, for this conference, which is I consider as like a family get-together. So I would like to thank the organizers and in particular Professor Dalal for inviting me to participate in this conference. So let's begin with the slides. At the outset, before I get into the technical presentation, I would like to acknowledge and praise our dear friend, Professor Pramod Pandurang Mahulikar. I hope I will have another occasion during this 2 days conference to speak about his contributions to both academia and to society. But I would like, the young students here to read this slide. I'm not going to, because each one of these points I can give a separate talk. So what I would like to, just mention here at this point of time, he is a person who always would downplay his achievements. He never boasts about himself. And of course, he deserves a lot more than this conference. And, the conference shows that the love, admiration, and respect what he has earned in his professional career. 600 plus participants attending this conference shows, his popularity and his impact on the society. So with these few words, let me talk about, the work which we have been engaged in the past 10 years or so. And the theme, especially what I have chosen here, I'm of course basically a polymer chemist, and I know that, polymer chemistry course has been running at North Maharashtra University. They are the pioneers, of course. after Solapur University, this course was launched in North Maharashtra University, Jalgaon, and they have produced, alumni, which is so strong that they are everywhere, not only in India, but they are occupying key positions abroad too. So that's the impact of, what North Maharashtra University has made. Of course, initially, I had a very ambitious plan to make a presentation, but on, polymer chemistry, talking about the kind of work which we are doing. But listening to the, presentation by Dr. Dinesh Sawant, Professor Sheshnath Bhosle, and our chief guest today, I have decided to again downplay this presentation just for the benefit of the students. And what I would like to do is try to inspire the students by telling them, some of our work, like how one can use creative ideas, in chemistry and solve difficult problems. That's the, idea which I am going to present to you. Of course, the talk is titled Combining Click Chemistry and Step Growth Polymerization. I'm sure many of you know that 2022 Nobel Prize went to the, scientists who worked on click chemistry concept. I'm sure the students know that, right? And of course, when we talk about polymer synthesis, polymer chemists, hardly develop completely new reactions. Many times, they borrow the reactions which are developed by organic chemists. And I'm talking to Professor Bapu Shingte, Professor Nandu Karde, Dr. Dinesh Sawant, and so many of, organic chemists who are doing extraordinary work. They are actually, I know that I've been following their work, and I, in fact, get inspired many times by the kind of developments which they have made in organic chemistry. And here, what is on the display is those ideas which I have borrowed as a polymer chemist from organic chemistry community and made use of those organic reactions to develop new monomers which will solve some of the pending issues in the area of polymer chemistry. So this is just a combination of concept of click chemistry and step growth polymerization to generate new functionalized high performance polymers. Of course, I will try to keep it very simple. But before I get into that, since there is a large scientific, student community here, polymers have brought huge benefit to us. Of course, there are some pains, and I will not again talk about that. People, when we talk about polymers, people look at polymer chemistry with suspicion. They think that, more than good, polymers have done bad to the society. But again, this is a topic of debate and discussions. I will not get into that. But what I want to tell you, it's very difficult to imagine the modern world without the use of plastics or polymers, okay? And polymers find application, again, it's to cut a long story short, polymers find application from bucket to rocket. This is, of course, a very well-established industry. The world today produces more than 400 million metric tons of plastic. This is the figure in 2023. So you can imagine the kind of impact which this industry has made. And more importantly, polymers are a diverse class of materials. You can tune their properties simply by changing the chemical structures. And this is what the art of the possible is. That's what organic chemists keep on doing, making new bonds, breaking the bonds. That's what the business of organic chemistry is. And this is what actually has been borrowed in the presentation which I'm going to make to you. Of course, again, let's acknowledge the contributions of these great polymer chemists. And why I'm showing this slide particularly here is to tell you that the polymer science is a multidisciplinary subject, or what we are talking about in today's times, to carry out research at the interface of two different fields. And these Nobel laureates, what the pictures tell you, the Hermann Schrödinger, who is considered as the father of polymer science, who gave the concept of macromolecules, he was an organic chemist. Then Ziegler and Natta, all of you know that, polyethylene polymerization, they are organometallic chemists. And then physical chemist. So you can see that everybody has a role to play here. Organic chemists also can contribute to development of polymer science, organometallic chemists, even physicists, all of them can contribute. So this is what the beauty of this field of polymer science is. Of course, when we talk about polymers, during the last 120 years or so, the first ever synthetic polymer was produced in year 1909. That is Leo Baekeland's discovery of making phenol formaldehyde resin. Since then, spectacular developments have taken place in the field of polymers, and millions of synthetic polymers have been produced. And just again, to excite the students sitting in the back, I tell you, every day, 15,000 new organic molecules are produced, okay? And the number of organic molecules which have been produced synthetically has already surpassed the number of molecules which nature makes it. And as you know, Mother Nature is an uncontested master. Nature produces lots of chemicals. So likewise, nature also produces a lot of polymers. But synthetic polymer chemistry, when we talk about, there are hardly, very few reactions which are put to practice to make the synthetic polymers. If I ask Bapu or Nandu or Dinesh, they will come up with, hundreds of reactions to make a carbon-carbon bond, or to make a carbon-nitrogen bond, or to make a carbon-oxygen bond. But not all of these reactions are useful or put to practice when it comes to synthesis of polymers. And again, when we talk about polymers, they are commodity materials, and they are produced in tons of quantities, unlike the drug molecules or pharmaceuticals, which are produced only in few grams or few kilograms. But polymers are produced in ton quantities. So obviously, the demand is that the reactions which we make use of to synthesize polymers have to be amenable to scale up. And why do we use polymers over other materials? Because of their cheapness, meaning they are low cost and high performing. Okay? So these are some of the points which one needs to keep in mind, or one needs to take into consideration when you want to design and synthesize the polymers. Of course, this is something very trivial, but I tell you what, there are only handful number of organic reactions. And one day, the method which Dinesh has developed to form amide bond formation, and as you know, nylons are produced in ton quantities. So that's the kind of impact, the developments in organic chemistry can make on polymer synthesis, okay? The reaction which, if you can bring down the cost of polymer synthesis even by 1 paisa, it has got a huge impact because the polymers are produced in ton quantities. So to come back to the point, there are hardly handful number of organic reactions which are used to polymer synthesis. When I say polymer synthesis, I mean on industrial scale, like basically like esterification reactions, which is used to make polyethylene terephthalate, or amide bond formation, which is used to make polyamides like nylons, then polyurethanes and phenol formaldehyde chemistry. And in the arsenal of organic chemistry, the reactions, recently in the last 20 years, the reaction which has been introduced to synthesize polymer is the click chemistry reaction. Of course, just again for the benefit of students, click chemistry is not a name reaction, unlike name reactions which you study. It's basically a concept, and I'm going to tell you exactly which reactions are categorized under click concept, okay? There are again only few good reactions which are considered as the click reactions, and polymer chemists have taken advantage of those concepts, which have been developed by the great scientists like Barry Sharpless, etc. And these are the, photographs I'm sure you all are familiar with. Of course, there are, I think around 30, 40 reactions which can be categorized as click reactions, meaning the reactions which are, happen very quickly, reliably, and in quantitative yields without any byproduct formation, or if there are any byproduct formation, those should be easily removable. Like, polymer chemists cannot afford to purify their monomers or polymers on industrial scale by techniques which organic chemists use in and day out, like column chromatography or vacuum distillation, etc. Those are, not being considered for industrial exploitation. So the reactions which we want to make use of for polymer synthesis has got very high demands, in terms of like selectivity and quantitative conversion, okay? And also similar demands are put on the monomer purity. Many times, people think that, making polymer is a trivial job, but it is not. In fact, it is much more demanding than making an organic molecule in the laboratory, okay? It has to be, monomer has to be 100% pure. And the reaction should be very high yielding, no byproducts, etc. Okay? That's why only few reactions qualify. And like I told you, only the click chemistry concept has recently been introduced, in the last 20 years. And polymer chemists have exploited this reaction, not only to make new polymers, but to also make these kind of macromolecular architectures, So polymer is not like about something material which is uncharacterizable, This is what the notion generally people have. But polymers are actually precise molecules, okay? One can control the sequences, one can control, the structures like block copolymers, star polymers, graph copolymers, etc. And this is what actually gives newer properties to the polymers and consequently newer applications. So why make new polymers is because, there is always a demand for newer applications of polymers. That's why new polymer structures need to be designed. Now there are basically two approaches, again, just again very for the benefit of students, wherein you can make a preformed polymer. Make a polymer and then carry out the post-polymerization modification reactions on this preformed polymer here. We can make a polymer, then introduce some functional groups, and then convert that into clickable groups. But this approach has got certain inherent disadvantages. Because when you are talking about carrying out an organic reaction on a preformed polymer, there are limitations like incomplete conversions or cross-linking reactions or degradation kind of reactions. So this is not a cleaner route to make polymers of desired architecture. So there is another approach, that is the one wherein you can use functional monomers, meaning you have the built-in clickable functional groups. Of course, sorry, I didn't mention about what those clickable groups are, but clickable groups are basically the widely studied are one like azido groups or alkyne groups, which are highly energetic, functional groups, meaning the reaction can happen under milder condition or maleimide, anthracene, etc. And I think I can give another separate talk on what those click reactions are, but one can design a monomer with a clickable group. Then if you do so, then you can precisely control the amount of clickable groups which are present in the polymer chain, okay? And there also probably location in the polymer chain. That's why the functional monomer approach is a preferred one for making clickable modifiable polymers. And that's why, we actually exploited this particular route rather than going for this post-modification approach. So design and synthesize clickable monomer. So I told you, we have entered into this area about a decade ago, and this click chemistry is just hardly like a concept which has been evolved over the last 20 years. So, we had an opportunity to be pioneers in this area, exploitation of click chemistry in polymer synthesis. So before I entered into this area, lot of monomers which were aliphatic in nature. As you know, the polymers are aliphatic type or aromatic types, okay? And aliphatic polymers don't have, extraordinary properties, like high temperature properties or high mechanical properties. Of course, aliphatic polymers have got different applications. Aromatic polymers have got different applications. The point I'm telling you here, this was a research gap which we had identified. And that's what is very important. When we do research, we need to find out the unsolved problems or what are the pending issues. And that's where, we actually designed and synthesized several difunctional monomers, and which I'm going to summarize, rather than, talking about the polymer synthesis and properties, I would rather like to focus more on the synthesis of monomers. Of course, I tell you what, why the world needs high performance polymers, because there are very demanding application, and when we're talking about the space missions, etc., and we have been able to great success because of the development of high performance polymers, because those polymers are widely used in space missions, also in biomedical applications. And here are some of the examples, commercial examples of polymers like polyether sulfones, polycarbonates, polyether ketones. And what I would like to draw your attention is to carry out post-polymerization reactions on these polymers is a challenging task. It's rather a Herculean task because these polymers are not soluble in common solvents and you cannot perform the reactions. Because for reactions to carry out, you can do reactions on solid state, but those are incomplete. So these polymers are not soluble, or they contain, in the backbone groups like carbonate, etc., which are very sensitive to acidic conditions, basic condition, etc. So you cannot post-modify these polymers, and you cannot introduce intentionally functional groups into these polymers, which are desirable for certain applications. So this is what actually was the research gap. And to address these issues, of high-performance polymers, to make new structures and consequently newer applications, we designed and synthesized several monomers. Of course, this is the motivation of our work, is to design and synthesize a range of difunctional monomers. Again, I think this will definitely suit the audience here, because I see lots of organic chemists and polymer chemists. And then, of course, when we synthesize the monomer, I told you, it is not a simple transformation of organic reaction to polymer synthesis. We need to do a lot of optimization work for each of these polymer syntheses, and then do structure property relationship and demonstrate click reactions on these polymers, okay? And then demonstrate certain application. Of course, this is like a 10 years work, 7 PhD students, so I will not be able to summarize all of that here, but I will give you just a glimpse or a helicopter view of what we have been able to do. Again, we have to keep things simple, we have to always keep things simple. Like I told you, polymer chemists always are looking for monomers which are scalable, and the reactions which are textbook organic reactions. So in my presentation, you will see all the reactions which you have studied in your 12th standard textbooks. No fancy reactions, okay? No Grignard reaction, no butyl lithium kind of reactions. I mean, not that, we cannot make use of those reactions, but those will never see the light of the day, meaning one cannot exploit those reactions on the industrial scale. Or if at all they are exploited, they'll be exploited only to make some specialty polymers, okay? And not like commodity polymers or high performance polymers. So as much as possible, we have made use of inexpensive and commercially available raw materials, and also biorenewables, okay? Now today we are talking about, the morning we heard a presentation on green chemistry, where one of the principles of green chemistry is to make use of renewable materials, not to compete with the food chain, but agricultural waste materials. And of course, I know this is another my favorite topic, where we have made extensive contributions of using cashew nut shell oil for deriving monomers. But today I'm not going to talk about that. But we have actually made use of chemicals which are derived from lignin, which is the second abundant polymer available on this planet Earth. Okay, and so there is a continuous source of raw materials which you can get from lignin, and we have made use of those raw materials which come from lignin. Then of course simple reaction like textbook organic reactions and operating conditions. Then simple purification either by precipitation or crystallization to get the polymerization grade purity, meaning 99.99% purity, amenable for scale up, high overall yield, and versatile polycondensation chemistries, okay? And when we talk about polycondensation or step growth reactions, the monomers which we normally come across are either bisphenols, diacids, diamines, and diisocyanates, etc. Why so? Because these monomers are versatile in terms of the opportunities which they offer. And from polymer chemist point of view, bisphenols, I mean the monomers which contain 2 phenolic moieties, are darling monomers of polymer chemist, because one can make a range of polymers from bisphenols. That's why we have focused more on bisphenol chemistry. And here is an example, This again, I would like to emphasize the point here. What you need is a creative ideas, okay? In fact, this reaction can be done, the reactions which I have shown here can be carried out in any undergraduate laboratory. You don't have to work only in place like elite institution like IISc or IITs or National Chemical Laboratory. You see, these 2 simple starting materials, furfural and guaiacol or syringol, both these monomer chemicals come from agricultural waste product. So we are not competing with the food chain, and we meet the principles of green chemistry. It's a simple reaction, single step reaction, high overall yield. And it is again not yet another bisphenol, but bisphenol with a pendant phenyl group. And I can see the excitement in the eyes of Bapu and Nandu. One can do a lot of chemistry with the phenyl group. It can enter into Diels-Alder kind of reactions. Okay? So this is the power of organic chemistry. You can design monomers which only cannot, it can be used for making polymer synthesis, but it now gives you an opportunity to incorporate pendant phenyl group. Okay? With which you can do lots of interesting chemical modification, transformations, etc. And another reaction again, norbornene moiety. You can see again, with norbornene you can do lots of reaction like epoxidation, hydrocellulation, and click kind of reactions. Both these reactions are single step, high yielding. Of course, we are not optimized. And this is the work of 2 of my PhD students, Dr. Sachin Kuire and Dr. Aniket Tarnikar, who just was awarded PhD last month. So these 2 students did these simple reactions. And of course, this work has been patented. And what I say here is, particularly would like to draw your attention is, these are carbon neutral monomer. See, one of the allegations against polymer is that, polymers are polluting the environment, right? Because we take fossil resources and finally end up converting into carbon dioxide. But here is a case now, we derive the raw materials from nature, from bioresources, make the polymers, and when they are burned or whatever, incinerated, again, we are not contributing to CO2 emissions because the carbon was already there in the nature. That's why I call these are the carbon neutral monomers, and they are performance differentiated properties, not like, simple bisphenol, okay? Because we can get different properties. So that's the beauty of these two simple monomers, bisphenols, and we have done a lot of interesting chemistry using these bisphenol monomers. So the idea here is, these reactions can be done in undergraduate laboratory. It's a simple condensation reaction using, simple reaction setup, simple purification, and you have monomer which has addressed the issues, pending issues with polycarbonates or all those high performance polymers. The next is, again, this is the work done by a student of mine, Dr. Samadhan Nagne. He started with this bisphenol, which is made from livolinic acid. Livolinic acid is also a platform chemical. It comes from agricultural resources, and a lot of work is happening in the CSMCRI on conversion of livolinic acid to gamma-varidolactone, etc. So we have made use of livolinic acid to make a bisphenol, and then using some textbook organic reaction like esterification, reduction, bromination, nucleophilic displacement reaction like agitation, reduction, and then maleimide formation. So you can see a family of new monomers was generated starting from livolinic acid. And all of these groups, what you are seeing here, azido, amino, malimido, these are all clickable groups, meaning they can take part in quantitative reactions. Okay? So that's the beauty of this synthesis. And this has, of course, has been patented. And a lot of companies have shown interest, on exploiting this chemistry. Sorry, I think I'm going ahead. Sorry, why is it not going back? Go back. Of course, this is little more, multi-step synthesis. Again, as a polymer chemist, we do a multi-step synthesis, okay? This was with some special purpose. I will not get into the further details, but these are the clickable monomers having, 3 different types of clickable groups, okay? So now you can imagine the kind of macromolecular architectures which you can generate with this. Like allyl group can participate in a different type of click reaction. Maleimide can take part in different type of click reaction. So and then, cyclopentadienyl, etc. So these monomers also have been made again from livolinic acid, but I don't publicize it so much because this is multi-step synthesis, which goes against our guiding principle. But we have still made these monomers because this will give access to new macromolecular architecture. This is again another very interesting diisocyanate monomer. Like I told you, bisphenols are the darling monomers of polymer chemists. Likewise, polyurethanes are the 6th largest polymers manufactured, in terms of the capacity. So diisocyanate monomers are also required, but most of the diisocyanates which are commercially available come from petrochemical sources. Now here we have made use of this livolinic acid, vanillic acid, which comes from lignin, which is an industrial chemical, which is used in ice cream, etc. So starting from that, again, through a series of reaction steps, which are very simple, which can be done in any undergraduate laboratory, we have prepared the diisocyanates. And again, these are just not diisocyanates, but diisocyanates containing clickable groups. Now, what these diisocyanates offer to us is this type of comb type of polymers, okay? And these structures were not accessible before. I'll just stop in a few minutes because I think, this is, you can see again, here, from 5-hydroxyisophthalic acid. So what you need is just a knowledge of organic transformations, like reactions of OH group, reactions of carboxy group. And this is what we have exploited, and you can see the library of monomers made from the simple chemical, 5-hydroxyisophthalic acid, which has also its bio-origin again. This diisocyanate with propygyl group, allyl group, anthracinyl group, and phenyl group, okay? All these are, again, clickable functional groups, okay? And you can see the kind of permutation combinations which one can make, using these setup monomers or the toolbox of monomers. Then again, this is something very simple. Students use phenolphthalein as the indicator, right, in acid-base titration. So phenolphthalein is such an interesting molecule. It has got the lactone ring and 2 OH groups. And what we have done is exploited the reactivity of this lactone linkage. And you can see again a range of monomers were designed and synthesized. And this is such a simple synthesis. Again, it can be done in undergraduate laboratory, commercially available, inexpensive starting material. And it has got this Cardo unit, rigid unit, which will alter or tune the properties of the polymers. So using this phenolphthalein, we have generated again norbornene, maleimide, azido, amino, etc. And this has been again heavily patented and also published. And some more publications will come, in this area. And this again, cyanuric chloride, which is industrial chemical, again exploiting the reactivity of chlorine atoms. And as you know, the chlorine atoms, one can actually selectively react, like replace one chlorine at a time, 2 chlorines, 3 chlorines. Like that, we have, again, my student Kavita Garg, she has generated a library of monomers containing cyanuric chloride, okay? This again, what can go on, like I think, like Sheshji mentioned, sky is the limit. Just, creativity. The question is, we have to make the molecules with purpose. So whatever molecules we have made so far, they are made with some purpose in mind, okay? Using those simple organic reactions, and which will solve some of the pending issues. So now you can imagine, the kind of breadth and depth what we have been able to achieve in terms of the introduction of aromatic step growth monomers, which are new to the world, to solve some of the problems with high performance polymers. So since Shesh has actually given me the alarm bell, I will like to probably end here by just telling you that we have generated a rich variety of aromatic step growth monomers which could be exploited. And I hope the students will be able to draw inspiration from this presentation, that we don't need fancy laboratory. Of course, what you need is the bright ideas, and one can really make a difference, or one can make a contribution. And that's what the teaching of Professor Pramod Mahulikar is. And I'm going to speak on this topic, maybe tomorrow, okay? So one can, need not keep complaining all the time that I don't have this facility. So what you need is basically those bright ideas. And many of the earlier speakers also, and everybody has talked about that, right? They all don't have, all extraordinary facilities. What they have is, I think, the brightest of the ideas. So with this, I would like to stop here, and would like to thank the organizers again for giving me this opportunity, and would like to thank the audience for the patience listening. I would be happy to take any questions if you have.
Thank you, sir. Any questions, audience? I think everyone understood very well. I can believe that. To add in sir's achievement, I just forgot to mention, sir has published more than 240 publications, international level, 24 patents. That is a big achievement. Yeah, like Vice Chancellor sir was saying, we patent only few and so on, but 24 international patent, only 3 Indian patents. Why, sir?
I have not updated.
Okay, sir, he hasn't updated. Okay. Okay, thank you, sir. Sir, I have started his, let me summarize sir's lecture. Sir, I have started using small organic molecule to make the polymers using a click chemistry, yeah, and bucket to rocket. The word, you must use that word in everyday life. We are from small town, we want to achieve the world. That's why you have to focus your study as well as in research to go abroad to make a rocket, yeah. We are in bucket now, we should be going towards the abroad for rocket.
By the way, Niranjan is here in the audience, he has actually
Okay, that's why. Sir also shown that simple synthetic strategy can be employed to polymer synthesis, but simple organic chemistry, what we think like I can make a carbon, nitrogen, all these molecule coupled together, that is not a strategy going to be working for polymer chemistry. There should be understanding, there should be focus, what purpose we are making them, that's very important. I think you all have enjoyed lecture because of that. There is no questions. Thank you very much, guys. Please join me to thanking Vadgaonkar sir. Thank you. I will give sir momentum and hopefully certificate. We are well in time. That's why I gave sir 5 minutes more. But Ankush, you won't get more time, yeah? Because people are waiting for tea. No, you can take time. Don't worry. If your lecture is interested, then we will give more time. Otherwise, no. Okay, Dr. Ankush Biradar is a principal scientist in CSIR, Central Salt Marine Chemicals Research Institute, Bhavnagar. Yeah. He earned his PhD from University of Pune, National Chemical Laboratory, Pune, because previously National Chemical Laboratory won't giving PhD. That is a related, means they should have the university joined with the NCL to give the PhD. Now NCL can give the PhD with their own independently. Ankush, wait, yeah. And completed postdoctoral fellow with Professor Asefa. We don't know him, but he must be did a very good place, his postdoc. From New Jersey, that means it should be good place, yeah, USA. His expertise spans homo-heterogeneous catalysis. We have seen Dinesh's lecture previously before Vadgaonkar sir. Yeah, that was also catalytic. Now we have one more catalytic reaction. We're going to enjoy that lecture. And mostly it's focus on nanocatalytic carbon-based material, because Dinesh was using different methodologies, but he is using carbon-based materials and metal oxide for development of environmentally friendly. That whenever you use this word, you will get grant, yeah? Remember, water-loving, environmentally friendly, you should start using this word. Guys, there is no tea, you can walk out. Process of biomass utilization, CO2 consumption, valuable chemical and fuels and so on. Biradar has published more than 100 international peer-reviewed articles. Wonderful. 15 patents. Now we are second machine coming out. Yeah, 24 patents Vadgaonkar sir has, but he didn't update his CV. Must be he has published more than that. Now the second guy, Ankush Biradar sir, has published 15 international patents, 3 book chapters. Ankush sir, how many PhDs? 5 PhDs. 5 PhDs completed, 5 PhDs working under his guidance. And he's looking, always he putting post on Facebook. He's asking others to send your student to my lab. You have a good chance to go Bhavnagar. He has guided 5 PhDs, as I mentioned. Let me over to the Ankush sir to give his wonderful lecture. Let's enjoy. Ankush.
Hello. Yeah. Thank you, Professor Bhosle, to introducing me to this audience. Basically, he has introduced to me this university, 2017. I came to take a viva of one of the student. So I connected well with this university, Professor Dalal, Professor Gite, and Professor More, Maulikar, Bendre ma'am, and everyone. And so on, I was always in touch with him, touch with this university. And always I tried to come over here. I generally drive the cars, and I enjoyed all the nature scenery. So that's how I got an opportunity to talk on this very noble occasion as Professor Maulikar is superannuating. And this is none than a great opportunity to talk my work basically. Okay, so thank you once again, Professor Dalal, inviting me to talk on this very well organized conference. And as I said, Professor Bhosle said, so we are always using the sustainability word, right? It catch always everybody's attention. Why it is so, right? So because same thing, you can see this local land, very nicely catched. You can see local land. What it mean basically? It means that whatever we do the research, it should come from the origin, from this native. It does not mean that the laboratory which is situated in the Jalgaon, or it is not situated in the Pune or Bhavnagar. It means that the research which can be generated basically, or it should be, we should address the world problem. Can we? That is the big question, right? Sorry. moving. Yeah, I said, it's always we see, everybody see, yeah, I have a problem. If you ask everybody, everybody says, okay, sir, I have a problem. Right? Even you ask the child, you ask the father, everybody's crazy. Everybody's crazy, literally crazy. What to do? Always earn the money, earn the fame. What we are doing basically? That is a big question. So, it always, I said this conference is well said, it's the greatest opportunity. What we can do basically for our mother nature, mother earth. Can we do something? So on this, as Professor Bhosle introduced that I'm working on different homogeneous catalysts, heterogeneous catalysts, high pressure reaction, CO chemistry, CO2 chemistry, and carbon-based materials. When I came back from the US, as I said that postdoc, so what to do basically? Because I want to start my own area, no one is doing this, our country. So coming from the basically, this is the problem as I said, we are always facing the problem. But we can see this. Everywhere the pollution is there, even you can go to all this, if you go to the north, lot of people are burning and we get lot of pollution, lot of CO2. And very recently we come across the Wayanad, right? Sudden rain in this one. Why it is happening? This is all giving us, every occasion giving us the opportunity to think. What should we do? Generally we should do in such a way that we should avoid the temperature. How can we develop? But this is the, this is the basically, everybody has a goal that after say 100 years now onward, the temperature, the earth temperature will rise up maximum 1.2 degrees Celsius. If you increase just 0.5 degrees Celsius also, it creates a lot of problems as I see in my previous slide. So what we should do basically? So this, the consequences comes from, as I said, 90% of whatever our earth is open surface is available, it will cover. So land is not there. So land is not available, then what will happen? So we are not sitting, we are not doing any conferences anymore. So we have to think for what we can do. As Vadgaonkar has said that every polymer, all the chemicals, whatever the billions of chemicals we are producing right now, it is coming from the fossil fuels. That is the basic. Whatever chemistry we do, we cannot avoid it. We can avoid it, but those are not scalable. There are hundreds of challenges. So we need to think of what we can get it. This is the basic issue, so we have to address. So address this, again the problem, as I said, sir said, so it should be two problems basically. One more is population. India is the topmost population. We have to feed them, right? If you want to feed them, energy needs basically, not only food, energy is required. And those energy coming from the fossil fuels. And because of that, we are always looking for the cheaper energy. How to get the cheaper energy, how to get the, where from it get it. Most of the petroleum fuels we are either buying from the Middle East, Russia, like recent war, we are very, very high problem. So this is always the problem. But again, another problem is that even we buy it, okay, we have a lot of money, we earn somehow, and whatever we earn it, 80%, 70% of the fuel we are paying for that one. Millions of dollars we are paying for that. This is one problem. Second problem, we are buying that fuels, we are inviting the problem. Because once we take the fuel, we burn it. If you say, if I burn, say 2.9 tons of, 1 ton of your fuel, it will generate 2.9 tons of CO2. So it's a huge problem. We are adding 36.6 gigatons of CO2 every year. So that is increasing the concentration of CO2. And increasing the concentration of CO2, it is act as a mirror. So it is not allowing to heat to generate, participate outside. That's what temperature is increase. So basically this is sorry. Okay, yeah. So this is what we expected, that we expect that population is going to be at 2050, it's to be 11 billion basically. It has to be, it is a projected. And what we need is basically for that, we need 63 to 160% of energy demand is going to increase, right? All these problems we are going to face. But we see, if you go back, as my earlier, all the speakers, they said, we have to start from the local, gaon, gar, ghara. So this is, if you see, everybody know what is this, no need to say this audience. This is cow dung, gauri, we say Marathi, right? Oh, sorry. No. Going back. You're doing. Okay, next. So you see this one. This is we are using mostly for heating the water, right? Or cooking sometimes, right? If you go to the South African countries, these people are using this energy. But you see, this all consists of lot of energy, right? We have a lot of energy. So this energy is basically, as you say that, as my previous slide, the energy source is we are using basically coal, natural gas and all. Almost, you can say 94% we are taking it up. And all the others is renewable energy. We are talking, big word is renewable energy that is coming from the different biomass and different geothermal, wind and solar energy. We are very, very less, only 6%. It has to go 70%. Then only we can sustain, we can survival in next, say, next decade, next century. So basically, very recently in the UAE, it has that is COP28 conference. All it is basically this is a United Nations conference where every year they met in different countries and they decide decide that what need to be the achieved the goal. So they in this 28 conference they said why not we triple that fossil fuels, reduce and use the biomass for this one. In this regard, so it is a huge opportunity basically for us. This is again the energy what I am saying, huge opportunity. The biomass, how can we can use it? In given a snapshot, as we get this 1.74 terawatt, 12 terawatt energy from the sun. So out of that, we only use basically 0.023% of this energy. And if this energy we can use it in somehow, so this biomass can help us to convert this one. So basically no need to inform this biomass what it is. Everyone knows what it is available. So in the next slide, you can see that this much biomass is available in India if you want to really utilize. So if you see all Maharashtra particularly, if you see what biomass is, wheat we have rice, we have bagasse, this much millions of ton is available. So bagasse is nothing but, as we know this all sugar factories, and they take the sugar and they, after crushing they throw it or they burn it, and the equal amount of CO2 generated after getting the minimum amount of heat. So that is the big we are throwing. Instead of that, what happened basically carbon cycle is, you take the biomass, if you want to really convert like fuel cells, it will take millions of years, right? So for that, you want to understand basically to do this research, we need to understand what biomass it is. You know, this is a plant. If you go to the little bit zoom, we can see that microfiber structure like this is consists of cellulose, hemicellulose and polycellulose. And even you can go through as a chemist, we can see cellulose, polycellulose and this one. From now you can see that we have a carbon oxygen bonds. And now carbon oxygen bond, like fuel, we can get directly energy. We burn it, but here we cannot get it. Only one problem is there. What it is? That is oxygen. That oxygen cannot go off easily. So to remove that one, we have to work on this one basically. Basically, if you take the fibers of this one, as a chemist you can see this, as I said, this cellulose, semicellulose, as Sir Wadgawkar was saying, that this is the polymer, even glycol from this lignin we can get it. Even we can zoom it, you can see this, all this, now we are here. So this biomass, as I said that I want to work on little bit on this conference, particularly talk on locally available energy source, which is every day we are seeing, right? Particularly, sorry. No, so not going back. Go back. Say, yeah, no, next. Yeah, you can see this biomass, you can see this tracks, and this, if you see this, we are the second largest producer of the sugarcane after Brazil. Brazil is the number one. We produce about 34 million tons every year. And we equivalent amount of sugar is, that much energy is available. So if you take this one, as we know, very simple calculation mathematics, if you crush 1 ton of bagasse, sugar, and we get about 250 to 280 kgs of bagasse, and from that we can get many like we use as a juice, we use as a sugar, other things are there, and then remaining this bagasse is just the fire and boil it and just throw it, and some lot of pollution will they generate. You see the lot of the chimneys. So as I was saying that So can we basically same thing as sir said, can we do the similar thing? As sir said, these are all bucket to rocket science applications. We can really do this one. So let me explain little bit my research on this one. Basically how this one biomass can be sent, can be utilized this one. So as I said, first this is the cellulose, hemicellulose we have to understand basically. And generally in India particularly or abroad also, whenever they biomass, they work on it, they generally they take the platform chemicals and they convert it. Okay, so here what I tried is we have to use directly biomass like bagasse, we can take it completely. And can we basically use these like this, any source of making chemicals, making carbons, making enzymatic. So let me start with the first one. So whatever the bagasse is available, so we can, oh sorry, this slide is double. Okay, so bagasse I have taken it and we can treat it basically as Professor Bhosle was saying rightly, we have to adjust such a parameter that which can convert, which can get a selectively one. So let me begin with one. So let me begin with, so whatever the cellulose, hemicellulose consists of bagasse, I have taken a hydrothermal technique which is very powerful technique basically, where it autogenous pressure will generate and there we can add a different catalyst. From that catalyst we can start with making the different carbon. If you treat with the different solvent, treat with the conditions, temperature, pressure, we will generate different. So in this case I have taken the cellulose, hemicellulose direct bagasse, where the bagasse I added the bifunctional catalyst like acid base catalyst, where acid will depolymerize whatever the cellulose, hemicellulose is there, and that hemicellulose it consists of HMF, 5-HMF, perfurol and all these chemical. And next is because of the high pressure and temperature and using the different source we can generate a different catalyst. So one catalyst we have prepared like this N containing carbon material, and that catalyst was well characterized with different techniques, the synthesized catalyst, whatever we after observation. And then you can see that PXRD pattern of this catalyst, synthesized catalyst. You can see that we have added nickel. We want to make the catalyst basically from the material, and that it is sure that nickel is present on it. It is in a different form because we have not controlled nickel 111 and nickel 200 planes. So because of this oxidation reduction environment, we cannot control it. But we can make it selectively nickel 0 by under control of hydrogen environment. And then you can see this, whatever I was saying that, sorry. It is back. Yeah. You can see that the Raman band, that D and G band does very well, and those D and G band confirm that my synthesized carbon is graphitic in nature and is graphitic in nature. And then you can see the solid state NMR, where we can see that 1 to 8, which is carbon-carbon bond, is well formed. So this all confirms that synthesized material is graphitic in nature, as well as nickel is present on this one. So next. So you can see that SEM and TM picture that the synthesized material is very ball-like structure from the direct bagasse, and you can see that a lot of nanoparticles are around it. You can see the nickel planes, D planes, and from that you can confirm that the synthesized material is nickel doped as well as in graphitic in nature. And you can see that all XPS also studies also show that it confirms the formation of nickel and this one. The synthesized catalyst was again do some organic chemistry, because Dr. Karate sir he just went off, but I learned from him, and then do some reactions. So I tried to start with the reductive amination, where we taken the biomaterial and nitro groups, where hydrogenation will happen first and then condensation. So all the parameters we have studied, and from that parameter we found out that this catalyst work for the reductive amination in one pot. The next is we also showed the different substrate scope, where we can use all the biomolecules, we can reductive aminate this one. And also we showed that the synthesis of some drug intermediates also, which can show that this is more applicable for the synthesis in any heterogeneous catalysis. And based on that control experiment, we propose the mechanism. In the second work, as sir was saying, that can we get this basically biomolecules. In this one, again we use the bagasse as the same, starting material where we get a cellulose, hemicellulose. From that we get this purpurol, this one, and then we in that case we added sulfuric acid as a catalyst where we sulfotate SO3H group were well functionalized. And these catalysts were again characterized with the different techniques like FTIR. We can see the SO3H group. We can see this CHN analysis, which confirms the formation of SO3H carbon. You can see the morphology. And we did again on this also, we used different catalysis. First is esterification condensation reaction, and second is different biosubstrate molecule we use for this reaction. Because as we know, as I said that we started with the solid base catalyst, solid acid catalyst. The solid acid catalyst also, we can take the purpurol and 2-methylfuran, we can get that this is a fuel precursor basically. And from it reoxygenate this, if you remove this oxygen basically, it will become jet fuel. So from the we optimize the different condition, and we found that under solvent-free condition this reaction works very well. Again, we showed that the just fuel we can try, we can explore in different grade of hydrocarbons, different hydrocarbons, and we can generate from different octane number of jet fuel grade, but we have not worked on hydrodealkylation because it needs a different setup condition. Okay, the third one is again one more important, as I said, a leonic acid synthesis is very important. So where we work on basically different conversion on using the as a solid acid catalyst. Okay, one before that, as I said, this is the work basically as we worked in NCL basically. So I started with this basically this work, and we can get from the direct bagasse, we have used the different catalysts, we can very beautifully carbon nanospheres. And this carbon nanosphere we can literally, sorry, excuse me, hello? Okay, and this also you can see that the same bagasse again, I have changed the condition, we can get different carbon space, different shapes carbon. So one last work I want to discuss basically, as the professor given me this warning bell. So we use bagasse directly, and from that bagasse we can synthesize this is a fuel as a bio oil basically. The same bagasse, one condition, different hydrothermal condition, we can take this product, and we scaled up. This is a half a kg batch, so we are working on it still to make a product, and the catalyst was recycled. Also, as I said, we are working on hydroformylation. Why not this carbon is used as a support? So having the hydroxyl group, so we functionalize the different ligand and use for the hydroformylation reaction, well characterized. You can see this different characterization. Also, one problem same bagasse, we have used bagasse. It consists of hydroxyl group, cellulose group, and there we functionalize with the different moieties like amine group, and then we carbonize, and we use for the CO2 sequestration reaction. The last work, sir, so I want to just pick up one, so this, no, this already I discussed. So this work basically is another one, as sir was also mentioning. So we have prepared a leonic acid from the direct bagasse. So no change, no pre-treatment, directly we have taken, we just hot wash, and we use different conditions basically and catalyst, and then we can generate literally leonic acid at very high scale. So this leonic acid has a lot of problems, as sir discussed. We optimize reaction conditions, and it shows that this catalyst can be, this bagasse can be used for the leonic acid synthesis. This is all characterization. So again, one more thing is in the same catalyst, whatever the solid we form, so we use that catalyst for the hydroformylation reaction to make again a fuel precursor. So with this, as sir has given me a short time, so I'll some of the slide I skip. So this is whatever the different biomasses is available. One is missing. I saw yesterday there are a lot of bananas are available, the millions of ton. So we can use that cellulose, hemicellulose to make these chemicals basically, not the material, because it consists a lot of potential, and from that we can do a lot of unit operations, and we can synthesize different bio-based molecules, and which can some, at least not 100%, but at least 5 to 10%, as we have a target about 43% to replace this one. So we can make this target and make this our little bit less burden on our Mother Earth. So with this, all this work is done by all the students. Particularly, I discussed with this guy, Krishnan, who really done amazing work on this topic. So once again, thank you for giving me this opportunity. Thank you for my parent organization, CSMCRI, and funding from the CSMCRI, my collaborator. And thank you one and all. Thank you very much.
Thank you, Ankush. Only 2 questions, guys. Anyone? First come, first be. Ankush, I think they understood very well. I can believe that. Dinesh has one question.
Okay.
Dinesh.
Yeah, it is stable. That's what I have not showed, but it is we are recycled up to 7 cycles. Okay. But after that, when we recover that catalyst, so we lose that catalyst, so we cannot recycle. But you can see that we have analyzed before the reaction, after the reaction. Particularly, we have very good technique, XPS. From that XPS, we come to know that this bond is intact.
No more questions? I can see a couple of people are sleeping still. Okay, anyway, guys, let me thanks Avinash, not Avinash, Ankush, because Avinash also my friend, Ankush also friend, that confused. Anyway, please join me thanking Ankush. I don't have to summarize because we have still 2 more lectures. Yeah, Ankush has done a lot of hard work, 115 publication, not a joke, in a synthetic organic chemistry. Let me congratulate him for his achievement. I think he got some momentum and certificate as well. Thank you. Thank you. Let's start. Another 2 speakers are on the queue. One more is R.R. Deshmukh sir from ICT Matunga, Mumbai. Matunga. Yeah. Sir has 25 years of teaching, UG, PG, research plus teaching experience. And he's a scientific advisor board of Bombay Textile Research Association, Mumbai. Research interest, material science, plasma technology, polymer physics, functional nanoparticles, so on. Most important thing, half of people are walking out. I believe so. There is no tea. Don't worry. If you go outside, you will have only water. 150 publication, not a joke. Continuously, we are publishing lot of papers. We can beat an international level. Yeah. 150 publication, about average impact factor 3.66. And sir's H index is 47, I index is 109. What is I index? Can someone tell me backside?
Thank you,
What
sir,
is
for
H index?
kind introduction.
Please, sir.
Anyway, we are running very late. So today I will be talking about RF pulse plasma surface modification of for biomedical applications. So outline of my presentation is, I will give you brief idea about what is continuous wave plasma and what is pulse plasma. Then I will cite few examples of controlling film chemistry. And then I will come to the topic, and I will be giving some idea about just 3 applications in biomedical field. So here in this slide you can see that plasma is kept on for some few milliseconds and off for few millisecond time. So in this time period, active plasma species are generated and their population increases. And even the plasma is switched off for certain millisecond, those active species remain in the plasma chamber and can carry out reaction further, but the next pulse should arise before all the species are depleted. So here, the effective power requirement as compared to continuous wave is very much less. The period is basically T on plus T off is the period, and the duty cycle is calculated with this formula, T on divided by the period, and the effective power is the total power multiplied by the duty cycle. So here you can see that in continuous wave plasma, when the peak-to-peak power is say 150 watt and the pulsing is 10 millisecond on and 50 millisecond off, so the duty cycle is 60 and the equivalent power is only 25 watt. So here the energy requirement as compared to continuous wave plasma is much, much less. And there are some other advantages as well that we are going to see. In case of pulsing nature of plasma, one can increase deposition rate by increasing the off period where the on time is kept constant. Here you see that when in case of continuous wave plasma, the thickness deposited for 10 minute deposition time is around 30 nanometer, and as we increase the off time, initially the thickness increases and then it decreases. So we have to find out what is the correct off time for a given monomer, and then one can get better deposition rate. Another observation from AFM study is that in plasma polymerization, it's a continuous deposition and ablation. So simultaneous deposition and ablation takes place. Therefore, film surface is little rougher. As we increase off time from 10 millisecond to 20 millisecond to 50 millisecond, so during off time, essentially etching is avoided and we get smoother and smoother film. Also, monomer functional groups can be retained in the off period. For some application, we wanted to have polymeric film having more bromine content. Bromine, even as such as a gas, is having refractive index 1.6, which is considered to be quite high for gas. So when it is incorporated into a polymeric film, obviously its refractive index will increase, and we wanted to have it for certain application. So we employed pulse plasma polymerization technique, and here you can see for continuous wave plasma, and then this time period 10 millisecond off, 25 millisecond off, 50 millisecond off, 200, okay, 100 millisecond and 200. As we and on time was kept constant 10 millisecond. So as we increase the off time, the retention of monomer functional group can be observed. So more bromine containing atom that you can see, this is dibromomethane, okay, was used as a precursor monomer. Maybe, yeah, from this diagram, it is very clear atomic ratio bromine to carbon that we have calculated from XPS data. And as a function of off time, you can see that the bromine to carbon atomic ratio, how it increases, and it is correlated with the observed parameter, that is refractive index. So we could vary refractive index from 1.743 to 1.932. Please note, in case of refractive index, even the change in second decimal place is also considered as a substantial change as far as refractive index is concerned. So here, ranging from 1.7 to 1.9 is a quite substantial change in the refractive index. Another example where we wanted to have quite hydrophilic polymeric film or the surface, and for that purpose we selected allyl alcohol as a monomer, and the film was deposited as a polyallyl alcohol, and here also pulse plasma was used. The lowest one FTIR shows 1 millisecond on, 2 millisecond off, and 1 millisecond on time was kept constant, and the off time was varied from 2 millisecond to 5, 10, 20 and 30 milliseconds. So as we increased off period, or we varied the duty cycle systematically in this way, it leads to large scale progressive change in film chemistry, whereas all other plasma parameters held constant. So here you can see that the retention of monomer functional group OH increases with increase in off period. And that was also measured, hydrophilicity was measured, okay. For that we measured contact angle, and contact angle, you can see that there is a decrease in contact angle as a function of off time. So several attempts people have made to control film chemistry, but our approach is variable duty cycle pulse plasma, because of which wide range of film chemistry is possible that I showed you. Surface chemistry is important for large number of applications. I have cited few of them: transforming surfaces from hydrophilic to hydrophobic and vice versa. For biomedical application, tissue engineering, creating biosensors, creating highly antimicrobial surfaces, drug delivery, creating biocompatible, blood compatible surfaces, so on and so forth. So there are certain attractive features of plasma surface modification. It is a single step, all dry process to minimize waste, so environment friendly, applicable to virtually any solid surfaces. Even nanoparticles can be processed in plasma. Only thing is that you need to have a different kind of design for plasma reactor. Plasma polymers are highly conformal, highly cross-linked, and pinhole free films can be obtained. Excellent control over film thickness, and wide range of film chemistry is possible with the help of, I think something, okay, no problem. So, plasma finds applications in variety of fields. First one, say, antimicrobial wound healing. Chronic wound impact healthcare system due to their increasing prevalence and cost. And wounds are harder to treat when infection persists within the wound. And if biofilm formation is there, then again it is a add-on challenge to treat such wounds. You may have to use, heavy dose of antibiotics, but still, bacteria may not be responding to that or may have resistance to that. So we need to have some other process of treating wounds. So we have created agarose and chitosan based scaffolds for this, and those scaffolds were, so we didn't have cryo bath at ICT, so this work was done at BRC. So we prepared porous scaffolds with the help of chitosan and agarose, and then these scaffolds were subjected to DPDSE plasma, diphenyl diselenium plasma. So very fine coating of this antimicrobial coating was offered on these scaffolds with the help of plasma. This typical plasma reactor was used for this purpose. We measured contact angle on both the sides of scaffold surface, though both the sides were treated. But since due to the porous nature, on the top side, its contact angle is little different than the one which was in contact with the petri dish. And also we did ATR FTIR study of it, and ACM also. ACM showed that there is some deposition on it, and from ATR FTIR one can see that good number of hydroxyl groups on other groups are there on the surface. Oh, I think this animation has made some, anyway. So to understand the surface chemistry of untreated and DPDSE plasma treated scaffold, this is survey scan. Here you can see that the selenium, though small amount, is deposited on the surface. And here you can see that in case of untreated, selenium is not there. But in the selenium plasma, when the scaffolds were treated, close to 1% selenium was there. Also, there is increment in oxygen and nitrogen post plasma. Normally, it happens when anything is put in the gaseous plasma or some after that, post plasma exposure of samples interact with the oxygen and the nitrogen present in the air, okay, and due to that you can see that there is a slight increase in oxygen and the nitrogen, okay, but we are more interested in having or knowing whether the selenium is deposited on the surface, and yes, it is there. Okay, so whether those scaffolds, oh, sorry, yeah. We carried out a cell viability study, and plasma process scaffolds or plasma treated scaffolds have good cell viability, and it was studied for two different kinds of human dermal fibroblasts and human keratinocytes. Okay, these two different cell lines for that we studied, and you can see that these scaffolds are not harmful to human cells. Also, we have determined in vitro disdiffusion for two different kinds of bacteria, S. aureus and S. epidermidis, and here for untreated, okay, you can see that there is no zone of inhibition. For 40 minutes, yes, little bit, 60 minutes it is increased, and 80 minutes and then 100 minutes, but we found that the 80-minute plasma treatment is having zone of inhibition 24 millimeter, and here 26 millimeter in case of S. aureus and S. epidermis respectively. So it is a very good zone of inhibition that we could obtain due to this pulsing nature. Also, we perform MTT cell assay, and these are confocal microscopic images for untreated and plasma treated. This green light that you see is basically for live cells, and you can see that in case of plasma treated, okay, the cell adhesion and proliferation occurred, okay, and that is an indication on these from these two images that you can see, and that too also for both the kinds of cell lines. Okay, and also in vivo we studied the wound contraction, wound healing also, and we found that in the rat model where we applied this DPDAC deposited scaffolds on the wound, the contraction rate and the wound healing rate, okay, was better as compared to pristine scaffolds or untreated. I think I can skip this data because it is not even readable from long distance. Yeah, so here even we have determined hydroxyproline content, and the hydroxyproline content for standard betadine applied wound is 6.35, and in case of plasma treated scaffolds it is close to 6. So this hydroxyproline content more, it means that the collagen formation is better, so wound healing is better. So hydroxyproline content is an indication of how wound is getting healed faster. So this shows that scaffolds which are plasma treated, okay, shows better and improved hydroxyproline content. The another application is enteric coating. So enteric coating on nano or submicron size drug particles using pulse plasma. We use 360-degree rotating reactor to coat these particles. This is actual setup in the laboratory. So functionalization of nanomaterials is also possible in this 360-degree rotating reactor. One can attach like carboxylic groups, amine groups, or hydroxyl groups, or any other functional group onto these nanoparticles, and it can find applications in variety of fields. So these are the videos actually. Maybe can you click on the images so that you can see that glow, pink color glow is plasma, and this is 360-degree rotating reactor, and yet the vacuum is also maintained. It is rotating and the vacuum is maintained. The beauty of it is that at each and every cycle these nanoparticles are taken up and they freely fall in the plasma zone so that all the sides are equally treated. The other one also you can click. So here I have stopped the rotation just to record the pulsing nature of plasma, like a flickering of plasma that you can see pulsing on and off, okay, few milliseconds on and few milliseconds off. Okay, so what is enteric coating? Enteric is basically a small intestine, and this coating is offered on a drug so that this drug safely reaches to the intestine and not released into the stomach, right? Because there are certain, and of course there is a difference in pH values. In stomach, the pH is around 1.2 and intestine it is 6.8. So basically enteric coating is in a short, it's a pH sensitive coating basically. So there are, why enteric coatings are required? There are 3 reasons: to protect the stomach from the drug. For example, non-steroidal anti-inflammatory drug, commonly called as the painkillers, if they are continuously taken, may hamper stomach lining or may create some, ulcer, or may lead to bleeding in the stomach, right? So this is the effect of a drug on the stomach. So such drugs are not to be released in the stomach. They should go to the intestine for absorption. Another one is to protect the drug from the stomach. Sometimes what happens that the acidic medium which is there in the stomach, or some of the enzymes which are present in the stomach, they severely damage, or sometimes, because of that, we feel uncomfortable, nausea, right? So in that case also, that drug should be, protected from the stomach. And the third one is to release the drug after the stomach, cost effectiveness. It is possible that as we grow, old, or at old age, we may have to take some supplements, right? Maybe some in the form of powder or whatever is, or even some medications. And if 50, 60, 70% of it gets damaged due to the stomach acid, so it means that if we are spending 100 rupees for that, and 50% is damaged, so we are getting only in return only 50, right? 50 rupees. So in that case also, it is necessary that whatever the supplements we are taking, and if it is adversely, that stomach acid is adversely affecting on it, so it needs to be protected. And it is more meaningful to coat nano or sub-micron size particle individually rather than a tablet or a capsule. Currently, entire capsule is enterically coated available, or the tablet enterically coated available. For example, Ecosprin. Original drug is aspirin. You know, right? Now the Ecosprin tablet is very small. The aspirin was bigger one. Since it is enterically coated, its bioavailability is now enough. So therefore, small quantity of drug is sufficient now, right? So there are certain criteria for enteric coating, that it should withstand at least 2 hours in stomach acid. And once it reaches to the intestine, that coating should disintegrate in 12 minutes so that the drug is available for intestine to absorb it further. And the coating material should not be harmful to the body or should not form any complex with the drug itself. And the coating should be pinhole free and uniform. If the coating that covers, say, 90% part of the drug powder molecule, powder particle, and 10% opening is there, or if some voids and the cracks are there, through that also stomach acid can enter and damage the drug or can have some other reaction. And it should be cost effective and environment friendly. Okay, I can skip this. Now in order to visualize how it works, okay, this is some different work than that of the medication, but what we did here, we coated red dye particles for visual effect, and then you see here Can you just click on the image? So this side, you see uncoated particles, and coated particles are put here, and the pH is same as that of the stomach. But when we adjust the pH of the right hand side equivalent to the pH of the intestine, you can see that the coating disintegrates, and this is just for visual effect that we prepared. So this is how it works. Similarly, we coated this omeprazole. Basically, when released in stomach, it stops, producing acid. So it should be released in the intestine, and therefore what we did is, so omeprazole drug particles were coated in the plasma environment, and then the tablet was made. So when such tablet is taken, so the drug particles are disintegrated, but on each and every particle the coating remains in the stomach, and then they enter into the intestine one by one. As they enter into the intestine, the coating is removed and the drug is available for intestine to absorb. So this is what we have done, and for more details you can see this Journal of Drug Delivery Science and Technology. Okay, I can skip some slides. This also. Yeah. And the third application is cold plasma processing of pharmaceutically active materials for solubility enhancement. So this work was done in collaboration with pharma department at ICT. Therapeutic effectiveness of a drug depends upon the bioavailability and ultimately upon the solubility of the drug. Currently, new drugs entrant into the market, most of them are poorly water soluble. And as a thumb rule, if the drug is not water soluble and if it is used as an oral medication, so its bioavailability will be limited. So its intrinsic dissolution rate needs to be increased. Then in such cases, what is done is basically either converting that drug into its salt, and you know that salts are soluble in water, aqueous, but sometimes converting it into the salt may compromise its medicinal value. Then another approach is reduce particle size to increase solubility. But with this also you can achieve limited success. So what we did here is we put it into pulsed oxygen plasma for very minimum time, and then we increased its intrinsic dissolution rate, thereby its bioavailability increased. And for that purpose we selected this ritonavir drug, which is used for antiretroviral therapy to treat HIV/AIDS patients, and the drug is costly. And if with this technology, if only 20 or 30% drug, if it is utilized properly, because the bioavailability is now increased, so we can treat many more patients, right? So in that sense we did this work. So you can see why this work is very important, because since the epidemic, 75 million people have been infected with HIV and 32 million people have been died. So we selected this drug. So our objective was to increase its solubility and then increase its intrinsic dissolution rate, thereby its bioavailability will increase. So that was our objective. And we use this novel pulse oxygen plasma treatment to increase that. And we also studied it thoroughly, whether its chemical structure is changing too much or minimal changes are there. So we did NMR and all those things. I am not going to present here all these things. So here in this table you can see that the solubility of untreated drug was 16 microgram per ml, And with plasma treatment, we could achieve it more than 90%. Okay, sorry, 90 microgram per ml, that you can see that. And since the solubility is increased, it means that its intrinsic dissolution rate, IDR, is also increased, that you can see. And hence, its bioavailability also increased, so that the less amount of drug would be effective in treating HIV and AIDS patients. Here you can see that in these bottles, this is not soluble at all. And here plasma treated, okay, that you can see here how they are, getting dissolved in it. So pulse plasma, RF pulse plasma processing helps us to make ritonavir hydrophilic, thereby enhancing bioavailability. No change in chemical structure, and hence drug activity is not hampered. Of course, I didn't present here NMR and all those things. And the technique is environment friendly. Thus, pulse plasma processing is a powerful technique to control film chemistry for various biomedical applications. Thank you.
Thank you, sir. Only one question, audience. Otherwise, we can discuss during tea. Vadgaonkar, sir.
When you say externally, what does that mean? Is there any bond formation or no? No, but can you really call it as the same chemical structure then, when there is some additional... Okay. You mean only some particles are getting, okay. Okay. I don't know.
Okay, everyone. Please join me congratulating Deshmukh sir for his wonderful lecture. Now there is slight change. Narendra Singh sir will be presenting afterward. Now we have online lecture, and after that we will have great tea time. Yeah, we can discuss during tea time. But there will be online lecture now. You shouldn't go out. We should learn the technology we learned last 2 years during COVID time, how word becomes small. Yeah. Let me felicitate Deshmukh sir with a token of love from. Okay, before we start, sir, I will give you some brief introduction about Devan Sohan. He is from Department of Chemistry, Research Institute of Convergence of Basic Science, Hanayang University, Seoul, Korea. He is a research scientist from 1987, and before that he was a postdoctoral fellow at Wisconsin, USA. And before that, he was in Canada for 1906 to 1997. Now, Hong Kong, Professor Hong Kong University, Seoul, Korea, 1997 to present. He is a Dean of Faculty from 2012 to 2013. Now, presently, he is a Director from 2022 at Institute of Convergence of Basic Science. And what else I should say? Proud Alumni Board, November 2033. He is Polymer Society of Korea, Fellow of Polymer Society of Korea. LG Chemical Polymer Research Award he awarded in 2021. Best Scientific Publication Award co-faced in Korea 2008. And he has delivered many invited lectures. Now you can see his online giving presentation. That means he has delivered many lectures. Hopefully we will have great time. Sir, you will get 30 minutes. Please go ahead. Thank you, sir.
Hello, everybody. Can you hear?
Yes, sir.
Can you hear?
Yes, sir.
Okay, good. First, I want to sorry for not to be over there. I'm just using online communication like this. And also, I'm not in my office. I'm just in my home because this is the Thanksgiving holiday in Korea. So we have some sort of family gathering these days. So I'm just stay at home. So sorry about that different condition in here. And also, I want to thank
Sir, there is some small internet issue. Please go ahead, sir.
Okay, I want to just, can you see?
Yes, sir.
Can you see?
Yeah,
okay,
yeah.
good. Okay, good. My name is Daewon Son. As introduced, I am in the Department of Chemistry at Hanyang University. Before start the talk, I am going to briefly introduce the Hanyang University. Okay, and also I have a Indian student, Indian PhD student in my group, and we have very good relation with India. For the several researchers visited our laboratory for the visit as a visiting scientist a couple of years ago. And today's topic is about the hydrogel, but I want to just briefly what I am doing in my laboratory so far, and then focused on the hydrogel research field. Okay. Let's see. Okay, before start the talk, I want to just briefly introduce the Hanyang University. Okay, Hanyang University is in Seoul, and university is the first engineering school in Korea. We founded in 1939. Okay, that is the period of the Japanese period in Korea. So we started our university in 1939. That was the first engineering school in Korea. So that means during last 80 years, means 1960 to 70s, the development of Korea, totally depending on our alumni of Hanyang University. Okay, our university started from the mining department, and then chemical engineering and mechanical engineering, and then electronic engineering, and these days, very advanced engineering school is very strong. So last several years in Korean economic development, totally depending on our alumni. So we are very proud of the contribution of our universities to the development of Korea. We have two campuses. I am in Seoul campus, and we also have another campus a little bit southwest part of Seoul. And in Seoul campus, we have 15 colleges and 64 departments, and another campus also has this number of college and department. And the faculty members, the students in Seoul campus has around 25,000 undergraduate and graduate students, and the faculty members are around 4,000. That is a number. And also the budget is around 500 million US dollars, and total, including the other campus, almost 1 billion US dollars is the total budget of the university. And this is the world ranking of the university. In 2023, QS world ranking, Hanyang University was 157. And we were the 24 in Asian countries. And in Korea, we were number 4 in Korean university. We have around 200 universities in Korea, and our university is around ranking number 4. But I will just emphasize that we are very proud the number of alumni of CEO in companies. We are always number 1, because as I told you, we are the engine of Korea. We started from the engineering school, and many alumni of our university founded many companies, and we are still number 1 in the number of CEO in Korea. Okay. And this is just briefly introduced by myself. I got a PhD from Louisiana State University in United States. And Professor Paul Russo was my boss. Right now, he moved to Georgia Tech. And postdoc in University of Wisconsin, and Professor Hyuk Yu was my advisor. And also I did the postdoc in University of Toronto, and Eugenia Kumachiba was my boss time. And also I got experience in NIST in United States and Japan and Hong Kong and China as a visiting professors. And these are my international advisor to help my research field. Okay, and I am learning the physical chemistry laboratory deal with the macromolecules. So PPCL, Polymer Physical Chemistry Laboratory, is the name of my lab. And you can also scan this QR code to get some information about my research field. And my research field is the characterization of polymeric materials. So today I want to just briefly what I did so far. First one is the polymeric material in solution. And second part is the polymeric material at surface. And the third part is the polymeric material in bulk state. So briefly introduce some of the material and how we can characterize in solution state and also at the interface. And I want to just give some gel structures and bulk state characterization part. Okay, first part is the polymeric material in solution. Okay, the material we have to use, we call the HEUR. This is the hydrophobic and captive ethylene oxide uracil resin. That means which has the backbone of hydrophilic polyethylene oxide. This is the hydrophilic part connected with uracil bond, and the hydrophobic end in both ends is hydrophobic. We can control the length of the hydrophobic part and also the length of the hydrophilic part. In solution, these polymeric material could be dispersed. And then by increasing the concentration, these molecules could be make some self-assembled, some surfactant micelle structure, but these micelles are huge because it has the polymeric network. We can control the polyethylene oxide backbone, 2,000, 4,000, or 8,000, something like that. And also, we can control the hydrophobic part, alkyl chain 10, 12, 14, 18. So we are using the symbol of HUR 2, 10, means the molecular weight 2000 and the alkyl chain carbon 10. Okay, and we can also use this kind of symbol to the changing of the backbone, hydrophilic and hydrophobic part. By increasing the concentration, these micelle structures could be aggregated in solution, right? So we characterize these molecules, and also we apply these flower-like micelle structure to make some nanoparticles. That means we can just put some hydrophobic conducting materials in it. In that case, we can make some hydrophobic nanoparticles, and we can control the size of nanoparticle by using this polymeric material surfactant. Okay, we have studied these materials, and also we characterize the structure by using the fluorescence probe techniques, and also dynamic light scattering, and small angle neutron scattering and X-ray scattering, and molecular dynamic simulations. This is a conclusion how that the micelle structures are changed in solution. Okay, x-axis is the molecular weight 4,000, and alkyl chain lengths are 8 and 12 and 18. And y-axis is the weight percent. Means by increasing the weight percent, this red line is the CMC. That is the critical micelle concentration. So before this CMC, the molecules are dispersed. And then after this CMC, these molecules are gathered together and then make some flower-like micelle structures. Depending on the hydrophilic and hydrophobic chains, sometimes it can make unstable structure, and sometimes it can make some very stable micelle structures. We can characterize these conditions by using these techniques. Okay, that is one of my research field, and also we can try to with the molecular dynamic simulation. Means we can make the molecule in computer and then minimize the stable structure of these micelle structures in computer, and this is a process how that the molecule can make some stable structures, and then and how many molecules can make some stable micelle structures, and we could publish this kind of structure in the journal. So our research field, first subject, is using the several different techniques to characterize the polymeric material inside of solution. That is the first part. And our research field, second part is the molecules at the interface and the surface. This is one of the example so far we have done an oxadiazole type moiety, and this molecule core is the benzene, and the other side has alkyl chains. So tripod-like structures, and these molecules are used for the strong blue fluorescence dye molecules and electroluminescence applications with these molecules are known. So we prepare these molecules, large molecules, but it has the tripod structures, and we characterize how these molecules behaves at the interface. Okay, that is the subject so far we have done. And one of the technique by using we call the Langmuir-Blazek technique, we can measure the surface area A and surface pressure isosome means spread the molecule at the air interface and then compress, then we can measure the surface area versus surface pressure. Okay, in that case, at the beginning, it behaves like a gas phase, and then liquid phase, and then solid-like phase change. Okay, by using these simple techniques, we can characterize how that the molecules behaves at the air interface. Okay, this is the molecule, tripod molecule. The inside is hydrophilic, and then outside is hydrophobic. Okay, we know that the size of the molecules and then spread at the air interface, then compress the molecules and it increase the surface pressure like this, and then it has the plateau and then increase again. A little bit weird surface pressure and surface area isotherms. So what is happening in this molecule? So we characterize this molecule by using the X-ray refractivity measurement, means air interface by using the X-ray. We can just characterize in situ measurement of the molecular behaviors. The left graph is the angular dependent, the refractivities. At the low surface pressure, it has the behaves like this, and high surface pressure, it has the bump like that. When we feeding the data, then we can have the information how that the molecules behaves at the air interface. And then we know that the G-directional profiles of the molecules means at the beginning, and the molecules are huge, and then it can change their G-directional profiles. By using this data in situ measurement of the X-ray at the air interface, we could conclude at the beginning that air and water interface, that molecules at the beginning has a phase on both form. Okay, by compress the surface, increasing the surface pressure, then it can stand up to change to the adjoint structure. Okay, we can clearly see the length scale difference and G-directional electron density profiles by using the X-ray scattering. So we can conclude by using this kind of technique to characterize how that the molecules behave. Okay, these are the subjects we have done in solution and interface. And the last one is the bulk state. I will focus more focused on this subject by using the hydrogel structures. Okay, we tried with several different hydrogel systems, but I want to just introduce the hyaluronic acid. Hyaluronic acid is a very soft material, and this is a chemical structure. And you know that our skin and our body, between the cell, has the hyaluronic acid inside. So this is the part of the extracellular matrix. So this is biocompatible and could be used for the clinical and biological applications. Okay, so many papers are interested in tissue engineering and medical applications of these materials. To apply for the tissue engineering and medical applications of these soft materials, we need to control the softness and hardness of the hydrogel. Okay, this is the subject and aim for this research, how we can control the soft hyaluronic acid to hard hyaluronic acid hydrogel. Okay, so we adapt the technique by using the catechol technique, means this is a structure of hyaluronic acid. We can modify the surface of the carboxylic acid to catechol. And this catechol method is very well known for this kind of muscle could be attached on the rod in the seaside, right? This is the basic idea how that the binding process basically in the ions could be coordinated with the catechol structures, monocomplex or bis complex or twist complex, depending on the conditions. It can make very soft binding and very hard binding structures. So we adapt this technique to this hyaluronic acid to modify the structure of hyaluronic acid with the catechols. Okay, I'm gonna just skip the details of the synthesis. And one of my students to substitute the hyaluronic acid with this catechol, and we can make some around 40% substitute ratio of the hyaluronic acid. Okay, this is the NMR data. And then we found the optimal condition of these materials. This is a 1:3 ratio of iron and catechol ratio. And also we can change the weight percent, 1:3 weight percent, and also to change the ratio. And 1:3 Fe, iron content, and 3 of catechol, and 3 weight percent is the optimal condition to make a gel structure. And also we can see the different condition has different UV spectrum, means the 3 weight percent is very stable gel structures like this. Okay, this is the evidence of the gel structures. And also we can see the gel structures totally depending on the pH. At the very low pH, around 3 or 4 pH conditions, this hyaluronic acid is very soft. 7 to 8, a little bit harder, and pH 10 and 11 can make some very well-defined gel structure like this. Okay, this is very reversible process. You can just changing the pH. You can make some very hard gel to soft gel. Okay.
Son.
And this is the UV spectrum based on pH 3, 7.5, and 10. Low pH conditions as the monocomplex and absorption around the 700 nanometers shift to the blue shift to 570 to bis complex and twist complex. Okay, by changing the pH, increasing the pH, we can make some hard binding and strong gel structures. And also we can observe the microscope that the change of the structure like this. And also we can measure the viscoelastic properties of this hydrogel. And G prime and double prime is the Young's modulus and Ross modulus. And Young's modulus is the elastic properties, and Ross modulus is the viscous properties. At low pH conditions, it has the liquid-like behaviors. So elastic modulus is lower than the Ross modulus. And the high pH conditions, it has very strong, and elastic modulus is very high. Okay, this is one of the evidence. And also we can observe some of the difference mechanism to make a gel structures. After 15-minute curing time, that the gel structures are totally different behaviors. Means even at the low pH conditions, it has yellow colors and gel structure, and high pH condition has the strong. And this one is also reversible, but these are the totally different behavior depending on the curing time of the system. And by using the Raman spectroscopy, we can characterize the bonding chemical structure of these systems, and we conclude during this 15 minutes of the period, there might be some chemical structure change, means that ions changing their oxidation state and change their catechol structure to the quinone structures. Okay, means there might be two different mechanisms. One is the binding or coordination bond of iron oxide and catechol. The other one is the cross-linking of the structures like this.
Son?
I will just skip this part. And this is the same image of the gel structure before curing and after curing. We could see the gel structures like this, difference. And this is a conclusion of the gel structures. There might be two different mechanisms. One is the instantaneous, very fast process to make a binding that is based on the coordination bond and monocomplex at very low pH conditions and tris complex at very high pH conditions. That is the one mechanism to make a gel. Other mechanism is the catechol to quinone process. That is little bit slow process, but it can make another mechanism to make a gel. Okay? There might be two different, fast and slow mechanism to make a gel. I have almost time to finish. And also we try to with the X-ray and neutron scattering. We have a facility in Korea to characterize the structure, the gel. And the gel structure has the correlation lengths between the network, right? So we characterize by using this X-ray and neutron scattering. So on this data, when you're feeding, we can get some length scale of the gel structures. Okay, I will just skip the more details about that. But this is a conclusion. By using the X-ray and neutron scattering, okay, we could characterize at a very high pH condition, very well-defined gel structures. Correlation length is around 3 nanometers. And the microdomains that separate inside of the structures. Okay, this is the real systems we could characterize by using the X-ray and neutron scattering. Okay, and this gel structure has the self-healing properties, and we can report by using several techniques. And this is almost done. Okay, and in our laboratory and our department has the recently bought the small angle X-ray scattering facilities, and also we have many instrumentation to characterize the polymeric materials and composite materials. Okay, so if you have chance to collaborate, then we can just contact by using this QR code or my laboratory. Finally, I want to thanks to my former boss and also my students and postdoc and students, and special thanks to Professor Gite to give me a chance to talk today. Okay, that's it of talk. And if you have any question or comment, just
thank you, sir.
I will just appreciate. Okay, thank you very much.
Thank you. Please join me thanking Dr. Son.
Okay.
He's a professor in South Korea. Any questions, audience? Son, I think they have well followed your lecture. I think they are happy with your lecture. I think there is no more questions, and I think they are waiting for tea break. That's what I can see, like a couple of people walking out, coming back. There is no tea until your lecture finish. Anyway, thank you very much for wonderful lecture. I could have given you certificate and momentum, but you are not here. Let's. I will hand over to Gite sir. He wants to speak something.
Thank you, sir, for coming here and presenting your work. So I think I'm out visible to you. We were eagerly waiting for you to be here physically, but however, you made it online at least. So we'll be waiting once again for your physical presence next time whenever possible. Thank you.
Sure. All right.
Thank you, sir.
Thank you very much. All right. Thank you so much.
Thank you. Thank you.
Good.
Thank you, Professor Bhosle, sir, for chairing this session. Friends, we will be having 10-minute short break of tea. And once again, we'll gather in the same hall for next two important lectures. Thank you.
शरीरा
यह रंगों का देश है। यहाँ विविधता में एकता और एकता में विविध
के वापस आएंगे सरगम के बाजे धाय धाय धम धम
इंसान को जीने के लिए
भाड़ा भरी की मेहनत
Good evening. Friends, now we are gathered here for the last session, that is session number 10. And for this session, we have Chairman Professor K.K. Sharma from Department of Nanotechnology, Shivaji University, Kolhapur. So I request Professor K.K. Sharma, sir, to chair the session.
Check.
I request Professor Deshmukh sir to welcome Professor Sharma sir. Thank you, sir. Now I request Professor Sharma sir to continue.
Okay, yeah. Good evening to one and all. Yeah. So I'm grateful to the organizers, GOLD-CT 2024, for giving me the opportunity to chair this last session of the first day. And we have possibly maybe 3 or limited to 2 speakers because of paucity of time. And as we are running late, I will not delay much, and I would like to introduce the first speaker of this third session, Dr. Narendra Singh. Actually, Dr. Narendra Singh has earned his PhD from Guru Nanak Dev University, Amritsar in 2005. He began his postdoctoral research at Osaka City University, Japan, followed by positions at Yonsei University, Korea, and Robert Gordon University, Scotland, UK. In 2009, he joined the Indian Institute of Technology, Roper, and he is currently a professor of chemistry. He served as the department chair from October 2011 to March 2015, and later as the chair for the GATE exam. Dr. Singh's research focuses on the synthesis of organic materials for chemosensors and engineering application. He has successfully completed numerous national and international projects. His prolific research output includes 335 papers published in international peer-reviewed journals, predominantly in Royal Chemical Society, known as RSE, and ACS publications. Additionally, he has monitored 18 PhD students, 5 postdoctoral fellows, and numerous MSc students. With this brief introduction, I would request Dr. Narendra to please come on stage and deliver his talk. Thank you.
Yeah, thank you very much for the invitation. And so my work is concerned with, just a minute. Yes, so my work is concerned with the chemosensor which I am going to present today. So that is chemosensor development for environment monitoring. And earlier I thought a different type of lecture, but today I have seen that there are two parts of every lecture. One is your research, and other is motivation to the students. So I also continue with the same thing, that I will also motivate the student for commercialization of your sensor. Many of my sensors are there in the market, and how we commercialize, so accordingly I will start my presentation. If I have to divide my sensor work, I have three domains over there. One is sensor to determine toxin in soil and water. And once we know that we have the soil signature for Punjab, Himachal and Haryana, so once we know that this part of the country or this part of the state is contaminated with this particular type of analyte, then what we did, we make some of the strategy to remove those toxins from the water. Especially we take the industrial based water. So we have quite large number of consultancy projects from the industries where we treat their water, and after that this water become reusable in the industry. So basically we are, at the moment we are, if somebody is having some ETP plant, so we convert their ETP plant into ZLD plant, means zero liquid discharge from the industry. And in some of the cases where we are working for the industry, especially for the hand tool industry, there we extract nickel or chromium from the wastewater and convert it into nickel and chromium nanoparticle, nickel chromium alloy particle, and those particles are used in the Chima boilers, a boiler industry in the Punjab state. So to keep the time in my mind, so I will discuss this part and will not touch this part. For the students, I think everybody knows that what are the chemosensors, but again I am giving little bit of description that what are the chemosensors. Basically in my case these are the organic compounds where we have the receptor, and receptor is made in such a way that it has binding site. Then if these binding sites are in such a way that only one type of analyte is interacting over here and no other analyte is interacting, I mean to say, let us say if I have this water bottle, and if it is contaminated with some of the metal ions, so if I want the sensor for mercury, then only mercury should coordinate here, and this coordination event should be read out in the form of chromogenic, means color change. It can be fluorescent, or third category which we have recently introduced in our group, that is electrochemical sensors. So I mean to say, whenever some analyte is binding here, and quickly we have these three analytical techniques by which we come to know that how much analyte is present in the water samples, and this should be very selective. Otherwise it should give, some of the time it may give fast positive, fast negative, and in my cases I try to avoid those type of things. Let me start with the little bit, because everybody today was talking about little bit of their history, that how they started their work. So I also take into account the things that how I have started this work. Long back when I completed my PhD and after that postdoc, then I joined IIT Ropar, and I was the first faculty in chemistry department to join that institute. We don't had any infrastructure. At that time I thought, okay, I have a background of chemosensor development. Let me continue with those chemosensor. But I also want that it should be something new so that it gave me identity in the country. So then I thought, let's make chemosensor which are for environment and which are for biomedical analysis. So if I have to do environmental analysis or biomedical analysis, then there is one primary condition, that is they should be soluble in the aqueous medium. But if you see the structure of these compounds, now there is a lot of lipophilicity. These are some of the compounds which I made in my postdoc, and other people also made during that time. So I was thinking, if I utilize these compounds, these are the lipophilic compound, and they will not do the biomedical analysis, they will not do any environmental analysis, because they should be operatable in the aqueous medium. Then what I did for this one, I have synthesized a small molecule. Now, to keep my presentation very focused, I have taken only one example, that is mercury. Throughout my presentation, I am taking mercury only, although I have sensor for all type of metal ion, anion, biomolecule, various type of biomolecule, pesticide, large number of herbicide we have covered in our research, but I am taking only one example, that is mercury. So what we have done, we have synthesized this compound, and when it was interacting with mercury, there was a change in the color. Chemistry behind this concept is that one. Here we have conjugation, and when mercury is interacting, then this bond is breaking, and after that you have extended conjugation over here, and if there is extended conjugation, then homo-LUMO gap will decrease. If this homo-LUMO gap will decrease, then you will experience the red shift, and accordingly, if it was not absorbing in the visible range, and upon interaction of mercury, it should absorb in the visible range, and there should be the color, there should be the change in the color. However, again, the catch was that I could not realize the biomedical analysis or environmental analysis with this type of molecule because it's not water soluble. Then at that time, I heard that many people were talking about inorganic nanomaterial. I thought, let me start a branch of organic nanomaterial. Very few people were working for organic nanoparticle. Some of the people working in industry or some of the pharma industry, they were talking about something which is almost similar to the organic nanoparticle. Then from 2010 to 2013, you can see from this publication, 3 years we struggled to get the organic nanoparticle. All the time I was getting this type of organic nanoparticle where we have too much agglomeration. Then luckily in one of the attempts, we got nice organic nanoparticle. The catch was that if our material, this material was soluble in DMF and DMSO, and if I inject this material to the water, then agglomeration was happening. But if I control the rate of injection of this material dissolved in DMF or DMSO to the water, then we got this type of organic nanoparticle. And here the solvent composition is 99% water and 1% of your organic solvent like DMF and DMSO. So this is the nano suspension. And if you add 1 drop of water over here, then there is a change in the color. Now, commercialization was there always in my mind. And I don't know whether I got the right feedback from my seniors in IIT Delhi or it was a wrong feedback. They were saying, some of the faculty who were close to me, they say that if your work is not touching the society, then that work is not having any meaning, or in IIT system, you will not get any recognition. They gave me this type of feedback. So that's why all the time, commercialization was in my mind. So I tried to commercialize this one. Then the feedback from Punjab Pollution Control Board was that if we utilize this one, all the time we need a dedicated chemist. And they said that for our routine pollution controlling lab, we don't have manpower. How we employ a manpower who will make this nanoparticle? So this was the feedback which I have taken in a good spirit. Then I coated this material on silica strip, and this strip was changing its color. However, on silica strip, large number of organic chemists are there. So these are amine linkages. You know, if amine linkages are there, silica strip is there, most of the time, this amine linkages may hydrolyze. So this strip was not having good shelf life. Then I mixed this compound in polymer matrix, and here we have improved the shelf life up to 6 months. So then again, I contacted the Punjab Pollution Control Board or regulatory in the Punjab state. They said, yeah, it's a good achievement, but with this one, we can only say whether mercury present or not. We cannot say that how much is present. Means it's only a qualitative type of thing. There is nothing about the quantitative. Now the next target was to get something which should be quantitative. And another problem was the second feedback which I got from there. They said that synthesis. So they say it's a long synthesis. और उन्होंने पंजाबी में क्या बोला था? I narrate in the Hindi. They said, यदि ये कैंसर का भी इलाज करे, तब भी नहीं इसको कोई खरीदेगा because the synthesis is quite long. So then the next target was to shorten the synthesis, and second target was to realize something which should be qualitative, not only quantitative. So in the morning we have one-pot synthesis. So I skipped that what is one-pot synthesis. So I made this type of compound. Just you take 2-amino-bench-thiazole, this carbaldehyde, pyridine carbaldehyde, beta-ketoester, mix them together, just heat for half hour, and after that you will get the precipitate of this compound in a almost quantitative yield. So means I was happy that at least I have removed that problem of long synthesis. However, when I analyzed this one, it was working for mercury, and there were two problems. One problem was there was a quenching in fluorescence intensity. You know, always signal generation is welcome, like if you do the titration by adding phenolphthalein from colorless to colored, it's easy to determine. From color to colorless, very difficult to determine. So here the thing was happening. It was the quenching in the fluorescence intensity, which is not welcomed in spectroscopy. I know this fact. And second problem was that if there is a presence of chloride, then this system was not working. So again, I could not commercialize it. Again, I have to publish. And now there was another problem. There is a modulation at a single wavelength, and there are large number of problems if there is a modulation at a single wavelength, which I will discuss in next slide. So then what we did, we have made another type of compound where we have taken this compound, coated on zinc oxide. Why zinc oxide? Because zinc oxide is a quantum dot type of zinc oxide. So I can excite the zinc oxide at a wavelength where I can excite this molecule. So I mean to say, if this compound is coated on zinc oxide, I can excite zinc oxide and this one simultaneously, and there is a dual channel emission. Upon mercury binding, there is a shift in the mercury. You can see over here, and no that type of shift was observed for any of other tested metal ion. Then we have a ratiometry. If I take the ratio of these two, then I can have a linear arrangement over here. And there is another I should say, advantage that if I change one instrument to the another instrument, then there is no problem, because always we are taking the ratio. We are not taking the conventional monitoring at a single wavelength. So then the people said that, do we have some handheld device? So then my next research was to find out something like handheld device, because if somebody is living with the diabetic patient, you take one drop of blood, put on the strip, and you will having the reading. So my next target was to realize something which we can show some of the readings. So again, we did some organic chemistry. Here, the color was changing from colorless to yellow. And this was a 3D printed material. We have 3D print. So with this 3D printer, here we have sample slot, battery, excitation source. So if we put this strip over here, and if we add water contaminated with mercury, like 5 nanomolar, 10 nanomolar, 20 nanomolar, then accordingly we are getting different colors. The colors you can see like this. If we change the concentration of mercury from 1 nanomolar to in fact 2 nanomolar, 3, 4, like this way, so we have change in the color, which you can capture. You can capture the photograph with this mobile camera. You can capture the photograph with this mobile camera, and after that, you can break the pixel into red, green, and blue, and there is a linear relationship between green and the concentration of mercury. So from this linear concentration range, again you will get the data which will be giving you a qualitative analysis. However, there is a one catch, that if you change this mobile camera, let us say I have Apple, somebody is having different mobile camera, then accordingly you have to do the calibration. You have to again do the analysis or you have to make some of the arrangement. Or there is another thing, either you can go for mobile-based app. So then I thought, okay, we should not go with this one for commercialization. Then although we got very good results, you can see here the results that we have a quite linear relationship. Either I take water sample from the tap, from river, pond. So all the cases we had very good relationship, but because of one limitation that always we have to take the mobile photograph, and from one mobile to another mobile, it will vary. So I have not launched this one. So then we made another type of strategy. This is Arduino-based system. So let's we see. So now here you can see, if we put the strip over here, directly you will get RGB over here. And not only this, we can directly get the mercury concentration over here. So this was our first gadget which we made at IIT. And after doing this one, there was 3 themes in my mind. One was, let us make a system where I can analyze multi-analyte. In the previous example, if you see this one previous example, there is one catch. If I have to analyze mercury, then lead, then other analyte, if I want to analyze 10 analyte, then I have, at least I need this type of 10 units. So instead of 10 units, I thought I should be having only 1 unit, and all the 10 analytes should be analyzed by that 1 unit. So that was one theme, that is on-site testing of multi-analyte. Second theme was in my mind that real-time water monitoring means river is there, you throw your sensor gadget to the river, and you will get the data on your mobile. So both of these are our commercialized technology. We have data for this one. And third was that there must be some of the protocol which invented at IIT Ropar, and eventually it should become the BIS approved protocol. We don't have any success over here. Still, it's a dream. But here I have some of the results which I can show right now. For analytes, let us shift our talk about food sensors. So here what I have taken metal of complexes where the coordination sphere is guarded by solvent, some of the anions. So when meat sample or this mushroom sample is degrading, then they are creating biogenic amine. Which amine is, that is spermine or the spermidine. So when this spermine and spermidine is coordinating here, they are affecting the stereoelectronic parameter. So earlier it was having yellow color, and if some spermine and spermidine is there, its color was changing to blue. And with this one, we have made one envelope where this material is coated on one special type of silica, and there is one strip inside the envelope, another strip outside the envelope. If meat stored in that envelope is degrading, the strip which is inside the envelope, the color is changing to blue, and then you will come to know, okay, this meat is not good for human consumption. So this was 2 types of analyte we have seen, and just I skipped this one because within half hour I want to show many things. So I skipped this one, and directly I am coming to the one part where we analyze multi-analyte in one go, means 8-10 analyte in one go. Here we have used machine learning based approach, AI based approach we have used. So what we did, in human tongue, like we can have large number of tastes which we can detect with the tongue. Although today I have taken too much spicy food, so that's why after that I am unable to detect. Otherwise I can detect many type of taste. So metalloproteins are there, olfactory neurons are there, brain is the memory. So this metalloprotein we have mimic with metal complexes, olfactory neurons we have mimic with data processing, brain we have data processing system or data analysis. So how we did what we did, here we have taken metal complexes, here we have taken different type of analyte, and you can see the pattern for spermine. If you see the pattern for spermine, that is entirely different from another biogenic mean, means I mean to say that with this strategy, I am getting a unique signature for each type of biogenic mean, and then by using some computational approach, we have separated all the biogenic mean in 3 dimensions in this way. So simultaneously, we can detect all these biogenic mean. So in fact, this strategy was used by Excise Department of Punjab State, and we have one consultancy project to find out the origin of liquor, from which industry that liquor is originated. Because there was one problem in the Punjab State about illegal liquor sale. So the similar type of strategy we have used to find the origin of that liquor from any distillery. So small gadget, again I can show you small student gadget. Here we have this electronics, and here you can put all your sensors. We have 5 excitation source. You can see this color, blue, green, and orange. So these are the excitation source we have. So now you can put the samples over there. You can here put the samples. And first you have to take the background correction you have to take. So this is your background correction. You can see the speed of our sensor system. So now, if you put the samples over there, this is something like you have high throughput screening. That type of screening we have done with an gadget which is just 20,000, cost is just 20,000. Now you can see the data. So I skipped this pesticide analysis. We have sensors for this pesticide analysis, which recently, it seems to be recently, but 8 years old. And again, in organic chem I have. So applied material, I skipped this one. Directly I am coming to the real-time online water monitoring of samples. So what we did, so let us say if there is a river, let us say this is the river, and I want to know the pollution level of this river at different point, then we install water monitoring station at this point, at a distance of 50 kilometers in many locations. So now, if something happen in this stretch, then all these two sensors are giving the data which is okay, and problem is from here. And from the Gaussian nature of curve, you will come to know that exactly at which point there is a addition or unregulated discharge from the industry. So basically, what is the science behind it? First, I want to discuss the science. If I take the excitation emission matrix for deionized water, it's like that way. If I take the river water, Satluj river water at Ropar, so we have this type of pattern, which is exactly similar to the tryptophan-like fluorophore. Generally, if there is a pollution, organic pollution to the river, then there is an elevated level of bacteria, where in the bacteria we have tryptophan-like fluorophore, and my gadget is detecting this tryptophan-like fluorophore. If we have this type of pattern, it means BOD-COD is around more than 10. Here BOD-COD, I should say BOD is around 5, and here BOD is around 0. So with this library we have played in our sensor system, and you can see here we have installed. So this is Satluj river at Ropar. I have 5 minutes, 5 or. So this is the sensor system. Here we have sensor for BOD, COD, TDS, conductance, pH, and temperature. And this is attached to this tree. And from here, whenever it will be installed, after that, the data is wirelessly. From here, the data is going to the gateway, which I will show you. From here, data is going to this gateway, and from this gateway, it goes to the cloud, and we have one access code. If right now, if I give you that access code, with your mobile, you will come to know the level of BOD, COD, or all those parameters on your mobile. So here, one of our students, so he is assessing the data from this mobile phone wirelessly, although he is sitting very near, but wirelessly he is assessing this data. So this is about river monitoring. So this type of data you will get. So thank you very much for your time and patience. So I think I have saved the time for next speaker. So if there is a quick question, I can take 1 or 2 quick questions if you have.
Yeah, maybe we open to 2 questions. So anyone who has questions, please.
So if there is no question, it means either they have understood everything, I am too good speaker, or they could not understand anything.
Okay, yeah, it looks like they have understood all the things. But yeah, Dr. Narendra, it was a very nice talk. And particularly, you have given an example of lab to LEN. So lab, what you did in your research lab is being converted for the use in society by designing the device.
To the audience,
excellent talk.
To the audience, I can say that one of my formulation recently got the approval of SWIDEFCO for commercial production. And one company is producing that formulation for antiviral and antimicrobial coatings.
That's great news. Thank you. So without much delay, I would like to invite our next young speaker, Dr. Niranjan Yole, who is actually the ex-student of this School of Chemical Sciences, North Maharashtra University. He did his master's and completed his PhD degree in polymer chemistry in 2011, and then he was selected for D.S. Kothari postdoctoral fellowship at University of Hyderabad. He worked there for from 2012 to 2014, and during that time he published 10 peer-reviewed papers. And he then joined industry, and he worked for almost 7 years in various industry, including PI industries, and then Dulcera ITES company. And currently he is a scientist associate with Intellectual Property Group within this CSI, National Chemical Laboratory. And his responsibility is to implement and managing the IP portfolio of the CSI NCL. So without much delay, I would like to request Dr. Niranjan to complete within 20 minutes.
Yes.
Thank you.
I understood the context the moment the answer came up. So I will wind up within 20 minutes. So I would like to have an interaction-based session. So how many of you know intellectual property? Nobody knows? Don't keep hands down. I will consider nobody knows this, okay? Intellectual property, have you heard? Okay, a few hands are raising. So what are the types of IP? Yes, trade secret. Yes. And the other section is about SDG. What is the full form of SDG? Okay, I already kept it. So we will understand the correlation between the intellectual property and SDGs. And before starting, I would like to thank organizers, and this is like a felicitation to Professor Maulikar sir. Though he was not directly PhD mentor, but he was mentor for my project. So SAP, as Dinesh mentioned about the product of UGC SAP, I am also one of them. So earlier speaker talked about the commercialization. So he shown us what goes into the market. I will explain what is the requirement before going into the market. So we'll understand about the importance of intellectual property and the trends, how that based on the trend, what scenarios can be taking place. And thereafter, we will understand about one of the aspect of monomaterial, which is being used for the packaging solution. So that will be kind of a case study to understand what is the correlation and how it is impacting to the SDG. So first and foremost, who needs patent information or intellectual property information? I think each one of need to have, because it's like a digital world, and tomorrow will be very difficult if you don't go into because earlier it was like plant, property, equipment, tangible properties were focused. But now, henceforth, means earlier also, recent years, the progression if you see on, earlier in 1975 around, there was a focus towards the tangible asset. And there is a limitation because you cannot grow the land, right? There is a limitation. However, the knowledge created based asset, you can exponent to as much as possible. There is no requirement you can only limit to India jurisdiction based. You can extrapolate to other jurisdiction as well. So academic researcher need to know what is patent information is available, IP related stuff, so that they can design their project. Otherwise, it will be like a reproducing whatever has been already done, you will be repeating the same thing. So unless and until you don't do the same work, you will be not convinced to go forward. Similarly, R&D professional, because in industry, whenever you start a project, and industry means commercial, so they don't invest for just a fancy project base. It has to have a commercial value. From where that value will come up, it is from the patenting or IPR related information. Non-patent literature will give you the insight, but the patent related information will give you the exact scenario where and how you have to incorporate your knowledge. Similarly, the entrepreneur, let's assume entrepreneur doesn't do the homework of intellectual property analysis and he goes into the market and somebody comes up after, boss, I have an already IP protected, how come you are entering? And you will be in soup, you will have to pay the damages and it will be multifold. It will not be limited to XYZ amount, it will be always an 2x or 3x or sometimes 10x payment you have to do. So business professional, I will correlate as an IP professional also, I belong to that. So you will understand during the case study how the correlation takes place before taking any decision. In context of public policy maker, unless and until they don't know what is coming into the IP, they cannot design the policy which will be helpful for the social cause. So for example, in the health sector or the environmental issues. Let's say for example in pandemic, India and South Africa were the countries, they asked that there should not be monopoly related to the COVID related stuff. So this is done because they got to know in that sense that okay, so a few of the IPs were limiting the social benefit. So they said there has to be IP waiver, there should be no monopoly around it. So what is the benefit of patenting? It's like protecting whatever the invention or your investment has been done. The second is about the perfection, just to help avoiding the deduplication or the infringing of someone has already patented that XYZ invention. And if you do the same work, it will be like very mess up. And you need to do your homework first so that the protection, perfection, and the patent application get published after 18 months of your filing. So it like in public domain so that you can understand what is there in the public domain. And as I already mentioned about the business professional, the planning is the most crucial importance here. Yeah, so why patent information? I already explained, but let's talk about the statistics. 15 to 25% of all research efforts in WEN. This is regarding the European case study they had. Australian patent office has done the homework and they understood that the euro 60,000 million of wasted because they already been done. So it's kind of a repetitive work. So they that much of not only time but the resources have been wasted. So if you do that homework prior, you will save that much of amount. Even the Proventis, the tech transfer agency, they also did similar kind of a study, wherein they also understood that total 25% of R&D spending is been wasted because they didn't do this homework before investing in that particular project or whatever the work they are following. And the patents are like very unique information. You can get it very easily and free of cost. For example, the journals, you will have to pay a subscription fee to get the patenting journal access. Whereas patent information, everything is public domain. And in context of manuscript, you will not get the examiner comment what has been, queries were raised. However, in patenting, you will understand what examiner has raised and what applicant has answered. So you will understand to and fro of that particular information. So it will be really good homework to do instead of only following the non-patent literature. And there are additional benefits. It's like the structure is very appropriate in context of patenting. So you will understand even the non-English patent filing will also follow the same format. It will have a similar kind of an information. You can pitch upon where you have to extract that value. For example, the abstract will have specific designated code, title will have designated. So you can just simply copy and translate. Nowadays, it's like a translation is very easy. You can do it with all possible means. Yeah, as I mentioned that patenting information is free of cost, that can be available anywhere. And again, the budget constraint is not at all there. So now we'll understand about the monomaterial and SDGs. Monomaterial, the term itself says, okay, the single material. So we have heard earlier also today the polymer pros and cons. Being a polymer chemist, I will always say that there is a pros, but the cons are because of the misuse of those particular polymer material. So the single type of material is required. So if you understand the packaging, so packaging will have multi-layer content and it will have a different material assembled in each of the layers. Whereas this mono material will have an unique property wherein all this gas barrier property, transformation, so all these properties will be there in the single material. For example, polyethylene. Polyethylene is having a different kinds of LDP, LDPP, means depending on the density, you will have a multiple layers of LDP, and each layer will suffer from, for example, metallocene-based polyethylene. It will have a gas barrier kind of a property which is been provided by aluminum in normal packaging. So these are the material which plays a very crucial role. And the sustainability is about the balance between the social, whatever the going into the equity, or it has to have an uniformity around economy and environment, how it is been considered. So all this monomaterial and SDG, it's like this material will have an say in that, out of that 17, there are multiple numbers, 4 SDGs will it follow. That SDG 9 refers to the industry, innovation and infrastructure, wherein this encourages the innovation in packaging technology and infrastructure development. Whereas in this SDG 12, it's a responsible consumption and production, which promotes the sustainable material use and efficient recycling. So if it is a single material, you can recycle it appropriately. What is the problem in the multi-layer packaging at this moment? Similarly, the SDG 13, it's about the climate action, which reduces the environmental impact through improved recycling process. So all these are connecting. So the moment you have such kind of a project, which is about sustainability, which helps all these multiple domains, there are 17 SDGs. Out of this material follows through these 4 SDGs. So now we'll understand to the case study. So as I said, you will understand this data. It's like after whatever work is been done. But you need to do this before you start any project. So this is what the scope. It's about the finding out recyclable material relating to packaging industries. Out of scope. Regarding patenting, it's always, you need to define the scope always. And out of scope is similarly, you don't have to consider those documents which are falling under this recycled material use in the material composition. And these are the concept table which we follow for the patenting information retrieval. So if we see, while analyzing, Japan plays a very crucial role in terms of monomaterial, and they are the leader finding out similar solution. So that's a very big problem, but the Japan is taking a lead, and this information is been through the analytics we have found out, almost like while retrieval, I shown you in the earlier slide the concept table. Based on that, we made a strategy, and based on the strategy, we searched upon in the specific database, patenting database, wherein we, after filtering out, I said about the out of scope, so we filter it out those patent applications which talk about recycling based material, we filter it out those, and those are limited to only the product development associated to the monomaterial, which those were considered. So Japan plays a very crucial role, followed by China, and India is also booming up in this field. With the numbers, you can understand. These multiple countries are being followed. So it's like a geographical distribution as per our continent. So Asia is taking a lead, followed by Americas. So similar to the earlier slide, it's about the priority country code, wherein we understand that where the protection is being done prior, means the first filing where it is, so that invention is coming from which jurisdiction. So Japan is taking lead through the analytics which we have done. So if you see the trend, in earlier first objective I said, right, how the project can be decided. So if you see over the period of time, from 2019 onwards, you can see the very sharp leap in this monomaterial based packaging. And don't consider that 2024 is sudden drop, because we are yet to conclude 2024, and by the end of year it will have a more number of filings than compared to the 2023. So we understand the top players while doing such analysis. So we understand that this top-on printing, which is based in, headquartered in Japan, is taking a lead, followed by, you will understand the most of the countries, like a top-on printing, Dai, Nippon printing, so those are coming out of Japan only. So you can correlate that the industry followed by jurisdictions are very specific. So if we deep dive into the top players, so you can see that the top-on printing is playing a very crucial role, and the material they are focusing around PET, PP, and polyethylene. So as I mentioned that top-on has developed GL, that's a gas layer barrier, and which was having a unique barrier application, and it provides a variety of mono-material barrier packages with both barrier properties and environmental suitability for a wide range of product. By combining this GL rail, means replacing your aluminum with the polypropylene or polyethylene or a polyethylene terephthalate material they have made. Followed by this Dai Nippon, they are typically following this PP and mostly polyethylene based polymers. Next is about the BEMIS. You can understand, because of this patenting information, you can understand what are the collaboration, merger acquisition. Merger acquisition means the one company is taking over to the other company. Such kind of an business information also you can get it through the patenting. Dow is one of them. Similarly, the Borealis, it's again, you can go into the Europe now. So you can correlate all the jurisdiction and the top players and their material. Again, you can see that they are following the polyolefin mostly. And followed by this Constantia Flexible. So this is a European country, but it has an Ahmedabad unit, and the unit is specifically focusing towards this monomaterial packaging. You won't get easily that kind of an information through normal random search. Until and unless you don't do this patenting information, you cannot correlate, because once I got the top players, I searched only on the, we'll conclude, So Constantia Flexible search. So through that we understood that, okay, they are having a unit which is specifically focusing towards the monomaterial to achieve their, it's overall social SDG goals. Followed by this Fujimori, you can understand, correlate with the Japanese and Toyobo. So we, almost like from 2000 odd patent application, we could find out that there are 436 applications focusing toward the monomaterial for packaging. And these are the key findings which were already covered in our earlier slide regarding the quantums. And so through this conclusion, like based on the recent trend, there is a sudden sharp 2020 onward, 21 onwards, people are focusing to find out this monomaterial which are being used in the packaging. So if you talk about the business, this field is growing, and if you see that the annual average rate is increased by 4.5%, they are progressing, and so because of this information, you simply connect to the dots. Like if you normal do a search, monomaterial in packaging, the first word will come Unilever. But if you see the patent analytics, Unilever is nowhere, means it is at the last, I think 9th or 10th position. However, there is a collaboration between Top1 and Unilever. So this kind of a business information you can get, and that will be really helpful, because you can understand collaboration, where it is been taking place, and what will be the project focus around. And you can see that a few of the, we mostly heard about the patenting, but the sustainable value TM, it is been done by the Top1. So they, whatever the product coming out of Top1, they will be selling in this brand name called as a sustainable value TM. Yeah, so the moment you solve this particular problem of plastic pollution through that unique or best material, which is made with the single material, that will solve most of the problem. And with this, I think I made the time, and I can be have Q&As more. So yeah, that's it. That's it from my side.
Thank you, Dr. Niranjan. One question, if audience has got. Yeah. Yes.
Yes. Yes.
I would like to ask one question only, that if someone has published patent 18 months back, and today if I file patent for my own product, then how I come to know what has happened in that 18 months? Because the moment I publish my patent, it may be the prior art for me.
Yeah, so you touch upon very crucial aspect. There is an, whatever the publications are there in those 18 months, if we see the criteria required for the patenting, there is a novelty, inventive step, and utility. If your application in those 18 months, you are not aware of that publication. Exactly. So it's like an secret prior art. So that objection will be only based on novelty. So inventive step will not be objected. And again, it is again jurisdiction to jurisdiction. Law changes. US will have their different interpretation, and other countries, each and every country will have different law to interpret how they will evaluate this secret prior art. So as I mentioned, there are scenarios, because that is hidden, you are not aware of, but still there will be a question of novelty. You need to establish novelty to come out of that, that prior art, which is not there in the public domain.
Because we are facing such kind of challenges.
Yes. So just before concluding, I'll suggest all of you have your MSc projects, right? Keep such kind of an information so that your MSc project will have a valuation. The moment you go for the interviews, the moment interviewer sees this and they know that you have a commercial aspect knowledge also, that will be really helpful to summarize your project in a better way.
Our third speaker is Dr. B.B. Singate. He is a professor in organic chemistry at Department of Chemistry, Dr. Baba Sahib Ambedkar Marathwada University, Chhatrapati Sambhaji Nagar. He holds MSc PhD and he has a research experience of 22 years and teaching experience of 16 years. His research thrust area is design and synthesis of bioactive compounds and drug analogs, development of new synthetic methodologies, total synthesis of natural and unnatural products. He has in his credit 128 publication and an Indian patent has been granted and 3 are published. He has many awards in his name, and one of the awards that he has got is Indo-US Research Fellowship Award. Along with that, he has been a receiver of ISB Academic Scientist Award in 2023 from Indian Society of Chemists and Biologists, and he is also a fellow Maharashtra Academy of Science. He is a Best Chemistry Professor of the Year in 2020, given by Global Teaching Excellence Award. Then he is also ISB Best Teacher Award and given by Indian Society of Chemists and Biologists. So he, under him, 8 PhD student has completed and 5 PhD is working. And without any further distinction, I would hand it over the microphone to Dr. Singate, please.
Thank you, Sharma sir, for a nice introduction and kind words. I think this is the last lecture. It means that this is the last war. And I have to win the match or I have to lose the match. And as per the audience, I can consider that they want to win the match. Okay. From morning, we are listening in this particular hall. All these speakers are from national institutes or from foreign countries. I am the only person for today from State University. And I feel proud, in between the National Institute peoples, I am delivering a talk. being a teacher of organic chemistry, I have taken care of my students. And as rightly mentioned by various speakers, Professor Vadgaonkar sir, Dr. Vadgaonkar sir, and all other our senior colleagues, how to motivate the students, and how the research can be carried out at any places. Professor Sheshnath as well as Dr. Ankush, both of them have explained very nicely. And today, I will talk on, please share the slide. Yeah. Some of the job Dr. Vadgaonkar sir has already shared with you regarding one of the concept, that is click chemistry, a Nobel Prize reaction in 2022. Click chemistry inspired diversely functionalized 1,2,3 triazoles as therapeutic agents. And today I will talk on this particular topic. As these three peoples, Caroline Bertozzi, Morton Meldal, K. Barry Sharpless, all these three peoples have received a Nobel Prize in the year of 2022 for their contribution for the development of click chemistry and bioorthogonal chemistry. As Vadgaonkar sir has rightly mentioned that about the click chemistry, this click chemistry is nothing but simple cycloaddition reaction. As everyone is teaching to UG as well as the PG students, Diels-Alder reaction. And here click reaction is nothing but cycloaddition of terminal azide with the terminal alkyne. Sometimes internal alkyne is also used. Okay, and already discussed about how to prepare azides from various substrates. Okay, and I'm not wasting too much time on these particular things, but see, as rightly mentioned by Vadgaonkar sir, this Professor Sharpless, he is the only fifth person who have received 2 Nobel Prizes in chemistry. The first Nobel Prize in 2002, the discovery of asymmetric oxidation reaction. That is a Sharpless asymmetric epoxidation, Sharpless asymmetric dihydroxylation, and amino hydroxylation reaction. See, in the year of 2002, and the same year they have discovered the another reaction, and after 20 years he has received a second Nobel Prize. Means he is the only fifth person from the chemistry received 2 Nobel Prizes. This click chemistry is nothing but, it is not a name of the reaction. This is the just concept as rightly mentioned by Vadgaonkar sir. When we are traveling by car or by plane, just we are putting the seat belt, and there is a, see, like this way, when we are putting the seat belt, there is some noise or voice coming, that is a click. And from that terminology, first time, K.B. Sharpless have coined this term, that is a click chemistry. And we have seen there are several reactions under this click chemistry. See here, the regioselectivity regarding the click chemistry, reaction between terminal azide and terminal alkyne under Wujen condition. Means at higher temperature, it gives a mixture of 2 products, that is a 1,5 disubstituted and 1,4 disubstituted 1,2,3 triazoles. However, Sharpless, Meldal have discovered copper catalyzed azide alkyne cycloaddition reaction, and which leads to exclusively 1,4 disubstituted 1,2,3 triazoles. This reaction is a copper catalyzed reaction. But if you change in place of copper ruthenium catalyst, you will get exclusively 1,5 disubstituted 1,2,3 triazoles. See, as Vadgaonkar sir has given this particular point, click reaction would be the modular, be wide in scope, give very high yields, be stereospecific, generates only inoffensive byproducts, and it can be isolated the pure product by means of crystallization simple. Okay, and see, click chemistry is a simple name for a simple set of reactions that are extremely ideal for working with organic molecules, and this particular terminology is explained in his famous paper of Angchem International Edition in the year of 2001. Now I want to put why people are working on click chemistry. See, the journey of click chemistry started in the year of 2001. The first paper in 2001, and so far the data for the September 12 of this particular year, total publications are 20,000. more than 20,000. And for the year of 2024, yet not finished, but see the number of papers are 171. And for the year just 2025-09, means the graph has been drastically changed, and the number of publications are too much on the concept of this click chemistry. Why click chemistry? What is the significance of click chemistry in terms of medicinal attributes or pharmacological significance? These are the molecules so far in the market having a 1,2,3 triazole skeleton. 1,2,3 triazole skeleton, for example, rufinamide, CAI, TSAO, tazobactam, cepatriazine, and IA09. These are the molecules. From morning we are listening about the materials, but we used to call it molecules. These molecules are in market, and several molecules are under clinical phase trial 1, 2, 3. Okay. Then, why these 1, 2, 3 triazoles? These triazoles displays various kinds of biological activities, including anti-cancer, anti-HIV, anti-inflammatory, anti-hepatitis, anti-diabetic, antibacterial, anti-tubercular, antifungal, Alzheimer. And so far, more than billions of the new molecules people have discovered, synthesized, and studied their different kinds of properties. It may be therapeutic properties, some electronic properties, or these molecules are used in material science as well. Okay. Here, without taking too much time, just I am shifting towards our contribution in click chemistry. As this particular concept, as Vadgaonkar sir mentioned, 10 years before, actually we have also started 12 years before, working in the laboratory at Aurangabad. See, the first and most important thing, whatever starting materials we have chosen, they are commercially available, one thing, and they are available in the PG labs. Accordingly, we have designed the molecule, and on the basis of rational drug design approach, we have designed different kinds of small molecules. And the very first molecule I want to tell over here, this is simply 1,4-disubstituted 1,2,3 triazoles, and there is some ethereal linkage over there. Why that ethereal linkage? As several people are talking about the hydrophobic and hydrophilic part, as well as aromatic region is there and having a different kinds of substituents on aromatic substrates. Accordingly, we have designed the molecules and synthesized them very well from the commercially available phenols on propargylation by using propargyl bromide, potassium carbonate. It gives a terminal alkyne. Now we have one starting material, one type of starting material, and we need azides. Simple, these azides were prepared from commercially available benzaldehydes, which on reduction followed by substitution, and then nucleophilic substitution with sodium azide resulted into the corresponding benzyl azides. Now we have a set of alkynes and azides which are required for click reaction. Accordingly, these are terminal alkyne and benzyl azides on click reaction condition by using copper acetate tertiary butanol water at a room temperature. Just we have started, sir, 3 minutes before. See, under click condition, copper acetate tertiary butanol water resulted into the 1,4-disubstituted 1,2,3 triazoles. And these are the molecules which we have synthesized and characterized very well by means of spectroscopic techniques and screened these molecules for different kinds of biological activities. First, we have tested these molecules against anti-tubercular activity by using MTB S37 RA strain, as well as these molecules were screened for their antioxidant activity. And some of the molecules are displaying better anti-TB as well as antioxidant activity, and these are the most active compounds. And for the sake of students, this is our first publication in the year of 2015, based on simple starting materials, medicinal chemistry communications. See, to carry out this particular reaction, you doesn't need any specific reaction conditions. At room temperature, you can perform, but the problem is that you have to characterize all the molecules by means of spectral techniques, because all are new molecules. In our second attempt here, we have used a simple benzyl azides. Just a small modifications in azides. See, here amide-based azides were chosen, And these amide-based azides were synthesized from commercially available anilines, which on chloroacylation followed by nucleophilic substitution reaction with azides, sodium azide, resulted into the alpha azidoamides. And these alpha azidoamides on reaction with already synthesized phenol-based alkynes, in presence of copper catalyst, we have optimized all these reaction conditions, as well as by using some ionic liquids to faster the rate of the reaction, resulted into the corresponding 1,4-disubstituted 1,2,3-triazose in a less time with high yields. And these are the molecules. These are the molecules after characterization screened for their biological activity like antifungal and anti-tubercular activity as well as antioxidant activity. And the red data showing these molecules are having twofold or sometimes threefold more active than the standard drugs. In our next attempt, first we have started with simple phenol. Two azides we have used, one is benzyl azides and alpha azidoamides. In our next attempt, in place of phenol, again phenol is taken but orthohydroxyacetophenone. Because as we know how acetophenones can be used to make different kinds of molecules. Simple chalcones, Claisen condensation reaction we can use. And I think more than 1 billion chalcones are available in the literature. We have kept this ketone moiety and accordingly we have designed the molecules and synthesized from orthohydroxyacetophenone, which on propargylation, and already we have synthesized the benzyl azides under click chemistry condition resulted into the corresponding 1,4-disubstituted 1,2,3-triazoles having this ketone moiety is free. And you can elaborate this ketone moiety and Karde sir, I want to tell you, after reporting this particular molecule, many people have elaborated that ketone, including ourselves. Okay, these are all these molecules screened for their biological activity like antifungal and antioxidant activity. And see, as in terms of impact factor, when we thought this particular work we have to submit to Chinese chemical letters, the impact factor was that time 1.4. And now the impact factor is more than 9. More than 9. And this is the lottery we can say for getting publications in this journal. These are the most active compounds amongst this series. See, in first case phenol, second case orthohydroxyacetophenone, and in the third case, just we need phenolic OH group, and we know how to introduce phenolic OH group. Here we have taken the molecules which are having a coumarin scaffold. And why not to incorporate two pharmacophoric groups in a single molecular motif by using the concept of molecular hybridization may leads to more active compounds. Accordingly, we have designed the molecules C over here and synthesized from the commercially available phenols, that is the resorcinol, and the teachers knows very well, we are giving the experiment to the PG students as well as UG students. Pitchman condensation reaction, and every student is making a gram of this 7-hydroxy-4-methyl coumarin. Just we have collected that particular compound and just recrystallized and utilized for making terminal alkyne over here. This coumarin alkylation, and already we have synthesized benzyl azides under click chemistry condition, copper acetate, tertiary butanol water at room temperature resulted into the coumarin-based 1,4-disubstituted 1,2,3-triazose. In our next attempt, just again coumarin is there, but 4-hydroxy-coumarin. This is a commercially available, but we have made in bulk from phenol under cyclation condition reaction, and same type of molecules we have made, and these are the library of the molecules characterized very well and screened for their various biological activities like anti-TB, antioxidant, antibacterial activity as well as antifungal activity. And most of the compounds in terms of bacterial and fungi strains, they are showing better activity as compared to the standard drugs like ampicillin, kanamycin, chloramphenicol. And these are the most active compounds. Okay, here we have used benzyl azides. just a simple strategy, modification in terms of azide or modification in terms of alkynes. In our next attempt, this resorcinol on Winsmer-Huck formulation reaction, we have different kinds of salicylaldehyde. And this salicylaldehyde, hydroxysalicylaldehyde on novel condensation followed by cyclation resulted into the coumarin. And we have this free OH group which on alkylation, we have terminal alkyne. And benzyl azides already synthesized under click chemistry condition resulted into the coumarin-based 1,4-disubstituted 1,2,3 triazose. And these are the synthesized molecules and screen for their antifungal and antioxidant activity, and some of the molecules are showing equipotent activity against the fungal strain. Then, so far we have taken benzyl azides. Here small modification we have made. In place of benzyl azides, we have taken alpha azidoamides, which we have already synthesized. Means how one material, one molecule can be used for many reactions. See, accordingly we have designed the molecules, and see here, earlier this was, and here amide-based azides by using 2 coumarin-based alkynes. Accordingly, we have synthesized, as we already synthesized these alpha azidoamides and terminal alkynes under click chemistry condition resulted into the amide-based 1,2,3 triazose. These are the molecules and characterized very well and screen for their antifungal, anti-TB as well as antioxidant activity, and some of the compounds are showing 2-fold or 4-fold antifungal activity. However, none of the synthesized compound displays antitubercular activity. However, some compounds are showing good antioxidant activity. So far we have seen how to elaborate phenolic OH group. In our next attempt, simple chemistry, simple alkylation reaction, propargylation reaction, and we already synthesized azides, and why not to utilize those azides for making some new molecules. Here isatine, as we know isatine, this isatine is available in many drugs, and why not to elaborate that isatine into propargylamine, propargylated compound by using propargyl bromide, sodium hydride. Here we have to use a strong base. Under potassium carbonate condition, this never gives alkylated product. And this terminal alkyne on reaction with the benzyl azides under click chemistry condition resulted into the isatine-based 1,4-disubstituted 1,2,3 triazose. Here, in addition to benzyl azides, we have used aryl azides, simple by making diazotization followed by substitution reaction, resulted into the isatine-based 1,2,3 triazose, and these are the molecules characterized very well by means of spectral techniques and screen for their anti-TB, antioxidant as well as antifungal activity. After studying for isatine, just we have changed the molecule benzothiazinone. Actually, we have elaborated a lot this benzothiazinone, but I am showing here only one scheme. This benzothiazinone, again, it is available in many drugs, and why not to incorporate this 1,4-disubstituted 1,2,3 triazoles in a single molecule and may enhance the biological activity of that particular synthesized molecule. Okay, accordingly, we have made the molecules. See, this benzothiazinone can be made from commercially available orthoaminothiophenol, which on cyclization by using chloroacetic acid. This benzothiazinone on propargylation by using propargyl bromide, sodium hydride condition, here alkyne, and we already synthesized benzyl azides as well as aryl azides under click chemistry conditions at a room temperature resulted into the benzothiazinone based 1,2,3 triazose. And these are the molecules and a screen for their anti-TB activity as anti-TB activity against 2 strains. One is the MTB-S37RA and another one is the M-bovis BCG strain. And some of the compounds are showing a good anti-TB activity. In our next attempt, as routinely we are synthesizing thiazolidinone in the laboratory, even though PG students are making this particular molecule.
And just accordingly, we have collected those synthesized molecules from the PG students and elaborated into useful molecules. See over here, the designing strategy, this 2,4-thiazolone backbone is available in various anti-diabetic drugs. And triazole, we have seen triazole-based molecules displays various kinds of biological activity, and accordingly design these molecules and synthesized from this aromatic aldehydes as well as the thiazolinone via novel gel condensation reaction, followed by reaction with sodium hydride and propargyl bromide, resulted into the corresponding alkyne. We have only 3 alkynes we have made, and we already synthesized various kinds of benzyl azides under click chemistry condition, resulted into the incorporation of 2 pharmacophoric groups in a single molecular motif may enhances the biological activity, and accordingly these molecules having a different kinds of substituents, that is a fluoro, chloro, bromo, iodo type of substituents are there, and screen for their anti-inflammatory activity against the standard drug diclofenac sodium, and see our 2 compounds are equipotent or more potent as compared to the standard drug, that is a diclofenac sodium, as well as these synthesized molecules screen for antioxidant activity. However, none of the compound displays any kind of anti-tubercular activity. But as the compound is not displaying anti-tubercular activity, means the compounds may display better antibacterial activity. Accordingly, we have screened these molecules for antibacterial activity against the 6 strains of gram-positive bacteria, gram-negative bacteria, as well as antifungal activity. And this particular work we have published in 2 journals, as well as we have received 1 patent. See, these are the most active compounds. Now, as we know, there is a 1 marketed drug, that is isoniazid, very small molecule, and even though till today, after more than 80 years, till today that drug is used to cure TB. That is a first-line drug. Today, doctors are prescribing first-line drugs as well as second-line drug if the case is MDR TB or TDR TB, or combination of first-line and second-line drugs to cure the TB patients. Sir, just 5 minutes. And here, as we know, why not to make some derivatives of INH? Why not to make some derivatives of INH, not only INH, but related to INH-based molecules? Means we can call it here, INH requires a pyridine, but we have taken different kinds of derivatives, and accordingly we have made the molecules. See here, commercially available 4-hydroxybenzaldehyde, which on propargylation, furthermore reaction with the benzyl azides resulted into the 1,4-disubstituted 1,2,3-triazose, and we have free aldehyde. And why not to make some hydrazone type of molecules by using INH, that is isonicotinic acid hydrazide, nicotinic acid hydrazide, to compare the biological activity, why INH is a better drug as compared to nicotinic acid hydrazide as well as the para-nitrobenzoic acid hydrazide. These are the synthesizer molecules, and see the beauty. The compound 20A, 20D, 20G, 20J, these compounds are based on INH. And it is proved that INH is better anti-TB drug. And even though people have studied nicotinic acid hydrazide, but that doesn't display any kind of biological activity. See, in our next step, why not to introduce some tetrazole in triazoles? Means a total 7 nitrogens in a single molecule. It's difficult to handle this particular molecule, and it requires many steps. And just I will display this metanesidine, which on acylation followed by Wilsmer-Huck reaction, 2-chloro-3-formyl quinoline is there. Then nucleophilic substitution reaction with sodium azide, it uses a tetrazolo-quinoline aldehyde, which on reduction followed by methylation by using methyl chloride, and nucleophilic substitution with sodium azide, we have 1 terminal azide. And this terminal azide, tetrazolo-quinoline based terminal azide, and we already synthesized phenol based alkynes. Means why not to utilize those phenol based alkynes to make tetrazolo-quinoline based 1,4-disubstituted 1,2,3-triazose. Accordingly, we have made, and just simple phenylacetylene, which is commercially available. Why not to make the derivative of that one also, and accordingly we have made. And these are the molecules, and screen for these molecules for different kinds of activities, that is antibacterial, antifungal, and most of the compounds are displaying better antifungal as well as antibacterial activity as compared to the standard drug. These are the most active compounds. Just, sir, 3 minutes I'm taking, and because this is the last lecture, and I have to win the match. That's why I'm taking the time. Yeah. See, so far we have seen how to introduce one triazole moiety. Means we have considered only one alkyne and only one azide. We got 1, 2, 3 triazoles, monotriazoles. But here, why not to make a dimeric triazoles? Okay, and those dimeric triazoles may have some C2 symmetry. It is like a human body. And accordingly, we have designed the molecules. Commercially available resorcinol as well as a catechol. Which on propargylation by using propargyl bromide, 2 equivalents, we have terminal alkynes. And we have this resorcinol and catechol both under click chemistry condition by using copper sulfate, sodium ascorbate, and we have already synthesized amide-based azides and made the library of molecules. See, these are, I think, total 26 molecules are there, means 13, 26 molecules. Characterized very well, and it's difficult to characterize such kind of molecules by using H1NMR-C13 mass. And screen for their different kinds of biological activity. See, in our first, we have screened these compounds against MTB S37RV strain. None of the compound is showing better anti-TB activity. Only 1 or 2 compounds are showing good activity. Antifungal activity, most of the compounds, because this contains triazoles, and triazoles displays good antifungal activity. These compounds again screen for their antioxidant activity. Most of the compounds are showing antioxidant activity, better antioxidant activity. Not only this, but also we have studied anti-proliferative activity of some of the compounds against the 3 cell lines, and some few compounds are displaying better anti-cancer or anti-proliferative activity. See here, the most active compounds for anti-proliferative activity, anti-TB activity, anti-fungal activity, as well as we also studied this most active antifungal compounds for enzymatic study against the lanosterol 14 alpha demethylase elimination, and some of the compounds are showing better antioxidant activity. See, these are the most potent compounds. As I have shown you before ending my lecture, just I want to tell you, one series of compounds, 26 compounds are there. Once you have characterized it very well, and if you have screened for different biological activities, you may get better output. Our first publication in BMCL, we have shown only 10 compounds. Second publication in NJC, we have shown all 26 compounds. In the third publication, we have shown only antioxidant activity for all compounds, and displays and gives 3 excellent publications on this particular topic. Okay, before ending my talk, I am very much thankful to all the research scholars, those who have worked on this particular chemistry, 3 students. A part of their work, just I have shown over here, part of their work, because they have extended a lot by means of different kinds of starting materials. Not only research scholars, but also collaborators from various institutes, National Chemical Laboratory, BITS Pilani Hyderabad campus, then other peoples from Pune, as well as from Aurangabad, Chhatrapati Sambhaji Nagar. I'm very much thankful to all of them, as well as DST FIST, UGC SAP, CSR, UGC for financial assistance, as well as our university, Dr. Babasaheb Ambedkar Marathwada University. I'm very much thankful to all of you also, even though I thought before 1 hour, I thought today I could not able to deliver a lecture. But organizers have made this beautiful last session, and definitely I think I have won the match. Just display.
Okay. See?
Last slide.
Last slide.
Yes. See, just I want to tell you, when the Nobel Prize was declared on the 5th of October 2022, early morning I am thinking, today definitely I will receive something good message. Early morning. Because that day I don't know whether the Nobel Prize will go to Sharpless or some other people's, but I have some connection with the work or with the peoples. Because prior to that year, McDonald have received a Nobel Prize, and I met in the year of 2014. Okay, and next year, 2022, I thought, even though, Karde sir, I'm not attending the duties that time, but I thought definitely I will get something. And from that day, I decided why not to compile our contribution of more than 35 research articles on the concept of click chemistry. I have made one book separate in the year of 2022, December 2022, and later on, we have published more than 25 research articles on this concept, and just I have shown over here whatever contribution made up to 2022. With this, thank you very much for giving me some additional time. Yeah, thank you. And definitely I welcome the questions from students as well as researchers, and we are ready to make some collaborations, those who are interested with us.
Thank you, Professor Singade, for excellent deliberation on triazoles through click chemistry. And I would just have a simple one question to take, and after that I think we will end this session.
See, please. I got your question. Many times such questions are asked. Yeah. Yeah, many times. Why you are using copper acetate in place of copper sulfate? Why you are using copper oxide nanoparticles also? Many times these questions. See, this copper is used to activate the alkyne. As you go through the mechanism of this particular reaction, activation of alkyne, because alkyne is inactive. And to make activation of that alkyne in the form of organocopper type of compound, means that negatively charged acetylene type of moiety and copper is there, and to react with the azides. Actually, when you use copper sulfate, then it requires reducing agent, that is sodium ascorbate. And when we use copper acetate, there is no need. And you can compare the rate of reaction by using copper sulfate, it requires longer reaction time. When we use copper acetate, it requires shorter reaction time. Okay? Yeah, please. Yeah, because participants should listen your question.
Yes, sir. For almost you have synthesized 90 compounds by using copper acetate. Yeah. But for bis triazole synthesis, why you use copper sulfate and ascorbate? Because under the same condition, why you not synthesize this? This is the first one. And in the last slide, you mentioned some 2-amino 3-cyano compounds. So in that case, if you use aryl azide, so why not tetrazole was synthesized instead of triazole?
Yeah, Professor Banerjee have asked 2 questions. One is why you have shifted towards copper sulfate rather than copper acetate?
Different compounds?
Not 90, sir. So far we have made 1,500 new triazoles. So far we have claimed those in different 50 publications. Even though, see, the reactivity wise, alkynes and azides are same, somewhat same. If we use copper sulfate, which is a cheaper, and copper acetate is having a high cost. No, it doesn't matter. Copper acetate also works, sir.
But you mentioned only copper sulfate.
No, I have not. Yeah, I have shown over here copper sulfate, but both can work very well. Okay. No issue. And your second question regarding why not to make tetrazoles. Yeah. That chemistry is a different, sir. Yeah. In the slide, see, not only working on this particular system, whatever some molecules are there, we have made some triazole-based aldehydes. Okay, I am disclosing that chemistry also. Triazole-based aldehydes like aromatic aldehydes, benzaldehyde. And we have made a triazole and aldehyde, like a pyridine carbaldehyde. We have made triazole-based aldehydes via click chemistry by using aryl azides and propargyl alcohol. We will have a triazoline methanol, which on oxidation, we will have aldehyde, and then we have made several chromin derivatives. And then, yes, first we have made triazoles. Yeah. And that work I have not shared yet. Yeah, more than 20 publications on that chemistry. Yeah.
Thank you, everyone. I know it was a very interesting topic and many delegates must have many questions, but you can discuss during the dinner time because Professor Singate will be present. So before I felicitate Professor Singate, I would just like to make an announcement. The cultural event will be here just 10 minutes after the end of this session for the arrangement. So please be here and enjoy, after a long deliberation of scientific things, it is time to relax and let us be ready to enjoy the cultural event. And on behalf of the organizing committee, I would like to felicitate Professor Singate with a small token of love.
I am, sir, just a minute, sir. I am thankful to Dr. K.K. Sharma for chairing the session, and as a token of appreciation, I would like to give him a bouquet. We are going to start the cultural program in a short while. Please stay here for some time. I require a few volunteers to make the stage arrangement.
हेलो।
सारी बस्ती कदमों में है, ये भी एक फनकारी है। सारी बस्ती कदमों में है, ये भी एक फनकारी है, वरना बदन को छोड़ के अपना जो कुछ है सरकारी है। सारी बस्ती कदमों में है, ये भी एक फनकारी है, वरना बदन को छोड़ के अपना जो कुछ है सरकारी है। और अब फिरते हैं हम रिश्तों के रंग बिरंगे जख्म लिए। अब फिरते हैं हम रिश्तों के रंग बिरंगे जख्म लिए। सबसे हंसकर मिलना जुलना बहुत बड़ी बीमारी है। सबसे हंसकर मिलना जुलना बहुत बड़ी बीमारी है। और कश्ती पर आंच आ जाए तो हाथ कलम करवा देना। कलम यानी कटवा देना। GOLD-CT 2024 की इनॉगरल सेरेमनी, कल्चरल प्रोग्राम और वैल्यूटी फंक्शन, इन तीनों की कश्ती मैं लेकर के चल रहा हूं। कश्ती पर आंच आ जाए तो हाथ कलम करवा देना। लाओ मुझे पतवारें दे दो, मेरी जिम्मेदारी है। मौसीकी, आवाज, अंदाज, अल्फाज, जज्बात और एहसास की दुनिया के परस्तारों को इस नाचीज और खाकसार प्रोफेसर, डॉक्टर, इंजीनियर गयास उस्मानी का प्यार भरा आदाब। दोस्तों, मुझे अपना इंट्रो इसलिए देना पड़ता है कि दो चार बार बड़ी अजीब अजीब घटनाएं हुई सर। मानेकशॉ सेंटर, बहुत से लोग आप जानते होंगे, इंडिया की जो टॉप मोस्ट 5 जगह हैं कन्वेंशन सेंटर्स कॉन्फ्रेंसेस के लिए, उसमें से एक। अल्लाह का शुक्र है मैं सब में प्रोग्राम कर चुका हूँ। मानेकशॉ सेंटर में एक किस्सा मेरे साथ हुआ। मैंने प्रोग्राम ऐसे ही शुरू किया और जाकर के पीछे बैठा तो एक साहब आए, उनके साथ 3-4 और लोग थे, बहुत बड़े देखने में लग रहे थे हाथ उससे। कहने लगे सर, उस दिन 17 तारीख थी, कहने लगे सर आप दिल्ली में कब तक हैं? मैंने कहा मैं 18 को जा रहा हूँ। बोले आप थोड़ा सा रुक जाएं सर, 19 को जो पेमेंट ये कर रहे हैं उससे 10-12 गुना कर दूंगा, कोई दिक्कत नहीं। अब मैं उनसे क्या बताता कि OTI की कॉन्फ्रेंस जिसका मैं मेंबर हूँ, मैं वो काम फ्री में कर रहा था। और 10-12 गुना। बहरहाल ये एक एक्सपीरियंसेस। लाइट का अरेंजमेंट लगभग हो गया है और हम कार्यक्रम कुछ ही देर में आपके समक्ष शुरू करने वाले हैं। मुझे ऐसा लगता है कि 30 साल से ज़्यादा, 34 साल तक मैंने पढ़ाई के काम में लगा और HBTI कानपुर से मैंने BTech, MTech और PhD किया और उसके बाद 89 से लेकर के 94 तक मैं वहाँ पर लेक्चरर भी रहा। HBTI कानपुर इस बार की NIRF जो रैंकिंग है NIRF की, उसमें भारत के 10 इंजीनियरिंग कॉलेजेस में से एक है HBTI कानपुर। और उससे ज़्यादा फ़ख्र की बात मुझे ये है कि HBTU अब हो गई, वो पहले HBTI कानपुर थी। तो HBTU के अलावा 10 में से 9 IITs हैं। हम इकलौते पूरे इंडिया में एक स्टेट गवर्नमेंट का इंजीनियरिंग कॉलेज जो NIRF रैंकिंग में 10 में से एक कॉलेज है, उसका मुझे फ़ख्र है। वहीं से मैंने बीटेक, एमटेक और PhD किया है, और मैं केमिकल का आदमी हूँ, इसलिए केमिस्ट्री की कॉन्फ्रेंसेस में मुझे बहुत अच्छा लगता है। तो उम्मीद करता हूँ कि हमारी केमिस्ट्री ऐसे ही जैसे पहले रही है ऐसे ही चलती रहेगी। आइए, उन्होंने कहा कि अभी 3-4 मिनट और लगेंगे, मैं आपसे थोड़ी और बातचीत कर लूं। अर्ज कर रहा हूं कि सुला चुकी थी ये दुनिया थपक थपक के मुझे, सुला चुकी थी ये दुनिया थपक थपक के मुझे, और जगा दिया तेरी पाजेब ने खनक के मुझे। सुला चुकी थी ये दुनिया थपक थपक के मुझे, और जगा दिया तेरी पाजेब ने खनक के मुझे। और दोस्तों, ताल्लुकात में कैसे दरार पड़ती है, ताल्लुकात में कैसे दरार पड़ती है, दिखा दिया किसी कमजर्फ ने छलक के मुझे। ताल्लुकात में कैसे दरार पड़ती है, दिखा दिया किसी कमजर्फ ने छलक के मुझे। और तुम्हें खुद अपनी ही महफिल संवारनी होगी। नौजवानों, आप इस शेर को गौर से सुने। शायरी में फिलॉसफी भी है बैकग्राउंड में बहुत ज़्यादा। एक एक शेर से आपको बहुत कुछ सीखने को मिलता है। अपने सीनियर्स से, बाकी लोगों से सीखिए कि ताल्लुकात में कैसे दरार पड़ती है, दिखा दिया किसी कमजर्फ ने छलक के मुझे। और तुम्हें खुद अपनी महफिलें संवारनी होंगी, बता दिया ये एक जुगनू ने चमक के मुझे। बता दिया ये एक जुगनू ने चमक के मुझे। और बता दिया ये एक जुगनू ने चमक के मुझे, और सभी की नजरें हमारी तरफ थी महफिल में। सभी की नजरें हमारी तरफ थी महफिल में। इशारा कर दिया उसने जरा सरक के मुझे। इशारा कर दिया उसने जरा सरक के मुझे। आइए, इस खूबसूरत महफिल में सारी तैयारियां ऑलमोस्ट हो चुकी हैं। कुछ ही देर में हम कार्यक्रम की विधिवत शुरुआत करेंगे। हर नजर को निगाह का हक है। हर नजर को निगाह का हक है। हर एक दिल को आह का हक है। हर नजर को निगाह का हक है। हर एक दिल को आह का हक है। और हम भी सीने में दिल को रखते हैं। हम भी सीने में दिल को रखते हैं। हमको भी एक गुनाह का हक है। हमको भी एक गुनाह का हक है। Friends, as all of you know, the delegates have come from not only all over India, but even from abroad to attend this international conference. और discussions, deliberations, presentations, इन सब के बीच में जो हमारे दिल और दिमाग पर एक धूल सी बढ़ जाती, धूल से नहीं कहेंगे, थोड़ी देर के लिए उठना बहुत ज़रूरी होता है, उसे हटाने का काम हम इन कार्यक्रमों के ज़रिए करते हैं। और उस कोशिश में मुझे पूरी उम्मीद है हम कामयाब रहेंगे, और आप डिनर के बाद जब कल दोबारा यहाँ आएंगे तो वैसे ही फ्रेश उसी तरह से, ऐसे हम पूरी उम्मीद करते हैं। आइए अब आज के इस कार्यक्रम की पहली प्रस्तुति, कार्यक्रम का प्रारंभ हम करने जा रहे हैं महाराष्ट्र गीत द्वारा। चेतन शिंदे, एमएससी सेकेंड, स्कूल ऑफ केमिकल साइंसेस, और उनके साथ विजय राज जाधव तबले पर, और ये भी एमएससी सेकेंड के स्टूडेंट हैं। इंस्ट्रूमेंटलिस्ट के लिए एक बार पहले से तालियां बजा दीजिए।
हेलो।
और डॉक्टर गुरव, हमारा जो म्यूजिक डिपार्टमेंट है उसके प्रोफेसर हैं, वो इस वक्त आपके समक्ष हारमोनियम पर। सो प्लीज गिव अ बिग हैंड टू ऑल ऑफ देम। और अब मैं तुमसे दरख्वास्त नहीं, आदेश करूंगा, गुरु हूं आखिर, इस कार्यक्रम की प्रारंभ करें।
थैंक यू सर। महाराष्ट्र माझा गरजा, महाराष्ट्र माझा जय जय महाराष्ट्र माझा गरजा, महाराष्ट्र माझा जय जय महाराष्ट्र माझा गरजा, महाराष्ट्र माझा रेवावरदा कृष्ण कोयना भद्रा गोदावरी, रेवावरदा कृष्ण कोयना भद्रा गोदावरी, एक पणाचे भरती पाणी मातीच्या घागरी, भीमतडीच्या तटानाया तटानाया, भीमथडीच्या तटानाया यमुनेचे पाणी पाजा, जय महाराष्ट्र माझा गरजा, महाराष्ट्र माझा जय जय महाराष्ट्र माझा। आसमानीच्या सुलतानीला जवाब देती जिभा, आसमानीच्या निजतानीला जवाब देती जिभा सह्याद्रीचा सिंह गरजतो सिंह गरजतो सह्याद्रीचा सिंह गरजतो शिवशंभू राजा दरी दरीतून नाद गुंजला महाराष्ट्र माझा जय जय महाराष्ट्र माझा गरजा महाराष्ट्र माझा जय जय महाराष्ट्र माझा गरजा महाराष्ट्र माझा गरजा महाराष्ट्र माझा गरजा महाराष्ट्र माझा जय महाराष्ट्र.
किसी भी प्रोग्राम में, किसी भी आयोजन में अगर आगाज अच्छा होता है तो अंजाम अपने आप खूबसूरत हो जाता है. बेहतरीन शुरुआत इस कार्यक्रम की. और जैसा कि हम जानते हैं हर कॉन्फ्रेंसेस में हम परफॉर्मिंग आर्ट्स के सभी स्वरूप प्रस्तुत करने की कोशिश करते हैं और इंटरनेशनल कॉन्फ्रेंसेस में डांस की, नृत्य का बहुत अधिक महत्व है. तो अब हम गणेश वंदना पर आधारित एक नृत्य आपके सामने प्रस्तुत करने जा रहे हैं. हवा ने फूल को चूमा तो खुशबू ने जन्म लिया, पानी ने किनारे को चूमा तो लहरों ने जन्म लिया, उंगलियों ने साज को चूमा तो संगीत ने जन्म लिया, किसान ने धरती को चूमा तो फसल ने जन्म लिया, और जब पायल ने पैरों को चूमा तो नृत्य ने जन्म लिया. आइए आपके सामने एक बेहद खूबसूरत सा नृत्य पेश करने जा रही हैं. एमएससी सेकेंड ईयर की स्टूडेंट फ्रॉम स्कूल ऑफ केमिकल साइंसेज आरती नेहते.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि. गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसदाराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डखण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्पाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि
Wonderful. Friends, as all of you know, one of the greatest gifts of our country to the world is yoga. I went to Seattle 2-3 years back, and I found the portrait of some of our yoga gurus in many health clubs over there. So today, in this program, we have specially invited the students from K.K. Patil Institute of Yoga and Naturopathy. They are the students of Dr. Anita Patil, and they are going to present before you rhythmic yoga. सूर्य स्तुति आपके सामने ये सभी छोटे नन्हे बच्चे करेंगे. किसी भी उस पर कोशिश करिएगा तालियां बजाने के लिए कि इनकी परफॉर्मेंस अच्छी रहे. कोच हैं दीपक पाटिल और इनके साथ साथ ऋतुश्री सोनकी, जानवी सोमानी, मानदा चौधरी, वैभवी, वैष्णवी, हर्षाली और ऐश्वर्या. तो अब आपके सामने प्रस्तुत है रिदमिक योगा.
महापापहरं देवं
प्रचोदयात् ॐ भूर्भुवः स्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात् ॐ भूर्भुवः स्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात् ॐ भूर्भुवः स्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात् तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात् ॐ भूर्भुवः स्वः तत्सवितुर्वरेण्यं भर्गो
चोरी से छुप छुप के मैंने चोरी से छुप छुप के तिनका चुन के सपना एक बनाया डोरी से बुन बुन के मैंने डोरी से बुन बुन के टुकड़ा टुकड़ा सी के सपना एक बनाया टुकड़ा टुकड़ा सी के सपना एक बनाया सपने रे सपने मेरे सच हो जाना रे हो जाना रे हो जाना रे सपने रे सपने मेरे सच हो जाना रे हो जाना रे हो जाना रे
नज़्म नज़्म सा मेरे होठों पे ठहर जा
मैं ख्वाब ख्वाब सा तेरी आंखों में जागूं रे, तू इश्क इश्क सा मेरे रूह में आके बस जा, जिस ओर तेरी शहनाई उस ओर मैं भागूं रे। हाथ थाम ले पिया, करते हैं वादा, अब से तू आरज़ू, तू ही है इरादा। मेरा नाम ले पिया, मैं तेरी रुबाई, तेरे ही तो पीछे पीछे बरसात आई, बरसात आई। तू इत्र इत्र सा मेरे सांसों में बिखर जा, मैं फकीर तेरे कुर्बत का, तुझसे तू मांगू दे। तू इश्क इश्क सा मेरे रूह में आके बस जा, जिस ओर तेरी शहनाई उस ओर मैं भागूं रे। लिफाफे में तेरा खत है जानिया, तेरा खत है जानिया, ना चीज ने कैसे पाली किस्मत ये जानिया वे। ओ मेरे दिल के लिफाफे में तेरा खत है जानिया, तेरा खत है जानिया, ना चीज ने कैसे पाली जन्नत ये जानिया वे। तू नज़्म नज़्म सा मेरे
डॉक्टर अनीता पाटिल न सिर्फ जलगांव, न सिर्फ खानदेश, न सिर्फ महाराष्ट्र, लेकिन भारत की एक जानी मानी योगा कोच हैं। इस इंस्टीट्यूट की डायरेक्टर आज किसी वजह से नहीं हैं हमारे बीच में, वरना मुझे बड़ा फ़ख्र होता है। हर एक महीने डेढ़ महीने में मुलाकात अपनी होती रहती है कार्यक्रमों में, लेकिन आज दीपक उनके कोच यहाँ पर मौजूद हैं। बच्चों के लिए और सब के लिए एक बार जोरदार तालियां। थैंक यू, थैंक्स अ लॉट, थैंक यू। और आइए अब एक डुएट डांस आपके सामने पेश करेंगी ऐश्वर्या पाटिल और निकिता पाटिल, दोनों स्कूल ऑफ केमिकल साइंसेस की एमएससी सेकेंड ईयर की स्टूडेंट हैं। और एक ज़रूरी अनाउंसमेंट, अभी आपके सामने योगा की इतनी अच्छी परफॉर्मेंस हुई, कल सुबह 7 बजे योगा का सेशन होगा कन्वोकेशन हॉल में, तो आप सबको वहाँ पर आना है। और आप जिस तरह से यू हैव एक्सेप्टेड इट, आई एम प्रेटी श्योर कि आप सब अधिक से अधिक तादाद में वहाँ पर पहुँचें कन्वोकेशन हॉल में कल सुबह 7 बजे। तो लीजिए प्रस्तुत है ये नृत्य।
नदीच्या पल्ल्याड आईचा डोंगर, नदीच्या पल्ल्याड डोंगर यंगून उघड देवी दार नदीच्या पाण्यावर आगीन फुलत नदीच्या पाण्यावर आगीन फुलत तुझ्या नजरेच्या तालावर काळी झुलत तुझ्या नजरेच्या तालावर काळी झुलत नाद आला ग जीवाच्या घुमराला नाद आला ग जीवाच्या घुमराला गेला ती भंडार दूर लोटून दे अंधार आलो दुरून रांगून डोंगर यंगून उघड देवी दार लल्लाटी भंडार दूर लोटून दे अंधार आलो दुरून रांगून डोंगर यंगून उघड देवी दार भंडार दूर लोटून दे अंधार आलो दुरून रांगून डोंगर यंगून उघड देवी दार लल्लाटी भंडार दूर लोटून दे अंधार आलो दुरून रांगून डोंगर यंगून उघड देवी दार
Beautiful and ultimate. And the way you applauded for it, it should be appreciated. Because after all, they are all MSc students doing their practicals, doing their viva, doing their classes, everything, making their journals, all the things they are doing, and then they are performing. It should be appreciated. I'm highly thankful to all of you. अब मैं आवाज़ देने जा रहा हूँ एक और गीत के लिए. चेतन शिंदे एमएससी सेकेंड के स्टूडेंट हैं एसओएससीएस के स्कूल ऑफ केमिकल साइंसेस और उनका साथ देंगे युवराज जाधव तबले पर. ये एक बहुत ही प्यारा सा भजन आपके सामने प्रस्तुत करने वाले हैं. ये कह कह के हम दिल को बहला रहे हैं, ये कह कह के हम दिल को बहला रहे हैं, वो अब चल चुके हैं, वो अब आ रहे हैं. खबर है आ रहे हैं, जस्ट विद इन फ्यू सेकेंड्स दे आर कमिंग ओवर हियर. खा लो। तो आइए, उनका इंतज़ार करने से बेहतर है कि मैं अब आवाज़ दूं एमएससी सेकेंड ईयर की गर्ल स्टूडेंट्स को, जो कि स्कूल ऑफ केमिकल साइंसेस से हैं। वो इस नृत्य के जरिए आपको पूरा भारत भ्रमण कराने जा रही हैं। आसाम, गुजरात, महाराष्ट्र, राजस्थान, तमिलनाडु, इन सभी स्टेट्स का आपको भ्रमण कराने जा रही हैं। मानसी देसले, हर्षाली मोरे, अश्विनी निकुंज, वैष्णवी काले, मोहिनी पाटिल, सोनल ठाकरे, नेहा महाजन, गायत्री पाटिल, भाग्यश्री, अश्विनी, वैष्णवी और आरती नेते। तो आइए अब हम चलते हैं और देखते हैं पूरा हिंदुस्तान, भारत भ्रमण, हमारा महान देश।
यह रंगों का देश है। यहाँ विविधता में एकता और एकता में विविधता है। यहाँ की संस्कृति ही इसकी धरोहर है। तो आइए देखते हैं इस संस्कृति की कुछ झलकियां।
मौसम आएंगे फिर चिनार की शाखों पे, पंछी घर अपना बनाएंगे। इन राहों से जाने वाले फिर लौट के वापस आएंगे। फिर जन्नत की गलियों में सब लोग ये नगमा गाएंगे। रिंद पोशमाल गिंदने गाए लो लो।
रिंद पोशमाल गिंदने गाए लो लो। रिंद पोशमाल गिंदने गाए लो लो।
सरगम के मीठे मीठे सुर घोलो।
है आया हूँ मैं प्यार का ये नगमा सुनाने, सारी दुनिया को एक सुर में सजाने, सबके दिलों से नफरत को मिटाने। आओ यारो मेरे संग संग बोलो।
रिंद पोशमाल गिंदने गाए लो लो।
सबके दिलों से नफरत को मिटाने। आओ यारो मेरे संग संग बोलो।
रिंद पोशमाल गिंदने गाए लो लो।
धिन कड़ाक आजा उड़ के सराट, पैरों से बेड़ी जरा खोल। नगाड़े संग ढोल बाजे धाय धाय धम धम धाय। नगाड़े संग ढोल बाजे धाय 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 धम धाय। ये धिन कड़ाक आजा उड़ के सराट, पैरों से बेड़ी जरा खोल। नगाड़े संग ढोल बाजे धाय धाय धम धम धाय। नगाड़े संग ढोल बाजे धाय 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 धम धाय। लटपट कमर दामिनी अधर रागिनी हो, लटपट कमर दामिनी अधर रागिनी मेरे दर आई कैसे सजी धजी देखो मेरे पिया की सावरी जिया से बावरी मेरे अंगना में देखो आज खिला है चाँद। ये बाजे धुन झम झम झमाके झाम तो नाचे मन झम झम झमाके झाम, ये बाजे धुन झम झम झमाके झाम तो नाचे मन झम झम झमाके झाम। लटपट कमर दामिनी अधर रागिनी मेरे दर आई कैसे सजी धजी देखो मेरे पिया की सावरी जिया से बावरी मेरे अंगना में देखो आज खिला है चाँद। ये बाजे धुन झम झम झमाके झाम तो नाचे मन झम झम झमाके झाम, ये बाजे धुन झम झम झमाके झाम तो नाचे मन झम झम झमाके झाम। पिंगा ग पोरी पिंगा ग पोरी पिंगा ग पोरी पिंगा, पिंगा ग पोरी पिंगा ग पोरी पिंगा ग पोरी पिंगा।
चैताकीचे त्वाल्या शिवजी का बागवान सची फूल फुल्या छना, अरे फूल फुल्या छना, हाँ फूल फुल्या छना। तिरो रेशमी रुवाला शचे मुंड मधारूच्या तिरो घाशी बुगाडुवा, हात मधारूच्या तिरो रेशमी रुवाला सचे मुंड मधारूच्या तिरो घासी बुगाडुवा, मला रेशमी रुमाला भावरा केले पोथला उडेले पोथला उडेल्या हा
कैसी लगी आपको भारत की विविधता में एकता की ये तस्वीर?
इक्का तेरा नाम है साजा,
तुझ पे वार न 100 वारी जान में तेरे कुर्बान मेरी माँ। वंदे
हेलो जी। ये सफर चंद मीलों में मत बांटिए, ये सफर चंद मीलों में मत बांटिए, जिंदगी को कबीलों में मत बांटिए। ये सफर चंद मीलों में मत बांटिए, जिंदगी को कबीलों में मत बांटिए। एक नदी की तरह है हमारा वतन, इसको तालाब झीलों में मत बांटिए। फ्रेंड्स, ये लड़कियां हैं और गर्ल्स ही ऐसा कर सकती हैं, क्योंकि जिनको परफॉर्म करना था वो दोनों बॉयज कुछ वजहों से यहां पर नहीं थे। इनको मैंने अचानक कहा एंड द वे दे हैव परफॉर्म। प्लीज गिव अ बिग हैंड टू ऑल ऑफ देम। लड़की हूं, कर सकती हूं, ये नारा मैंने मंच पर कई बार सत्य होते हुए देखा है, कई बार सत्य होते हुए देखा है। एंड आई एम एक्सट्रीमली हैप्पी दैट दे हैव परफॉर्म सो वेल टुडे। हेलो चेक। और अब वो दोनों लोग जिन्होंने बस मिस कर दी थी आ गए हैं, और आपकी इजाजत हो तो उनको मैं यहाँ पर आवाज दूं। देखिए, तबला बजाने के लिए हमारे बीच में मौजूद हैं श्री विजय राज जाधव, जो कि एमएससी सेकेंड ईयर के स्टूडेंट हैं, और उसके बाद जिनकी आवाज एक बार आप पहले भी सुन चुके हैं, चेतन शिंदे। ये भी एमएससी सेकेंड के स्टूडेंट हैं, स्कूल ऑफ केमिकल साइंसेज से। आपके सामने एक भजन प्रस्तुत करने जा रहे हैं, चेतन शिंदे।
हेलो। एका जनार्दनी शरण येते माहेरची आठवण, येते माहेरची आठवण, येते माहेरची आठवण। माहेर पंढरी आहे भीवरीच्या तीरी, आहे भीवरीच्या तीरी। माझे माहेर पंढरी, माझे माहेर पंढरी आहे भीवरीच्या तीरी, आहे भीवरीच्या तीरी। बाप आई, बाप आई, माझी विठ्ठल रखुमाई, माझी विठ्ठल रखुमाई, माझी विठ्ठल रखुमाई। माझे माहेर पंढरी, माझे माहेर पंढरी आहे भीवरीच्या तीरी, आहे भीवरीच्या तीरी। भंगा करीत से पाप भंगा करीत से पाप भंगा माझे माहेर पंढरी माझे माहेर पंढरी आहे भीवरेच्या तीरी पुंडलिक राहे बांधू पुंडलिक राहे बांधू त्याची ख्याती काय सांगू त्याची ख्याती काय सांगू त्याची ख्याती काय सांगू माझे माहेर पंढरी माझे माहेर पंढरी आहे भीवरेच्या तीरी आहे भीवरेच्या तीरी एका जनार्दनी शरण एका जनार्दनी शरण 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 एका जनार्दनी शरण येते माहेरची आठवण येते माहेरची आठवण येते माहेरची आठवण माझे माहेर पंढरी माझे माहेर पंढरी आहे भीवरेच्या तीरी आहे भीवरेच्या तीरी
थैंक यू वेरी मच। देर आए दुरुस्त आए, आप दुरुस्त आए। बहरहाल आइए अब हम इस कार्यक्रम को आगे बढ़ाते हैं। कवित्री बहनाबाई चौधरी उत्तर महाराष्ट्र विद्यापीठ जलगांव की एक परंपरा है, कोई कॉन्फ्रेंस कोई प्रोग्राम हम जब भी कोई चीज़ ऑर्गेनाइज करते हैं दूसरे स्कूल्स दूसरे डिपार्टमेंट्स को उसमें हमेशा इन्वॉल्व करते हैं, राइट फ्रॉम डायरेक्टर टू स्टूडेंट्स एंड इवन नॉन टीचिंग एम्प्लॉयज़ ऑफ दैट डिपार्टमेंट। तो आइए एक गेस्ट आर्टिस्ट हमारे बीच में इस वक्त आ रही हैं। स्कूल ऑफ कंप्यूटर साइंसेज में बीएससी सेकेंड ईयर की स्टूडेंट हैं और सानिका खरवे वो आपके समक्ष एक बहुत ही प्यारा सा गीत प्रस्तुत करने जा रही हैं। फिल्म दिल से का ये गीत कहना ही क्या। स्टेज पर बहुत ही अच्छी परफॉर्मेंस रहती है इस गीत की, आप सब लुत्फानंदोज होंगे ऐसी मुझे उम्मीद है। सानिका।
हेलो। गम सम गप्पे चुप, गम सम गप्पे चुप, गम सम गप्पे चुप, गम सम गप्पे चुप। हलचल हो गई तेरी, होठ है तेरे चुप, खलबल हो गई तेरी, बैठे है क्यों तू चुप। प्यारे प्यारे चेहरे लेकर दे दिया इशारा, देखा तेरी आंखों ने है सपना कोई प्यारा। हमसे गोरी ना तू शर्मा, कह दे हमसे जरा, हमसे गोरी ना तू शर्मा, कह दे हमसे जरा। कहना है क्या ये नैन का अनजान से जो मिले, चलने लगे मोहब्बत के ऐसे ये सिलसिले। अरमान ऐसे दिल में खिले जिनको कभी मैं ना जानूं, वो हमसे हम उनसे कभी ना मिले, कैसे मिले दिल ना जानो। अब क्या करे क्या ना मिले, कैसे उन्हें मैं पुकारूं। कहना है क्या ये नैनिक अनजान से जो मिले, चलने लगे मोहब्बत के ऐसे ये सिलसिले। अरमान ऐसे दिल में खिले जिनको कभी मैं ना जानूं। वो हमसे हम उनसे कभी ना मिले, कैसे मिले दिल ना जानूं। अब क्या करे क्या ना मिले, कैसे उन्हें मैं पुकारूं। गम पामागा गम पामानी सानी पानी सानी पमा पागा सागा मा पागा मानी पागा मारे सा सा नि सा नि सा ग सा नि सा ग सा नि सा ग सा ग सा ग सा ग सा नि पपा मग। पहले ही नजर में कुछ हम कुछ तुम हो जाते हैं यूं गुम। नैनों से बरसे रिमझिम 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 प्यार का सावन। शर्म थोड़ी थोड़ी हमको आए तो नजरें झुक जाए, सितम थोड़ा थोड़ा हम पे शौक हवा भी कर जाए। ऐसे चले आंचल उड़े दिल में एक तूफान उठे, हम तो लुट गए खड़े ही खड़े। कहना ही क्या ये नैनिक अनजान से जो मिले, चलने लगे मोहब्बत के ऐसे ये सिलसिले। अरमान ऐसे दिल में खिले जिनको कभी मैं ना जानूं। वो हमसे हम उनसे कभी ना मिले, कैसे मिले दिल ना जानूं। अब क्या करे क्या ना मिले, कैसे उन्हें मैं पुकारूं। शुक्रिया।
मैं तो बुलबुल हूँ, मैं तो बुलबुल हूँ, मेरा काम है गाते रहना। मैं तो बुलबुल हूँ, मेरा काम है गाते रहना, और भूल जाऊं तो मुझे याद दिलाते रहना। बहुत ही खूबसूरत, विदाउट एनी सपोर्ट। आजकल तो कैराके है, इतनी तरह की चीजें हैं, ट्रैक रहता है, उस सबके रहते हुए तुमने सिर्फ अपनी आवाज में इतनी अच्छी परफॉर्मेंस करी। बहुत आगे जाओगी, हम सबका आशीर्वाद तुम्हारे साथ है। थैंक यू, थैंक्स अ लॉट। Friends, as all of you know, GOLD-CT-2024 is being organized to pay our tribute to Professor P.P. Mahulikar, ex-Pro Vice Chancellor of KBC NMU Jalgaon and ex-Director of the School of Chemical Sciences. Sir, जिस तरह से यहाँ पर बच्चे आकर के परफॉर्म कर रहे हैं, मुझे बहुत अच्छा लग रहा है कि this particular evening and the conference throughout the day is a success throughout, and that is because of your efforts in bringing this particular, not only school, but our university to this level. Salute to you, sir. Thank you very much, sir, for your benign presence on this occasion today. और आइए अब मैं आवाज दूं एक डांस के लिए। समृद्धि कारंकल, जो कि MSc सेकेंड ईयर की स्टूडेंट हैं और स्कूल ऑफ केमिकल साइंसेज में, वो महाभारत की थीम पर आपके सामने एक नृत्य प्रस्तुत करने जा रही हैं।
सत्य असत्य कलेश कलंक सात की कथा परमार
वंडरफुल, एक्सीलेंट। और आइए अब मैं आपके सामने आवाज दूं। विजय राज जाधव एमएससी सेकेंड ईयर के स्टूडेंट हैं स्कूल ऑफ केमिकल साइंसेज में, और ये आपके समक्ष बांसुरी पर बहुत अच्छी धुन बजाने वाली हैं। मैं आपको बताता चलूं कि रोनू मुजुमदार, चौरसिया साहब, इन सब के प्रोग्राम्स मैंने कंपेयर किए हैं। बांसुरी एक ऐसा साज है, ऑर्केस्ट्रेशन में 10-12 गिटार हो सकते हैं, 12-15 कांगो हो सकते हैं, ढोलके 4-5-6 हो सकती हैं, लेकिन बांसुरी सिर्फ एक रहती है। हमने सुनी है कृष्ण कन्हैया की बांसुरी, राधा के प्यारे बंसी बजैया की बांसुरी। हमने सुनी है कृष्ण कन्हैया की बांसुरी, राधा के प्यारे बंसी बजैया की बांसुरी, और राधा सखी से बोली मैं श्री कृष्ण हो गई। राधा सखी से बोली मैं श्री कृष्ण हो गई, धर के अधर पे बंसी बजैया की बांसुरी। आइए सुनते हैं ये खूबसूरत साज बांसुरी।
हेलो।
थैंक यू।
बेहतरीन, प्लीज युवराज। जो कल्चरल फेस्टिवल्स होते हैं, ऑल इंडिया इंटर यूनिवर्सिटी कल्चरल फेस्टिवल्स, उनके अंदर म्यूजिकल इवेंट में आज तक की मजबूरी है कि हम इंस्ट्रूमेंटलिस्ट बाहर से ले जाते हैं। इंडिया की 90% यूनिवर्सिटीज बाहर से लेकर के जाती हैं, लेकिन जजेस उस टीम को अधिक पॉइंट भी देते हैं, तारीफ भी करते हैं, और अच्छा माना जाता है जहां पर स्टूडेंट ही एज इंस्ट्रूमेंटलिस्ट आए। तबला आपके सामने कितना अच्छा बजाया, बांसुरी आपके सामने बजाई। ऐसे लोगों की हमें कद्र करनी चाहिए, क्योंकि सिंगर्स आसानी से मिल जाते हैं, डांसर्स आसानी से मिल जाते हैं, सबसे ज़्यादा मुश्किल होती है इंस्ट्रूमेंटलिस्ट की। ऐसे ही करते रहो, इसी तरह से करते रहो, सबकी शुभकामनाएं तुम्हारे साथ हैं। आइए अब मैं आवाज़ दूं केथन मालखेड़े, जो कि स्कूल ऑफ केमिकल साइंसेज में प्रोजेक्ट स्टूडेंट हैं IPR सेल में। वो आपके सामने आज के इस कार्यक्रम में परफॉर्मेंस करने जा रहे हैं। एक गीत कराके पे आपके समक्ष प्रस्तुत करेंगे, इनकी हौसला अफजाई करिएगा।
सोचेंगे तुम्हें प्यार करके नहीं, सोचेंगे तुम्हें प्यार करके नहीं, ये दिल बेकरार करके नहीं। ख्वाबों में छुपाया तुमको, यादों में बसाया तुमको, ख्वाबों में छुपाया तुमको, यादों में बसाया तुमको। मिलोगे हमें तुम जन्म कहीं ना कहीं, सोचेंगे तुम्हें प्यार करके नहीं, ये दिल बेकरार करके नहीं। तुम हो खिलता महका सा कवल, हम जो गाए तुम हो वो गजल। कमसिन भोला सा मुखड़ा, लगती हो चांद का एक टुकड़ा। हम कितनी तारीफ करे देख के तुमको आहे भरे, तुम सा नहीं है कोई प्यारा सनम, प्यारा सनम। सोचेंगे तुम्हें प्यार करके नहीं, ये दिल बेकरार करके नहीं। हे हे हे
तुम्हें प्यार करके नहीं, ये दिल बेकरार करके नहीं। ख्वाबों में छुपाया तुमको, यादों में बसाया तुमको, ख्वाबों में छुपाया तुमको, यादों में बसाया तुमको। मिलोगे हमें तुम जन्म कहीं ना कहीं, सोचेंगे तुम्हें प्यार करके नहीं, ये दिल बेकरार करके नहीं। हे ला 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 ला, हे
केतन, इनकी खूबसूरत आवाज को सुनकर मुझे लगा कि अपना ट्रेडमार्क शेर इनके हवाले कर दूं कि तुझसे मिलती जुलती मैं आवाज कहां से लाऊंगा, तुझसे मिलती जुलती मैं आवाज कहां से लाऊंगा। ताजमहल बन जाए मगर मुमताज कहां से लाऊंगा। Congratulations, wonderful performance, congratulations. Friends, अब आइए मैं आवाज दूं स्कूल ऑफ केमिकल साइंसेस के MSc सेकेंड ईयर के गर्ल्स एंड बॉयज का कंबाइंड ग्रुप, और ये आपके सामने एक बहुत ही अच्छा सा मैसेज लेकर के आ रहे हैं एनवायरनमेंट के बारे में। सेव ट्री एंड सेव द नेचर, being presented by the students of MSc second year of the School of Chemical Sciences.
जननी जन्मभूमेच्च स्वर्गादपि गरीयसी, अर्थात माँ और धरती इनके समक्ष स्वर्ग और स्वर्ग का वैभव भी शून्य है। क्या हम अपनी पृथ्वी को वही सम्मान, प्यार, संरक्षण दे पा रहे हैं? देखते हैं धरती माँ का क्या कहना है।
मैं धरती हूँ, मैंने इंसान को जीने के लिए वृक्ष, जल और वायु दिया है। किसी कवि ने मुझे इन पंक्तियों में कितना प्यारा कल्पित किया है।
हरी हरी वसुंधरा पे नील नील ये गगन, कि जिससे बादलों की पालकी उड़ा रहा पवन। दिशाएं देखो रंग भरी, दिशाएं देखो रंग भरी, चमक रही उमंग भरी। ये किसने फूल फूल पे, ये किसने फूल फूल पे किया सिंगार है। ये कौन चित्रकार है, ये कौन चित्रकार, ये कौन चित्रकार है।
ये कौन चित्रकार है, ये कौन चित्रकार।
इसी निसर्ग से हमें प्यार और दोस्ती का पैगाम भी मिलता है।
गुनगुना रहे हैं भंवर खिल रही है कली कली, गुनगुना रहे हैं भंवर खिल रही है कली कली,
गली गली
कली कली
गुनगुना रहे हैं भंवर खिल रही है कली कली। जरा देखो सजन बेईमान भौरा कैसे मुस्कान,
आए कलियों शर्माए घूंघट में गोरी जैसे छुप जाए,
रुत ऐसी हर कैसी ये पवन चली गली गली, गुनगुना रहे हैं भंवर खिल रही है कली कली,
गली गली
कली कली
गुनगुना रहे हैं भंवर खिल रही है कली कली।
राहु केतु क्या हुआ? सरदार, फैक्ट्री बनाने के लिए जमीन और लकड़ा कहाँ से आएगा? वसुधैव कुटुंबकम। हा 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 हा। ये जमीन आसमां हमारे ही तो है। हा 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 हा। हमारे जंगल कब काम आएंगे? जाओ जंगल काट दो, जमीन भी मिल जाएगी और लकड़ा भी।
पर ये गांव वाले जंगल काटने नहीं देंगे।
गांव वाले काट दो उन्हें भी पेड़ों के साथ। सरदार, जिंदा लोगों को काट दे? हाँ, काट दो जिंदा गांव वाले। राहु, चलो इन पेड़ों को काट दे।
रुको, तुम ये क्या कर रहे हो? तुम इन पेड़ों को ऐसे नहीं काट सकते। अगर काटना है तो इन पेड़ों के साथ हमें भी काटना होगा।
आपको ये बता दें कि ये प्रतिकृति भारत के उत्तराखंड में घटित सत्य घटना से प्रेरित है, जहां अपने सत्ता और धन से दंडित राजा ने कई लोगों को वृक्षों के साथ ही काट दिया। देखते हैं 40 साल बाद क्या हो रहा है।
सरदार, फिर एक परेशानी है। फैक्ट्री का कचरा और धुआं कहाँ जाएगा? भूल गए राहु। वसुधैव कुटुंबकम। कचरा नदियों में और धुआं आसमान में जाएगा। चलो केतु।
और इस तरह शुरू हुआ धरती मां पर इंसानियत का अत्याचार।
प्रचंड बोल मस्तकों के झुंड, आज जंग की घड़ी की तुम गुहार दो। आन बान शान या की जान का हो दान, आज एक धनुष के बाण पे उतार दो। आरंभ है प्रचंड बोल मस्तकों के झुंड, आज जंग की घड़ी की तुम गुहार दो। आन बान शान या की जान का हो दान, आज एक धनुष के बाण पे उतार दो। आरंभ है प्रचंड। विश्व की पुकार है ये भागवत का सार है कि युद्ध ही तो वीर का प्रमाण है। कौरवों की भीड़ हो या पांडवों का नीड़ हो, जो लड़ सका है वो ही तो महान है। जीत की हवस नहीं, किसी पे कोई वश नहीं, क्या जिंदगी है ठोकरों पे मार दो। मौत अंत है नहीं तो मौत से भी क्यों डरे, ये जाके आसमान में दहाड़ दो।
ये तो आशा की लहर है, ये तो उम्मीद की सहर है, खुशियों की लहर है, खो न जाए ये तारे ज़मीं पर, खो न जाए ये तारे ज़मीं पर, तारे ज़मीं पर।
A wonderful performance by all these participants. Snehal, Neha, Aishwarya, Renuka, Nikita, Manasi, Devyani, Vaishali, Mayur, Amar Singh, Nilesh Patil, Chetan Shinde, and then we have got Murli, Vishal, Nikhil, Hitesh and Vijay Raj. एक सब के लिए एक बार तालियां बजाइए. बहुत ही खूबसूरत प्रस्तुति. सोच रहा हूं अब की लगाऊं एक पीपल एक आम का पेड़. सोच रहा हूं अब के लगाऊं एक पीपल एक आम का पेड़, और पीपल से तो छांव मिलेगी, आम है बेहद काम का पेड़. सोच रहा हूं अब के लगाऊं एक पीपल एक आम का पेड़, पीपल से तो छांव मिलेगी, आम है बेहद काम का पेड़, और लोग ईश्वर को खुश करने को जाने क्या क्या करते हैं. लोग ईश्वर को खुश करने को जाने क्या क्या करते हैं. मेरा बस इतना कहना है, एक खुदा के नाम का पेड़. दोस्तों, हमारे एनवायरनमेंट के बारे में, पर्यावरण के बारे में इन एमएससी के स्टूडेंट्स ने बहुत अच्छी तरह से यहाँ पर हम सबको न सिर्फ समझाया, बल्कि हमारे दिल में ये बात पैदा की कि हम सबको पर्यावरण के लिए काम करना चाहिए. और आइए अब एक बहुत ही पारंपरिक कला आपके सामने लेकर के आ रहे हैं. हमारे एमएससी सेकेंड ईयर के स्टूडेंट स्कूल ऑफ केमिकल साइंसेस के ऋषिकेश वानखेड़े, और ये आपके सामने प्रस्तुत करेंगे लाठी बाजी. देखिए, एक पारंपरिक कला जिसे हमारे नौजवान आपके सामने पेश करने जा रहे हैं.
अंजलि जंब पर वादवसु अंब पर रावण स अंब पर रघुकुल राज है। पौन बारी बाह पर शंभुरति नाह पर जो सहस बाह पर राम गिजराज है।
चीता मृगशुंड पर भूषण में तुंड पर जैसे मृगराज है।
तेजतम अंश पर खंडजनी कंस पर धूमलिच्छ वंश पर शेर शिवराज है।
जय भवानी जय भवानी जय शिवाजी जय शिवाजी जय भवानी जय भवानी जय शिवाजी जय शिवाजी।
राजाल राजाल जिंकुनिया जगभरी शिवबा राज नाव गाजली निगत वारगात कान भाळा भरी शिवबा राज टंक वाजली घडण वाज मराठीचे गणिन ब्राह्मणी खातली कंचा काळ भी करूच्या माझे आमच्या भाराने ठासली राजाल राजाल जिंकुनिया जगभरी शिवबा राज नाव गाजली। माझा राजा हे माझा शिवराज हे माझा राजा हे माझा शिवराज।
रिया, आपकी तालियों के लिए। मैं जानता हूं आप यहां पर जितने लोग बैठे हैं, इस वक्त तक बैठे हैं, वो सभी कलाकारों की इज्जत करना जानते हैं। और हम कलाकार ये बात मानते हैं कि जिस दिन इस दुनिया में फनकारों की इज्जत होना बंद हो जाएगी, उस दिन फूलों से महक चली जाएगी, डालियों से लचक चली जाएगी, गुंचों से चटक चली जाएगी, पायलों से झनक चली जाएगी, चूड़ियों से खनक चली जाएगी। हुजूर, चेहरों से चमक चली जाएगी, जिंदों के बदन जल जाएंगे, मुर्दों के कफन जल जाएंगे और ये दुनिया नस्त नाबूद हो जाएगी। इसलिए तालियां बजाते रहिए, हौसला अफजाई करते रहिए, क्योंकि आपकी तालियां ही एक जर्रे को आफताब बनाती हैं, एक किरण को महताब बनाती हैं। और आज के इस कार्यक्रम में परफॉर्म करने वाले आर्टिस्ट पूरी दुनिया में अपना नाम करते हैं। तो लीजिए, अब आपके सामने हम एक नृत्य प्रस्तुत करने जा रहे हैं। पूर्वी बाविस्कर, जो कि केंद्रीय विद्यालय की छात्रा है, उसके साथ गर्ल्स का पूरा ग्रुप है एमएससी फर्स्ट ईयर का, एक रीमिक्स सॉन्ग बॉलीवुड का आपके सामने पेश करने जा रहे हैं। इस ग्रुप डांस में ये सब
पधारो साधु मरणी चिलवान पलम धरो गुरर गुरर गुरनाव आस मारो जीवड़ो घणो हिचकावे ओ घबरावे मन में भावे मारो बाजलो भवन मन भावे चमक चम बाजे बायल बाजे भाई सनेरे चमक चमक घुघरा बाजे आओ साधु मरणी चिलवान आओ साधु मरणी चिलवान
ढोला वाले ठाट घूमर 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 घूमे घूमर 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 कैसा घूमर घूमे धिन तड़ाक आजा और के सराट पैरों से बीड़ी जरा खोल नगाड़ संग ढोल बाजे धाय धाय धम धम धाय नगाड़ संग ढोल बाजे धाय 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 धम धाय धिन तड़ाक आजा और के सराट पैरों से बीड़ी जरा खोल नगाड़ संग ढोल बाजे धाय धाय धम धम धाय नगाड़ संग ढोल बाजे धाय 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 धम धाय
तो शुरू करें।
कब मैंने ये सोचा था, कब मैंने ये जाना था, कब मैंने ये सोचा था, कब मैंने ये जाना था, तुम इतने बदल जाओगे, तुम इतना मुझे चाहोगे, तुम इतना प्यार करोगे, तुम यूं इकरार करोगे, मेरे महबूब, मेरे महबूब, मेरे महबूब, मेरे साथ। शुक्रिया मेहरबानी करम, मेरे महबूब मेरे सनम, शुक्रिया मेहरबानी करम।
Bring the drum.
हेलो 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 चेक। बेटा पूर्वी और ग्रुप के और लोग भी आ जाएं प्लीज। आप भी आ जाइए, 2-3 आ जाइए। आज सुबह भाविस्कर साहब मुझे घर लेने के लिए आए। पूर्वी उसी गाड़ी में मेरे बगल में बैठी थी। इन्होंने जैसे ही बताया तो मैंने कहा, पूर्वी तुम्हारा नाम मेरी लिस्ट में है। और वो कॉन्फिडेंस देखिए, उसका कॉन्फिडेंस उसी वक्त डेवलप हुआ। जिस तरह से मैंने कहा कि तुम्हारा नाम मेरी लिस्ट में है, बहुत बड़ा काम किया तुम लोगों ने। बच्चों के छोटे हाथों को चांद सितारे छूने दो। बच्चों के छोटे हाथों को चांद सितारे छूने दो। 4 किताबें पढ़कर ये भी हम जैसे हो जाएंगे। भास्कर साहब बहुत ही अच्छा इसने किया। वो एक बात है, उससे ज्यादा तारीफ तुम लोगों की करना चाहूंगा। तुमने इस बच्ची को ग्रुप में एडजस्ट किया, इसका कॉन्फिडेंस बढ़ाया. इट इज़ अ वंडरफुल परफॉर्मेंस, इट्स अ यूनिक परफॉर्मेंस. इन सब के लिए आप तालियां बजाइए. ऐसे ही करते रहो बेटा. कीप डूइंग लाइक दिस ओनली. बहुत अच्छा, वंडरफुल, एक्सीलेंट. इट शुड बी अप्रिशिएटेड लाइक एनीथिंग. नाउ फ्रेंड्स, आई एम गोइंग टू, अब उस्ताद को आवाज़ देनी है. डॉक्टर मनोज गुरव, डिपार्टमेंट ऑफ आर्ट्स एंड ह्यूमैनिटीज़ में फैकल्टी हैं. हर कार्यक्रम में, हर प्रोग्राम में हमारा साथ देते हैं. आज हमने इनसे गुजारिश करी कि इस मौके पर एक गीत आपके सामने प्रस्तुत करें. बहुत ही प्यारा सा गीत है, आप सब सुनेंगे. अच्छा, किशोर कुमार का क्लासिक है ये, पल पल दिल के पार तुम.
हेलो, थैंक यू सर.
तुझको देखा था मैंने अपने आंगन में, जैसे कह रही थी तुम मुझे बांध बंधन में. एक ऐसा रिश्ता है, एक ऐसे सपने हैं, बेगाने होकर भी क्यों लगते अपने हैं. मैं सोचता रहता हूँ, डर डर के कहता हूँ, पल पल दिल के पास तुम रहती हो. तुम समझोगी दीवाना, मैं भी इकरार करूं। दीवानों की ये बातें दीवाने जानते हैं, जलने में क्या मजा है परवाने जानते हैं। आकर ख्वाबों में पल पल दिल के पास तुम रहती हो। जीवन में की प्यार एक कहती हो, पल पल दिल के पास तुम रहती हो। थैंक यू।
थैंक यू, थैंक्स अ लॉट। फ्रेंड्स, आजकल मोबाइल का ज़माना है। जो बाहर बैठते हैं और जो अंदर बैठते हैं उनके बीच में मोबाइल से बात होती रहती, खाना शुरू हो गया कि नहीं हो गया, कहाँ आ रहे हो, क्या हो रहा है। मैं आपको बता दूं कि बाहर वाले आपको जितना भी अट्रैक्ट कर रहे हो, आप बिल्कुल सही जगह पे बैठे हैं। क्योंकि एक मल्टी कोर्स डिनर के बाद जब एक एक करके स्वीट डिशेस शुरू होती है ना, तो उसका मज़ा और अलग होता है। अब ये स्वीट डिशेस आपके सामने आ रही हैं, और उन स्वीट डिशेस को अगर आप मिस कर देते, बाहर होते, तो बाद में आपको अफसोस होता। आइए अब मैं इस कार्यक्रम में आवाज़ दूं चेतन शिंदे और सानिका खरवे, जो कि एमएससी सेकेंड ईयर की स्टूडेंट्स हैं। एक बहुत ही प्यारा सा गीत लेकर आपके सामने, डुएट्स, दो गाने हमारी भारतीय फिल्मों की एक शान है। कई साल पहले मैं सिएटल गया था यूएस में, वहाँ के लोगों से मैं बात कर रहा था। उनको पता चला कि मैं थोड़ा सा इस फील्ड में हूँ, तो बातों बातों में उन्होंने कहा कि इंडियन फिल्मों के बारे में जो हमें सबसे ज़्यादा अच्छी चीज़ लगती है वो ये कि हीरो हीरोइंस तालाब के किनारे, झील के पास, पहाड़ के पास, पेड़ के पास एक दूसरे के साथ जिस तरह से डांस करते हैं वो यूनिक। आइए देखते हैं, सुनते हैं ये दो गाना।
हेलो हेलो
हेलो लिखता हूँ तुझे रोज जरा सा, तू मेरी है प्रेम की भाषा। लिखता हूँ तुझे रोज जरा सा, कोरे कोरे कागज जिन पे बेकस, कोरे कोरे कागज जिन पे बेकस लिखता हूँ ये खुलासा। तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा। तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा।
तू मेरी है प्रेम की भाषा, लिखती हूँ तुझे रोज जरा सा, तू मेरी है प्रेम की भाषा, लिखती हूँ तुझे रोज जरा सा, कोरे कोरे कागज़ जिन पे बेकसे, कोरे कोरे कागज़ जिन पे बेकसे, लिखती हूँ ये खुलासा, तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा, तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा।
अभी अभी धूप थी यहाँ पे लो, अभी बरसातों की धारा, ये बहकाली प्यार किसी को से, आओ कर ले गुजारा।
कभी कभी आईने से पूछा है किसी ने रूप सवारा, कभी रब मोहिनी, कभी रब चांदनी, कभी चमकीला सितारा,
कितना संभल ले
बच कर चल ले,
दिल तो ढीठ आवारा, तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा, तुमसे मिले दिल में उठा दर्द करारा, जीने लगा वो ही जिसे इश्क ने मारा।
थैंक यू।
थैंक यू।
थैंक यू वेरी मच। जैसा मैंने कहा कि 3 डिशेस शुरू हो गई हैं, 2 डिशेस बस बाकी हैं। उससे पहले मैं एक बहुत बड़ा फर्ज अपना निभाना चाहता हूं। किसी भी कार्यक्रम में आप कितनी भी तालियां बजाते रहिए, वो बहुत अच्छी बात है, लेकिन आखिर में हम उन लोगों को याद करते हैं जो पर्दे के पीछे होते हैं। और पर्दे के पीछे जो लोग हैं, उनमें से मैं सबसे पहले आवाज दूंगा बेंद्रे मैडम को और जंगले मैम को। ये वो लोग हैं जिन्होंने इस कार्यक्रम को स्वरूप दिया है। प्रोफेसर डॉक्टर आर.एस. बेंद्रे एंड डॉक्टर आशा जंगले, इन लोगों की मेहनत का नतीजा है कि ये कार्यक्रम यहाँ पर आपके सामने आया। साथ ही साथ बेहतरीन लाइट और साउंड का कोऑर्डिनेशन आज यहाँ पर किया। प्रोग्राम में लाइट और साउंड का बहुत बड़ा महत्व होता है। रहे ना, यहीं रहे मैम, प्लीज 1 मिनट रहे ना 1 मिनट बस। तो मैं उनको यहां पर आवाज देना चाहता हूं। रुपेश महाजन, जगदीश असीजा और अक्षय ब्रजवाले। इनके पास वो होता है जो आप सोच नहीं सकते, हम जानते हैं। हाथी की आवाज चींटी में बदलने का हुनर इनके पास होता है। बहुत ही खूबसूरत आपने आज साउंड ऑपरेशन किया, इसके लिए आपका बहुत बहुत धन्यवाद। आपने इस कार्यक्रम को बहुत अच्छी तरह से निभाया करा, जिसके लिए हम आपका धन्यवाद देते हैं और आगे भी ऐसी उम्मीद करते हैं। थैंक यू वेरी मच, थैंक्स अ लॉट। और अब जैसा कि पहले भी कहा जा चुका है, ठीक 8 बजे, अभी कार्यक्रम में 2 गीत होने बाकी हैं, ठीक 8 बजे सुबह कल ब्रेकफास्ट शुरू हो जाएगा। और ब्रेकफास्ट के बाद 8:45 पर आप सबको यहाँ पर इकट्ठा होना है। ठीक 9 बजे कीनोट एड्रेस होगा इस कॉन्फ्रेंस का। जैसा कि आप सब जानते हैं, पद्मश्री डॉक्टर जी.डी. यादव उस कीनोट एड्रेस को 9 बजे से 9:30 बजे के बीच में वो एड्रेस है। तो आप सब उस वक्त यहाँ मौजूद रहिए और उसके बाद आपको पता है कॉन्फ्रेंस ऐसा चलेगी। तो कल समय पर आप 8 बजे अपने ब्रेकफास्ट के बाद यहाँ पर वक्त पर आ जाइए 8:45 पर, ताकि 9 बजे उस की नोट एड्रेस में हम सब लोग मौजूद रहें। और अब आज के इस कार्यक्रम की आखिरी परफॉर्मेंस, अ ग्रुप डांस बाय द स्टूडेंट्स ऑफ स्कूल ऑफ केमिकल साइंसेस।
अरे वाजर बडोल क्या चला बँड वाले सीताराम भाऊ आवरले शाबास What? शाबाश विकी भाग्यानी पावरी उन्नी बरका वाजाड बँड वाला दे दणका विकी भाग्यानी पावरी उन्नी बरका वाजाड बँड वाला दे दणका विकी भाग्यानी पावरी उन्नी बरका वाजाड बँड वाला दे दणका अब नाचूय पोरी लाव ठुमका आसावरी नाशे दणका नाचूय पोरी लाव ठुमका आसावरी नाशे दणका विकी भाग्यानी पावरी उन्नी बरका वाजाड बँड वाला दे दणका चंद्रानी कोर सुपारी चक्रीदार दारवर चंद्रानी कोर अब सुपारी चक्रीदार दारवर चंद्रानी कोर सुपारी चक्रीदार दारवर चंद्रानी कोर तुळस हिरवीगार गारदेव नवरदेव वर तुळस हिरवीगार गारदेव नवरदेव वर अरे हानमारी हिंदी मूल तू न तोल बोल मनी साळू की मैना हिंदी ना मूल तू न तोल बोल मनी साळू की मैना वडेल ना बजारी चाल चाल मनी साळू की मैना आज जंगना बेजारी चाल चाल म्हणी साळू की म्हैना गावना बेजारी चाल चाल म्हणी साळू की मैना चंदन पुरीले चाल चाल म्हणी साळू की मैना बिंदीना मूल तुना बोल बोल म्हणी साळू की मैना बिंदीना मूल तुना बोल बोल म्हणी साळू की मैना फिर कर कर मैं गड्याला काटा फिर कर कर अब गड्याला काटा फिर कर कर मैं गड्याला काटा फिर कर कर सही तुन वरवन एष्टी वर मैं सही तुन वरवन रिक्षावर वरवन एष्टी वरमन सईतून वरवन रिक्षावर घड्याळा काटा फिर कर गरमन घड्याळा काटा फिर कर गरमन शाबाश अरे हानबाई
और अब पैर थक गए हैं, आवाजें भर्रा गई हैं, गीत चुप हो गए हैं, गजल खामोश हो गई है और रात की तारीकी दिन की तमाम रौनकों को अपनी बाहों में कैद करना चाहते हैं। चलते चलते ये वादा रहा आपसे, फिर मिलेंगे अभी बाखुदा आपसे, कोई शिकवा शिकायत न लब पर रहे, कर चले दोस्तों अलविदा आपसे। शुक्रिया, मेहरबानी, शब खैर, गुड नाइट, जय महाराष्ट्र, जय भारत, जय जगत।
एक मिनिट सगळ्यांनी लक्ष द्या। वसतिगृहातल्या मुलींसाठी आम्ही सगळ्या मोठ्या लोकांनी सह्या दिलेल्या आहेत।